In this demo, we'll work with the Insights feature on Power BI when you use Power BI reports in Microsoft Fabric. This is part of the Power BI experience available in the Fabric Unified Data Analytics platform. The Insights feature uses artificial intelligence to automatically analyze your data and find hidden patterns, such as anomalies, trends, and key drivers. It works by running statistical and machine learning algorithms in the background to identify significant changes or correlations that you may have missed. In this demo, we'll work with the Power BI experience on Microsoft Fabric. We'll set up the Fabric workspace and load data first. Before we dig deeper into insights on specific visuals, we'll trigger Quick Insights on the dataset. Quick Insights is a feature in the Power BI service that automatically analyzes an entire dataset to find hidden patterns. We'll then move on to a more specific visualization, that is our baseline visualization that we'll use to generate insights on our data. We'll make use of the Get Insights feature on the visualization that will generate contextual insights based on what the visualization displays. We'll then explore the insights in some detail and understand why each of these insights were discovered by Power BI. Now, in any kind of visualization, let's say you're viewing sales or profits over time or sales or profits across categories, these will likely result in increases or decreases. We'll use the Explain Increase Decrease feature to understand why these increases or decreases occurred. That sums up our demo that will span several videos. Let's start with the very first step, where we set up the Fabric workspace and load data. Microsoft Fabric is a unified all-in-one analytics platform from Microsoft that brings together data engineering, data science, data warehousing, and business intelligence into a single cloud-based service. Now, where does Power BI fit in here? Well, in the business intelligence bit. Power BI is one of the core components or experiences within Microsoft Fabric. You can, of course, use Power BI locally as before using the desktop app, but here in this first demo, we'll use Power BI on Microsoft Fabric. Head over to app.fabric.microsoft.com, and here you'll need to log in with your Microsoft account. Please be aware that you need an organizational Microsoft account, one that's associated with your company. Now, you might say your organization doesn't use Microsoft Fabric. How will you have a Fabric account? Well, you can just create one if one doesn't exist, and you will be given a very generous free trial. That free trial will allow you to perform most of the demos in this journey. There'll be a few demos for which you need a paid Fabric capacity. I'll explain that when we get to that. But for the most part, the free trial is more than sufficient. I have my Microsoft organizational account and I have a free trial set up. So that's what I'm going to use to log in. Go ahead, specify your username and password and sign in to Fabric. Now, this is what the Fabric homepage looks like. In the center pane, you have a number of actions that you can perform to get started. You can ingest data into Fabric, build a lakehouse. These are all Fabric components, and we'll use some of these components later on in this journey. On the left, you have icons giving you quick access to Fabric features. At the bottom left, notice you can see the Fabric icon. This shows you that you are in the Fabric experience of Microsoft Fabric. The Fabric experience is primarily for data engineers and data scientists. Now, if you're a data analyst, what you're looking for is the Power BI experience. Click on the icon on the bottom left and switch to Power BI. Fabric handles everything from raw data ingestion and storage to complex data engineering and science. Power BI is the final step in that setup. It acts as the business intelligence and visualization layer. This is where you turn all of the data that you process in Fabric into interactive reports and dashboards for end users. And here we are in the Fabric experience. The home view for the Fabric experience will be a little different. Now, since I regularly use this account, you can see some of the items that I frequently open. Your view might be different if you're a first-time user. At the top right, you can see that I'm using a Fabric free trial. It says 7 days left, but I've noticed that Microsoft is very liberal and it extends the free trial almost indefinitely. This initial free trial is a 60-day free trial and it does get extended. This is what I've seen from experience. You'll need a work or a school account to be able to make use of this free trial. Now, all of the computation that you perform on Microsoft Fabric, any data ingestion that you perform, any transformation, any processing task has to run on some compute resource somewhere. That compute resource is a Fabric capacity. With Microsoft's 60-day free trial for Fabric, you get a 64 capacity unit trial capacity, where a capacity unit is just the metric that Microsoft uses to measure the amount of computing power available to your organization. The trial period has given me a trial capacity that's more than sufficient for a majority of the demos in this course. However, some of the premium features like Microsoft Copilot are only available in a paid capacity, and for that, I'll show you how you can set one up. Now, in order to do anything within Microsoft Fabric, let's say you want to upload data and create a Power BI report, you need to create a workspace. This Fabric workspace is the central collaborative environment where teams create, organize, and manage all of their analytics items. Think of this as your shared project folder. Now, if you worked with Power BI before, a Fabric workspace is the evolution of a Power BI workspace. And it still holds all your Power BI content, reports, dashboards, and semantic models, but it can also hold all the new Fabric items. We're not going to be collaborating with anyone, but we do need a workspace in order to get going. And I call the workspace Looney Workspace Power BI. If you click on the advanced section here, you'll be able to see the licensing mode for this workspace, and we've selected the trial license. You can select Power BI specific licenses here, Pro or Premium per user, or if your organization's administrator has created a Fabric capacity, you'd select this option that's currently grayed out at this point in time, Fabric capacity, and use that capacity to run all your compute. The Fabric capacity is just a compute resource. You can scroll down and see here at the bottom that we are currently using the trial capacity. This is absolutely free for anyone with a Microsoft Work or School account. Go ahead and apply this, and this will create our workspace. And this is what an empty workspace looks like. This is where we'll be storing all of the assets that we use in this journey, from reports to lakehouses to deployment pipelines to metrics and scorecards and real-time event assets. At this point, we have a Fabric workspace and we've transformed and loaded our data into that workspace. We are now ready to view quick insights on our data. Quick Insights automatically analyzes an entire dataset via its semantic model to find hidden patterns. You run it on a dataset, and Power BI's AI runs various statistical algorithms to rapidly generate a whole different number of visuals showing outliers, trends, correlations, and even seasonality. Quick Insights is a fast way to discover interesting data points before you even start building a report. Quick Insights serves as an excellent unbiased starting point for discovering relationships you may not have known to look for. Here we are in our Fabric workspace in our Superstore folder, and we have our Superstore model, the semantic model for our Superstore data. Click on the three dots next to the model, and here you'll find an option to get quick insights. Go ahead and click on that option. You'll wait a few seconds, and soon the insights will be available. And you can click on View Insights to view a Power BI report with all of the insights that Power BI's artificial intelligence has generated. Now, let's say you'd like to view insights after you've generated them. You can click on the same three dots, and instead of Get Insights, you'll find an option for View Insights. And that's where you'll always find your generated insights available. But for now, we'll click on View Insights and take a look at the different charts and visuals that Power BI found interesting. The first chart here is a donut chart, postal code by category. This shows you a split of the proportion of postal codes served by different categories: office supplies, furniture, and technology. All of these visuals are interactive. Here you can see the technology category serves 18.48% of the postal codes, office supplies 60.3%, and for furniture it's too small, you can't really tell. You can hover over the important terms in the narrative here to figure out what kinds of aggregations were applied on the column to get this result. This donut chart was generated by applying a count aggregation on the postal code column. Next, we have profit by city, and this is a bar chart. Off to the right, you can see the simple AI generated narration. New York City has noticeably more profit. And off the bars, you can see New York City's bar is the tallest. Here, profit is about $62,000 for New York City. You can hover over the individual bars and see profit by different cities. And if you scroll down here to the very bottom, you'll find the loss making cities. And how was this visual computed? If you hover over profit, this is sum of profit categorized by city. The next important insight that Quick Insight has generated is sales by state. And here you can see that the state of California has the highest total sales. And you can hover over this and see it's almost 500,000, 457,000. New York comes second, and then there's Texas, Washington, Florida, Illinois, and so on. And as you scroll down, you can see that in North Dakota, West Virginia, and Maine, this particular superstore doesn't have very many sales. Along with donut charts and bar charts, Quick Insights generates other kinds of charts as well, such as scatter plots. Now, I left the row ID column in my dataset, and Quick Insights thought it was important for some reason. Row ID is just a unique identifier for the individual orders records, so the shape of the scatter plot doesn't really make that much sense, but the outliers are interesting. The narrative tells you that for certain ship dates, March 21st, 2014, March 15, 2016, and April 28, 2016, the records had outliers in sales. These outliers are marked in orange. Since row ID is a unique identifier for a row, it's pretty clear that there are certain orders where the sales were huge. Those are the outliers that you see here. You can see sales were almost $20,000 or $10,000 in certain situations. Here is a visual that's not really relevant, row ID and quantity. This kind of just serves to tell us that not all insights generated by Quick Insights are equally useful. Certain insights may not make sense at all. Here is a donut chart that does make sense. Remember, the row ID individually identifies records in our dataset. This chart shows you the proportion of orders using different ship modes. The narrative tells us standard class accounts for the majority of row ID, and then we have first class, second class, and same day shipping is a very small proportion. And let's hover over row ID to see how this particular chart was generated. The aggregation applied was count of row ID categorized by ship mode. There are many different insights here, and all of them are very easy to interpret. I leave it to you to explore those on your own. Here is a slightly different visual, a line chart, which shows you sales by category. Now, a line chart may not be the best representation of this, but it still gives us information. Our superstore has a vast majority of its sales in the technology category, then office supplies, then furniture. As you scroll through these various charts from Quick Insights, if there's any one that you're particularly interested in, you can always click on that chart and that will take you to focus mode. Focus mode expands the chart to fill the entire screen so you can dive down deeper and understand the chart better. You also get filters off to the right that you can use to drill down further based on dimensions that you're interested in. Well, that's it. That's our quick overview of the Quick Insights AI feature that Power BI has to offer. Now, this feature is not available in Power BI Desktop. It's only available on Power BI Service. Something you should keep in mind. Quick Insights has given us a brief idea of what our data looks like. We are now ready to create a report, set up a visual, and generate insights based on that visual. That's what we'll do in the next video. We have our workspace. In this video, we'll see how we can get our data into the Power BI service on Fabric. Now, if you'd like to keep your workspace organized, it makes sense for you to create a folder within which you place all assets that are related. Here, I'm going to work on the Superstore dataset, and I'm going to create a new folder here called Superstore. So all of the assets related to this particular dataset, I'll place within this folder within my workspace. Now, if you'd like to create any asset within Fabric, you'll find the create icon off to the left. You can always click on that. Or you can use the new item option that you can see just below the name of the workspace. So I click on create on the left sidebar. And since I'm in the Fabric experience, Fabric realizes that I likely want to set up a report. and it shows me a bunch of actions related to that. So you can access data from Excel files, CSV files, you can manually paste in data, or you can create a report by picking a published semantic model. A semantic model is just a logical layer of business friendly information that sits between your raw data and your Power BI reports. We'll talk more about that once we ingest our data. Let's click on Get Data and you can see the variety of data sources available to ingest data into Microsoft Fabric. The options here on the top are all of the sources that you can connect to. You can access data from an Excel workbook. If your data is in SharePoint, you can connect to SharePoint. And there are many more third-party sources from which you can retrieve your data. We'll keep our life very simple. We are focused on Power BI and the advanced features in Power BI. I'm just going to upload my CSV file right here and access my data that way. Here is my Superstore CSV file. Now, this is a dataset that I got from Kaggle, and here is the link to the original of the dataset. So if you'd like to download this data directly rather than use it from the assets available in this course, here is the link for you to use. You see an option here for connection credentials. That doesn't really matter since we're loading from our local machine. It'll just use our logged in account to access the data. I'm logged in as contact at Lunicorn. You saw that when I signed in, and it'll use this organizational account to load my data into Fabric. Let's now click on Next, and this will give us a quick preview of our data. Now, if everything looks good, this is what our data looks like, where every record here is an order placed with the Superstore. And we have a number of details. We have the order ID, order date, ship mode, customer name, city, postal code, product ID, category, and many, many more. You can scroll over to the right and see all of the details here: product name, sales, quantity, discount, profit. Anytime you load in your dataset, make sure you take a look at the data types of the various columns of data that you're loading in. For example, you can see the 1, 2, 3 next to row ID indicating that's a numeric column. Take a look at the ABC next to customer name. That indicates that this is a text field. Likewise, state and city are text fields, but postal code is a numeric field. While doing this quick scan, I realized that order date and ship date are both interpreted as text fields. Notice the ABC icon next to them. Now, this is definitely a problem. This is something we'll have to fix when we transform our data after loading. Click on Next, and this opens up the familiar Power Query editor. This is likely not your first Power BI course, since this is meant for intermediate and advanced audiences. This means that you have used Power Query. Power Query is the core data transformation engine in Fabric. This is the cloud-based next-generation version of the Power Query you likely know from Power BI Desktop. In Power Query on the cloud, you can ingest, clean, and transform data using the same familiar visual interface. Your data is displayed here at the center of the screen. Off to the right, the applied steps show you what transformations you've applied to the data. The existing transforms there have been applied by default when you loaded data in. These transforms read data from our source, our CSV file, promoted the first record in the CSV file as a header, and tried to interpret the data types of the individual fields. In the FX input right above where you can see the main data, you have code in the M programming language defining the transformations applied to your data. Here, let's use Power Query just like we would on the Power BI desktop. The first thing I want to do is change the data type of my order date column so that it's of type date. So I select change type as an option. There is an option for date here, and I'm going to go ahead and select that. Now you can choose this to replace the current step, which is also about changing data types, but I want to add a new step to change only the order date data type. And it seems like this particular step didn't really work as well as expected. You can see a number of errors here. Now you can click through to the errors and see why these errors occurred, but the main reason is that there were certain dates that did not fit the format expected. The reason I get these errors is that Power Query is using the wrong locale to interpret the dates in my dataset. It's likely interpreting the dates based on my local region, that is India, but the dates are actually in the MMDD YYYY format, which means this uses English United States. We can explicitly set the locale that should be used to interpret these dates. Click on the gear icon right next to the step where we actually change the date data type. And this will bring up a dialog that will allow you to specify the locale of your date. Use this drop down to select the correct locale for your date. And in our data, it happens to be English United States. You can see all of the sample input values that the date with this particular locale will interpret correctly. Click on OK. And now if you take a look at the order date, there are no errors. This means that our dates have been interpreted correctly, and I can go ahead and change the data type for the ship date as well. I right click, select change type, and select date once again. The locale has been set once, the same locale will be used for the ship dates as well. And this time around, I have all of the date formatting set up correctly. Notice the icon next to order date and ship date. You can see that these columns are now correctly interpreted as dates. This means we are all set and we can go ahead and create a report. On the Power BI service, before you create a report, you have to create a semantic model. And I'm going to create this asset within the Superstore folder. This semantic model is the layer that lies between our raw data, the CSV file that we just loaded in, and our Power BI reports. The semantic model is not just the data, but also any relationships that exist in your data, DAX measures, hierarchies, and other business rules. Now, once the semantic model is created under the hood, you can see the familiar interface of a Power BI report. Now, to start off with, I don't really want to work with this report. I'd like to generate quick insights on my data. So what I'm going to do here is click on this workspace icon off to the left. That will take me to the main workspace view. And here in the main workspace view, I'm within the Superstore folder, and you can see my semantic model, Superstore model. You can't see the report because we haven't saved the report yet. In the next video, I'll show you how you can generate quick insights on your data. In this video, we'll move on to the next two steps of our demo. We'll build a base visualization, and then we'll use get insights on that visualization. This will move the focus from broad dataset level insights to a specific user-defined analysis. We set up a line chart of profit versus order date, and this line chart will act as the base or context for more advanced AI features. When we call get insights on the specific visualization, we'll observe the trends at the default yearly level. You'll find that at such a coarse granularity, the insights are really not that useful. But when you make the granularity more fine-grained, such as at a monthly level, you'll see how Power BI's AI can be used to identify outliers and trends that exist in the data. The first thing I'll do here in my workspace, you can see my Superstore model, that is the semantic model for our Superstore data. I select the three dots and select the Create Report option. This will take us to a new untitled report, and here is where we'll set up the base visualization. You can see that a Power BI report on Fabric is very similar to how Power BI looks when we use the desktop. Let me close the panes I don't need. I'll close the filters pane, and here in the data pane, you can see our Superstore data. For each order, we have a whole bunch of information: category, city, country, customer name, order, date, postal code, profit, quantity, and so on. Categorical variables have no marker, but order date and ship date both have the calendar icon next to them, indicating they are interpreted as dates. The sigma or the summation icons are present next to the numeric columns. When fields are identified and interpreted as dates, Power BI automatically sets up a date hierarchy. The date hierarchy is just a breakdown of the date into its hierarchical components. So for every date, we have the year, then the quarter, then the month, and then the day. The date hierarchy thus automatically groups a date column into logical levels. This feature is essential for reporting as it enables users to easily drill down from a high-level view, like say annual sales, to more granular details, like daily or monthly sales. And we are going to do exactly that. I've expanded the order date and you can see the date hierarchy there. And now I'm going to set up a line chart. The line chart will allow me to see how sales vary over time. I'm going to select the order date, and that is added to the x-axis of the line chart. Since I selected order date as a whole, all of the components of the date hierarchy have been added. Next, we need to specify what we'd like to view on the y-axis. Now let's say the metric that I'm most interested in is profitability. I'm now going to select profit, and here is the visualization of profit on the y-axis. We have profit information from 2014 to 2017, and profit has been trending up. By default, Power BI displays this visual at a yearly granularity. But using those downward arrow icons at the very top, you can drill down into more granular views. That's not something we'll focus on in this demo. We are more worried about AI insights. But before that, let me show you how you can format this visual. The format pane in the visualizations pane is available just like on Power BI desktop. In the format pane, there are just a few changes I'd like to make. The first thing is I'd like to turn on data labels. So head over to the data labels section and turn on data labels so that you can clearly see the profit values at the important data points. So that's one change. The other change is I'm going to add markers representing these points. So head over to the markers section and turn on show for all categories. You can see that little round markers have appeared at the different yearly points in our line chart. That's the default marker. You can go ahead and change it if you want to. I won't format this visual further. Those are the only changes I wanted to make. Let's go ahead and extract insights from this data. Now, when you extract insights for a particular visualization, Power BI will use the current representation of the visualization and identify trends, anomalies, and other interesting features. Click on the three dots next to the visualization and select the Get Insights option. This will open up an Insights pane, and AI generated insights are available for you to view and for you to drill down into. The only type of insight that's available at this granularity of our profit data, yearly granularity, is trends. And there are three types of trends that AI Insights shows us: recent trend, steep trend, and long trend. Recent trend refers to a significant upward or downward trend that is the most current one. This tends to focus on what's happening now in the most recent portion of your data. The steep trend highlights a trend that's not only statistically significant but also has the sharpest rate of change, that is, the steepest slope, compared to other trends within a single time series. And the long trend will identify a trend that's statistically significant and represents the most prolonged continuous increase or decrease found within our time series. At this very coarse level of granularity, this is not that useful. You can see that recent trend, steep trend, and long trend all talk about the increase in profit from 2014 to 2017. All three trends have identified the same statistically significant increase. You can click through on these individual trends and get additional information. You can get possible explanations for the change. Possible explanations here is completely empty, so it's pretty clear that Power BI's AI wasn't really able to identify any significant influences for these trends thanks to the coarse granularity of our visualization. I think we need to fix this. We need to go from this coarse granularity to a finer granularity. In this video, we'll move on to exploring the insights generated for our visual, and we'll also view the explanations for these insights. This demonstrates the true power of augmented analytics, moving from detection to diagnosis. This part of the demo will show us that Power BI doesn't just flag what happened, but also provides data-driven hypotheses for why it happened. You'll find that you'll get more interesting insights if you view your data at a finer granularity. I'm going to get rid of the order date that I have selected here that by default shows me the profit information at a yearly granularity. And I'm going to go ahead and select all of the date hierarchy components except day. You can see that my line chart is now much more detailed. This shows me the profit numbers at a monthly granularity. The tick markers on the x-axis are on a quarterly basis, and the individual data points are plotted per month. You'll find that you'll get many more interesting insights at this level. If you hover over the individual points, you'll get the month and the profit for that month. Let's now run our Get Insights feature on this level of granularity of our line chart. Click on the three dots and select Get Insights. You'll find that we now get two categories of insights. We get insights for anomalies in our data, and if you scroll down, you'll find insights for trends in our data. Let's go back up and focus on anomalies first. Notice you see anomalies in sum of profit that talks about all anomalies. For the years that we have data available, Power BI has identified two anomalies. Sum of profit was unusually high on October 2016 and December 2016, and profit was roughly $16,000 and $17,000 respectively. These correspond to the two highest peaks in our line chart. The one recent anomaly that Power BI has identified is on December 2016. That is the highest peak. And the anomaly that it determined was the most statistically significant was the one on October 2016. That's the second highest peak. And the reason I feel Power BI found this the most significant is because it's a steep rise. The total profit in September 2016 is quite low, and then it jumps up for October 2016, making that a significant anomaly. And then, of course, we have trends. The most recent trend in profit that Power BI found started in July 2017. And you can see that clearly in the line chart here. The steepest trend that it found was between July 2017 and December 2017. That's the last steep rise that you find in the chart, the same one starting in July 2017. We now know what happened. Let's see why these things happened. I'm going to dig down into the two high anomalies for sum of profit. There's a little glitch in the Power BI report here at the time of this recording, in that the main chart here that identifies the highs or the anomalies for sum of profit is not visible here. You can see the high that this particular anomaly refers to in December 2016 in the main chart. What I'm most interested in though is the possible explanations. And you can see that every possible dimension has been considered to see whether it could explain this particular high. The most significant dimension that Power BI AI found was that the category is office supplies. It seems like there was a spike in the profitability in the office supplies category in December 2016, and that contributed to the overall profitability. As you scroll down below, you can see the other possible explanations for this spike. The spike is in the consumer segment in the subcategory binders in the city of Detroit, where the state is Michigan. And if you look even further, you can find out what customer contributed to the spike. It seems like there was one customer with ID AB10105, whose name is Adrian Barton, who bought a whole bunch of office supplies, that is, binders within the office supplies segment, and contributed to the spike in profitability. These possible explanations are useful because they quickly highlight potential root causes for unexpected spikes or dips in your data. Instead of manually exploring various dimensions, the AI analyzes correlations across your data model and suggests factors most likely driving the anomaly. These factors are ranked by statistical strength. This accelerates your investigation and helps you understand why the abnormality occurred. Let's open up these charts and look detail into this analysis. You can see the spike there in the consumer segment. Well, office supplies is in the consumer segment, and you can see the spike in the binders category. It's all the same spike. It seems like these binders were bought in the city of Detroit, and there seems to be one customer responsible for the purchase of these binders. We have the customer ID and the name of this customer, Adrian Barton. Adrian Barton made this purchase and got it shipped via standard class. We've had a quick look at the possible explanations for the spike in December 2017, and you can actually add this chart to your reports, which we'll do so in just a bit. Here is the spike in profitability. Our data only goes up to the middle of 2017, so the spike in December 2016 is the most recent anomaly. Let's click through to the recent anomalies and take a look at the possible explanations. Since this is the same spike, you'll find that the explanations are the same as well. The category is office supplies. Now, let's say you'd like to drill into this chart further. Doing so in this very tiny view is difficult. You can always add this chart to the report in order to highlight this particular explanation for the spike. I'm going to go ahead and click on Add to Report, and I'm going to adjust the two line charts so they line up one on top of the other. My alignment isn't perfect, but you can clearly see the spike in December attributed to the category office supplies. In this way, you can drill down into the other possible explanations. Let's look at segment as consumer. Let's add this chart to the report as well, and you can line up the two charts and verify that yes, indeed, it was the consumer segment spike that caused the spike in profitability in December 2016. And the consumer segment, of course, has the office supplies category and the binders subcategory. So let's add this binders information. And you can see there was a huge spike in the purchase of binders. That's the dark blue line that corresponded to our spike in profitability in December. Let's add one last chart to our report to verify our analysis here. The spike in the purchase of binders by a particular customer, Adrian Barton. You can see that this particular customer was responsible for about $5,000 of the total $18,000 profit. Without the bulk purchase by this particular customer, our profitability would have been around in the 13,000 range, which is not an outlier or anomaly by any means. This specific bit of insight is tremendously important because this identifies our upward spike, the anomaly, as a potential outlier rather than a general trend. Knowing it's tied to a single customer's specific purchase prevents you from incorrectly assuming overall profitability is sustainably higher or that binders are suddenly more profitable across the board. This allows you to adjust forecasts and strategies more accurately. This tells you that it might be more important to investigate that particular customer relationship further or analyze binder sales separately from overall trends. This demo has been fairly long. There were lots of little details to consider, but we are finally at the very last step, where we'll use yet another interesting AI-driven insights feature in Power BI. Explain the increase and explain the decrease feature. When you select this option on a particular data point in a Power BI visual, it triggers an AI-driven analysis to understand why exactly that change occurred. This is typically used with time-ordered line charts or bar charts to see the change over the last time period and understand why that change occurred. This feature analyzes other columns and dimensions in our semantic model to identify which categories had the most significant influence on that specific increase or decrease compared to the previous data point. Power BI then uses charts and natural language descriptions to highlight the key drivers behind this particular fluctuation. Let's go back to our report. This is the same report that we've been working with, and I'm going to set up a new chart. This is going to be a clustered column chart. Drag that and I expand it to fill the window. I'm going to use this chart to display the sales by month. So I select the order date, but I'm not interested in the daily granularity. So I get rid of the quarter and the day components of the hierarchy. So I'm left with year and month. This is what I'll see on the x-axis. On the y-axis, I'm going to select the sales field. Sometimes Power BI is a little glitchy. This still shows me sales by year. I'm just going to deselect and select the month option once again, and the visual will refresh. And now I see the level of detail that I'm looking for, sales by month. You can hover over the bars of the individual months, and that will give you the total value of sales. Taller bars, of course, represent higher sales for a particular month. And I'm curious about why sales were high in a particular month higher than the previous month and why sales were lower in a particular month. Here is a really tall bar where we had the highest total sales in a single month, November 2017. I'm going to right click on this, select the Analyze option and observe it gives me only the option to explain the increase. Power BI has correctly realized that this month's sales was greater than the previous month, and I'd like to know why that increase occurred. And here you can see a number of different reasons why this increase occurred. The first is the ship mode. The narrative here tells us that standard class and second class accounted for the majority of the increase amongst sales in the ship mode category. Here is the sum of sales by year, month, and city. It seems like Newark, Burlington, and Seattle had the largest increase among sales by city, and it offset the reduction in New York sales. And if you scroll further down here, you can see the breakdown by state. The narrative gives you a quick overview of what states drove the increase. North Carolina, Delaware, and Washington. They had the largest increase, The state of New York had a fall and the other states offset New York's fall. You can scroll down here and see all of the different categories that influenced this increase in sales in November 2017 and then drill into whatever category makes the most sense, the one that you're interested in. I'm curious about how the different product segments affected this increase in November 2017. So, this is where I'm going to drill in further. If you remember in our trend analysis, there were four kinds of visuals that Power BI used to display possible explanations for a particular trend. These same visuals are used to explain why distributions vary as well. You can see the four visuals at the bottom: the waterfall chart, the scatter plot, the 100% stacked column chart, and the ribbon chart. Here is the waterfall chart that explains the increase by segment. The starting blue bar represents the sum of sales in October 2017. Now, going from October to November, you can see that the consumer segment showed a net increase. The sales for this segment were only around $23,000 in October, but in November, this went up to 49, almost $50,000. There was a major increase in sales in the corporate segment as well. October sales around $25,000, November sales almost $45,000. The segment where there is a slight fall is home office, a fall of about $5,500. The consumer and corporate segment thus drove the increase for November. Let's switch to the scatter plot, and this will give us the same information. The categories in the green region contributed positively to sales, and the category home office in the red region had a negative contribution. The 100% stacked column chart gives us the same information. Notice that the proportion of the light blue and the dark blue region, these correspond to the consumer and corporate segments respectively. These both showed an increase, whereas the orange portion corresponding to the home office segment shows a marked reduction. The ribbon chart, of course, visualizes the change in values over the two periods, but also emphasizes changes in rank. You can see the home office, the value fell, the rank fell from 1 to 3 as well between October and November. Whereas if you look at the corporate segment, you can see the rank remained the same at 2, but the value associated with the segment increased between October and November. Now let's try and dig a little deeper into a particular month where sales fell from the previous month. That is February 2017. You can see that the bar here is much smaller than the bar for January 2017. So let me right click, select Analyze, and here the only option I have is to explain the decrease because Power BI knows that this particular month had lower sales than the previous month. Power BI's AI insights will give you a number of possible explanations for this decrease, and the most statistically significant categories that could drive this decrease will be towards the very top. Here is an explanation of the decrease by state. You can see what states contributed to the fall in sales for February 2017 over January 2017. States contributed to the fall, regions contributed to the fall. Here is a waterfall chart for that. Let's scroll down further. There were falls across various categories of products as well, notably technology and office supplies. And you can scroll here and view the various possible explanations. Let's pick one. I'm curious about how state affected this decrease in sales in February. Sales in January to start off with quite high at $44,000. States in this other category, that is all of the other states other than the ones you see here on screen, did not contribute much to this fall, but these states did. Texas, Pennsylvania, Montana, Missouri, and the highest contributor was Michigan. Sales in Michigan were a full $10,000 lower than in January, and that was the most significant state that contributed in the fall in sales for February 2017. The same information is available here in the scatter plot as well. The data points in the green region had a positive contribution to the sales, that is, they tended to increase February sales, and the data points in the red region tended to reduce February sales. And of course, there is Michigan here, the biggest contributor. And here is a 100% stacked column chart. The big purple bar that you see on the left in January, that corresponds to Michigan. That barely exists in February. If you're interested in how sales changed for a particular state, the best view, of course, is the ribbon chart. You can see the sales in Michigan for the month of January, and there is no corresponding entry in the month of February. You can see how California increased between January and February, but this increase wasn't sufficient to offset the decrease in Michigan and the other states. This completes our first demo on AI generated insights. Let me quickly save this report. Go to File and select the Save option, and this report will be saved within the Power BI experience on Microsoft Fabric. I'm going to place this within the Superstore directory, which has all of the assets corresponding to this particular demo. And I'm going to call this report just Insights. And once this report has been successfully saved, you'll find all of the Power BI assets that we worked with, our Insights report, and our semantic model within the Superstore folder where we had placed it. In the previous video, we focused on anomalies and we drilled down into possible explanations for anomalies. In this video, we'll focus on trends and look at possible explanations for trends. And for this, I'm going to switch to a line chart with even more granularity. Empirically, I've found that Power BI is better at identifying trends and possible explanations for trends if you're working at a final granularity. I'm going to go ahead and right-click on the order date in the x-axis, and in the menu that comes up, I'm going to select order date. Rather than use the date hierarchy, which we have currently set at the month granularity, this will choose the raw order date as the x-axis for our line chart. And this will give us the most granular bit of information that we have. Here we have profitability on a daily basis. And you can see the various anomalies that exist in the data. It's hard to identify trends, but you'll find that AI Insights in Power BI works better with this data. I'm going to go ahead and click on the three dots and select Get Insights. And then, of course, this shows us anomalies as well as trends. Another kind of analysis that you often see, but you don't get here in our line chart, is KPI analysis. KPI analysis as insights often shows up in segment-based analysis, such as with bar charts. That's something you can try out on your own. For now, we'll focus on this long trend in sum of profit. Now, this long trend was a declining trend. Profit experienced the longest period of decline between Sunday, March 26, 2017 and April 20th, 2017. I'm very curious as to why that happened and what caused this decline. So I click through for possible explanations. This chart here is the chart that was analyzed to find the downward trend. I'll scroll down below and take a look at the possible explanations. The explanations here are broken down by various dimensions that could be possible root causes, and the one which is the most statistically significant is listed on top, and that is subcategory. AI Insights allows you to drill down into every possible explanation for an upward or a downward trend using 4 different charts. You can see the 4 charts here at the bottom. The first of these, one that you see here on screen, is a waterfall chart. This chart breaks down the total change between the 2 points in time that we're interested in. The first blue bar is the start of the time period, March 26, 2017. The last very small blue bar is the end of the time period. The remaining bars are the positive and negative contributions of different categories. This visually steps through how the different factors adds up to the overall decrease that we are viewing. The next visual is the scatter plot. This shows the value of each subcategory before the change on the x-axis and the value of the subcategory after the change on the y-axis. This helps identify which categories drove the change the most by showing how far they fall above or below the general trend line. You can see there is a partition at the center which divides the scatter plot into green and red portions. You can't see it in the chart, but close to this partition, we have a trend line. And the few points that are far away from the trend line tell us that there are a few outlier subcategories that drove this decline in profitability. Next, we have the 100% stack column chart. This visual compares the relative percentage contribution of each category to the total, side by side for the before and after periods. It's useful for seeing if a category's share of the total changed significantly, even if its absolute value did not change much. This chart right now is too small for us to interpret anything. I'll add it to our report and we'll inspect it in more detail in just a bit. Let's look at the last chart here, and that is the ribbon chart. Now, the information that it portrays is similar to the stacked column chart, but the ribbon chart visualizes the change in values over the starting period and the ending period. And it also emphasizes the change in rank. Thicker ribbons represent larger values, and the flow of the ribbons clearly shows which categories gained or lost importance relative to others. Now, since I'm eager to learn more about this particular decline, I'm going to add an additional page to this report, and I'm going to add these charts to this page one by one to analyze the long downtrend in profitability. So I'll click through to this long trend, and let's take a look at subcategory as the most statistically significant explanation for this decline. Here is our waterfall chart, and I'm going to add it to our report so that we can drill down into this in much more detail. First, let's pay attention to the two blue bars that form the start and the end of this waterfall. Now, the trend that we are digging deeper into is a decline in profitability. On 26 March 2017, our profit was $426 roughly, and on 20th April, it was just $22. Our AI insights tell us that subcategory is the most significant driver of this decline, and I'm curious to see how the different subcategories performed over this period. Between the starting and the end time periods, we have a number of floating bars that breaks down the change. The colors of these floating bars have meaning. Green bars indicate categories that contributed to increasing the profit. Red bars indicate categories that contributed to decreasing the profit. Here you can see that the subcategory appliance had negative profitability in March, but in April it was zero. So it positively contributed to the profit. Next, we have binders that went from zero profit to $83. So this contributed in a positive way to the profit. The contribution of items in the other subcategory was not very significant, though it was overall negative. Here are the subcategories that changed significantly, driving the profit down. The first was phones. This drove the profit down by roughly $58 in this time period. Then we have furnishing that drove the profit down by $61. These are all small numbers compared to copiers. Copiers formed a huge part of the profit in March at almost $570, but they didn't sell at all in April. And this was the major driver of reduced profitability that we see on 20th of April. Next, let's look at the same analysis, but this time in the form of a scatter plot. Select the scatter plot and let's add that to the report. On the x-axis, you can see the value of profit for each category on the initial date, 26 March 2017. On the y-axis, we have the value of profit for each subcategory on the 20th of April 2017. The dotted line that you see at the center is the trend line. You can see that the different points in the scatter plot lie in either the green portion or the red portion of the scatter plot. Data points are shown in the green region when the value for that specific category increased between the initial date and the final date. Data points fall into the red region when the profit for that category decreased between the first date in March and the second date in April. Now let's hover over a single data point in the green region. The profitability for appliances increased in this time period. It went from a negative value to zero. You can see that binders falls in the green section as well. It went from profitability of zero in March to about $82 in April. The major contributor to the decline in profitability in this time period was due to copiers, and copiers is clearly in the red region. The superstore went from earning $570 of profit in March to zero in April. Next, let's look at the 100% stacked bar chart. Go ahead and select that and add that to the report. This gives us the relative percentage contribution of each subcategory to the total. Now, on the left, you can see a big yellow portion for March 2017. This corresponds to the copier subcategory, which formed a huge portion of the profits. You can see that there is no section for copiers on the right-hand side, which corresponds to the 20th April profits. The largest portion here on the right is for binders, and that had a profit of just about $82. The fact that the section for copiers and the section for binders are almost of the same size, but the profits are very different, tells you that this is a stacked column chart that shows the relative contributions of the different subcategories. Now let's look at the last visualization here, the ribbon chart. I'm going to add that to the report. The ribbon chart visualizes the change in values from the initial period to the final period. Now, in the initial period, there was a huge order for copiers that does not exist in the final period. Observe that there is no flow from the initial period to the final period for copiers. However, there is a flow for phones. This means there were profits to be gleaned from phones both in the initial period and in the final period. Phones was at rank 2 in the initial period and it went to rank 6 in the final period. So its relative rank fell. It contributed a profit of $33 in March and that went to a negative profit. That is a loss of about $24 in April. Another category where you can visualize the net change in values is furnishings. Furnishings went from rank 4 to rank 7. Its rank fell as well. These four charts together allow you to visualize in a great level of detail where exactly the trend change came from, the decline or the increase. There are other possible explanations for this decline in trend. In addition to subcategory, you can look at customer name, city, state, and maybe segment. That sounds interesting. Each of these four charts are available for segment as well, and you can view the individual charts to see how segment contributed to this decline in trend. This scatter plot immediately tells you that consumer had a positive contribution to the profits in this time period, but the other two segments, corporate and home office, had a negative contribution. Here's the same information in the form of our 100% stacked column chart and in the form of our ribbon chart. In this demo, we'll use Power BI's AI insights to figure out where a distribution is different. This compares the distribution pattern of the segment that we've selected against the distribution pattern of the overall dataset. It then runs statistical algorithms across other columns and dimensions in our model to identify where the proportions or relative contributions significantly diverge. The feature then highlights the dimensions and values within those dimensions where the selected segment shows the most statistically unusual or distinct distribution compared to the norm. Here are the steps involved in this demo. The first thing you need to do is pick the right visual. The visual here is typically a bar chart that is focused on proportional comparison. We'll visualize how distributions are different and then we'll make a few tweaks to our data. We'll create new columns in our data for richer comparisons as to how distributions are different. Next, we'll compare distributions using the new columns, and finally, we'll save and wrap up. Let's start off by picking the right visual. The right visual is typically a bar chart. The visual has to focus on proportional comparison. Instead of explaining a simple increase or decrease, this feature answers the question, how is this group different from the rest? This feature is crucial for identifying unique characteristics or behaviors of a specific segment. Here is our workspace with the Superstore folder. We'll continue working with the same data set as before. So click through and let's create a new report with this Superstore model as the semantic model underpinning the report. We need to set up our visual first before we can see how distributions vary. I pick a bar chart that is a clustered column chart. In this chart, I want to view the profitability based on segment. So make sure you drag segment and place it on the x-axis, and on the y-axis will display the sum of profit. In the overall dataset, the consumer segment is the most profitable, then comes the corporate segment, and then the home office. Now I'm curious about how this distribution varies across states, regions, cities. When you look at the segment-wise contributions based on these other dimensions, things might look very different. Hover over this visual, doesn't matter where, select Analyze, and here you'll find an option to find where this distribution is different. This option is not available on all charts, it's available on the bar chart. Let's take a look at the visualizations that we have here showing us how distributions vary. Based on Power BI's analysis, This distribution is significantly different for the three states here: Texas, Pennsylvania, and Illinois. Texas is a state that's currently selected. You get a narrative summary at the top that says that Texas, Pennsylvania, and Illinois show significantly different patterns compared to the overall distribution of profitability across the three segments. Now, if you take a look at the shaded gray area, that shows the profit proportions for the three segments in the overall dataset. The gray bars tell us that the consumer segment overall is the most profitable, then corporate, and then home office. The blue bars are the corresponding profits for the three segments in Texas, and you can see they are very different. The consumer segment in Texas is in fact loss making, it has the highest loss. Corporate is also loss making, but the loss is lower, and the home office is also loss making in Texas, but the loss is again lower. It's pretty clear that the distribution of profitability across the three segments in Texas is very different from the overall distribution of profits. Now, let's take a look at Pennsylvania. I'm curious about how that is different, and you can see the difference is stark here as well. The three segments are loss making in Pennsylvania. Consumer has the highest loss, then corporate, then home office. This is, of course, represented by the blue bars. The blue bars represent Pennsylvania, and the gray bars represent the overall profit distribution across the entire data. And we know that across all of our data, all segments are profitable. The next state that we'll consider is Illinois, and we see the same pattern here. All three segments are loss making in Illinois, but profitable in our overall data. When you're analyzing how distributions vary, an important point for you to consider is this narrative on top and the percentage of records that belong to the different categories. Our narrative says that Texas has 9.9% of the records, Pennsylvania 5.9%, and Illinois 4.9%. This together represents about 20% of the orders. That's a pretty significant chunk. So, a huge chunk, that is 20% of the records in our dataset, had a different distribution for profitability across segments as compared with the distribution of profit across segments for the entire data. If you scroll down, you'll see there are certain cities that have very different distributions in terms of profitability across segments. An interesting observation here is that these cities belong to the states that we looked at earlier. Philadelphia is in Pennsylvania, Houston is in Texas, and Chicago is in Illinois. The profit distributions for the individual states were definitely affected by these cities, and these are big cities. Since the cities are highly correlated with the states, we won't dive into this further. Instead, we'll scroll down and look at another possible dimension, and that is the subcategory. It seems like the profit distributions of tables, binders, and furnishings are very different from the overall dataset. Let's look at the narrative up top to see how significant this is. Tables comprise of about 3% of the records, binders are huge, 15.2% of the records, and furnishings almost 10% of the records. The gray bars indicate the profit distribution across the entire dataset, and the blue bars the profit distribution for tables. And tables are loss making. Tables in the consumer segment have the highest losses, then corporate, and then home office. Now, if you switch over to binders, you'll see that the profit distribution for binders is really not that different from the overall profit distribution across segments for the entire dataset. The consumer segment is the most profitable, then corporate, and then home office. And this is true of the entire dataset as well. Binders might have more variation in the distribution as compared to other subcategories, but really it's not very different, and the same is true for furnishings as well. The distributions here are very similar to the profit distribution across segments for the overall dataset. Let's see how this particular distribution varies by region. You can see the distribution for the central region is very different. In the central region, the corporate segment is the most profitable, then home office, then consumer. And the central region has 23.2% of the records in our dataset. You can quickly take a look at the other regions, but the south region more or less matches the distribution of the entire dataset, and the east region is just a little bit different. Now, the best way to view this chart of how distributions are different is to compare proportions. When we compare proportions, we emphasize the relative contributions of the individual categories rather than absolute amounts. So here what you see are relative contributions of consumer, corporate, and home office for the data set as a whole, that's the gray bars, and for the central region, that's the blue bars. Now, instead of comparing proportions, you can compare absolute values. With absolute values, you're doing a direct comparison. The gray bars are absolute profit values across consumer, corporate, and home office, and the blue bars are absolute profit for the central region across these three segments. Even though the profit distribution across segments for the central region is different from the distribution for the overall dataset, the central region contributes a very small proportion of the overall profit in these three segments. Of the regions here, the south contributes again not so much, the east contributes much more, and it's pretty clear that a majority of the contribution comes from the eastern region that's likely driving the distribution of profit across these three segments. I think comparing proportions is easier to take in and parse intuitively, but you should look at absolute values as well so you can see the magnitude of the contribution. If this is an analysis you find interesting, you can always add this chart to your report. If you click on this little plus icon, the chart that you're viewing will be added to your report and you can place it where it makes sense to you. I find that it's easier to analyze such data when the charts are placed one on top of the other. Now, what if there is a particular way you'd like to categorize your data and see how distributions vary across those categories compared to the overall dataset? Well, it's possible to do that by creating new columns. That's what we'll do in the next video. When you're analyzing how distributions vary across categories, you're not restricted to the categories that currently exist in your data. You can create new categories via DAX expressions, and Power BI will include those categories in its analysis as well. We can now move to the next step in our demo, where we compare distributions using the new columns that we've created. Since we can analyze how distributions vary only by categorical variables, we converted some numeric fields that we were interested in to categories in order to see how distributions vary across these new categories. Now that we're done with understanding how distributions vary, let me go ahead and save this report. Click on Open Data Model from the Power BI report here, and this will take you to the semantic model underlying our report. Now you can see on the top right that we are currently viewing our semantic model. I'd like to make some edits to this model to switch our mode over to editing. This will allow us to add new columns, new data to our semantic model. Now that we are in the editing mode, let's add a new column using DAX expressions. Click on the new column option here, and this will allow you to enter a DAX expression right here in this input box. I'm going to add a new column called discount band. The records in our dataset contain products sold and many of them are discounted. I'm curious about how profitability varies for the different ship modes, standard class, first class, and so on, based on the discount band. What you see here is a simple DAX expression where the variable D references the discount column in our Superstore dataset. I then have a switch expression. If discount is blank, the category is just unknown. If the discount is 0, the category is 0%. If it's greater than 0 and less than equal to 0.1, then the category is 0 to 10% discount. If it's greater than 0.1 and less than equal to 0.2, the category is 10 to 20%. Otherwise, the category is 20% plus. I go ahead and click on the check mark to add this new column to my semantic model. You can see that the discount band has been added to the semantic model, both in the main pane as well as in the data pane off to the right. Another thing I'm curious about is how profitability varies across the different ship modes based on the size of the order. So here is my new column for the different order sizes. This is based on the quantity that is a pre-existing column in our dataset. If quantity is blank, then order size is unknown. Otherwise, I have my categories: small 1 to 2, medium 3 to 5 quantity, and large is quantity of 6 plus. And I'm going to click on the check mark to go ahead and add this new column to my semantic model. And in the pane off to the right, you can see that order size has been successfully added as a new column. Now, both quantity and discount were numeric values. Power BI's AI Insights doesn't consider numeric values in trying to figure out how distributions vary. It's focused on figuring out the change or varying distributions across categories. What I've done here is I've converted both discount and quantity that were numeric values into corresponding categorical values. Let me just make sure that our semantic model is refreshed and up to date. Click on refresh. And once the model is updated, let's go back and extract insights from our visual and see how distributions vary. And you'll see that these new categories will be included in Power BI's analysis. We can now move to the next step in our demo where we compare distributions using the new columns that we've created. Since we can analyze how distributions vary only by categorical variables, we converted some numeric fields that we were interested in to categories in order to see how distributions vary across these new categories. Let's head back to our Power BI report. We were previously viewing profit based on the different segments. I'm now going to change this visualization. Instead of profit by segment, let's switch out segment, and I'll now view the distribution of profit by ship mode. And in the overall data set, it seems like orders with standard class shipping tend to drive most of the profit. Then we have second class, then first class, and then same day shipping. Now, this is likely because standard class has the most number of orders, then second class, then first class, and then same day. But I'm curious about whether this distribution is different based on discount band and order quantity. So right click, analyze, find where this distribution is different. And here you can see that the most statistically significant variation comes in the discount band category. For those orders where the discount is more than 20%, the distribution of profits across ship modes is completely different. In fact, when products are sold at a 20% discount across all ship modes, they tend to be loss making. And this is an interesting insight. This tells us that at the highest level of discount, the superstore is not making any money at all. Whereas overall, the superstore is profitable no matter what ship mode is used. If you look at the distribution for 10 to 20%, at this discount band, you can see that across all ship modes, the superstore orders are actually profitable, but the distribution is a little different from the distribution across the entire dataset, represented by the gray bars. And if you look at the category where discount is 0%, the proportions here match the overall distribution of profit across the dataset. It's pretty clear that non-discounted orders are the ones driving the profitability of the superstore. Now, though not as statistically significant as discount band, profit distribution across ship modes for medium-sized orders is a little different than the distribution across the entire dataset. For large orders, again, just a little different, not that different. And let's see how it is for small orders. Again, not very different. This clearly doesn't give us as interesting insights as the discount band did. Now that we are done with understanding how distributions vary, let me go ahead and save this report. And again, it's going to be within the Superstore folder, and I'm just going to call this report Distributions. Go ahead and hit Save. In this demo, we'll see how we can train a regression model without writing any code using AutoML on Microsoft Fabric. Regression is a machine learning technique that's used to predict a continuous numeric value based on input features. For example, you might use regression to predict home prices based on square footage and location, or predict the mileage of a car based on the state of the car, the age of the car, and the model of the car. Here are the steps that we'll follow to train a regression model. We'll first load data into the Lakehouse. This will be our training data. Then within our Fabric workspace, we'll create a new machine learning model and we'll configure the basic setup for the model. This will involve several details and choose the data source to perform regression. That data source will be our Lakehouse table. We'll define the purpose of the machine learning model, whether it's for regression, classification, forecasting, and then we'll configure the training data. This is where we'll specify the features used to train the model and what we are trying to predict. AutoML on Microsoft Fabric will then create a notebook with Python code that will pre-process our data and perform the regression. We'll review the code generated in the notebook and then execute that code to actually train a regression model. We'll then review the model's output and predictions. Let's start with the very first step where we load our training data into the Lakehouse. Here I am in my workspace and we have the Lakehouse already created. We created this Lakehouse earlier to store our cleaned diamonds dataset. Now here in the Lakehouse, I'll show you how you can upload a CSV file and create a table using the contents of the CSV file. I'd mentioned earlier that the Lakehouse can hold semi-structured and unstructured data in the files section. And this is where we'll first upload our raw data before we load the data into a table. Select files and right-click and select the upload option and upload files from your local machine. Here you can browse for the data that we'll work with for regression. This is the King County housing data that we'll use for home price prediction. I click on the upload button and this file will now be available in my Lakehouse as a raw CSV file. Since this is structured data, it can be directly loaded into a table. You can click through and take a look at the data. This is the raw file view. These are the contents of our CSV file. The table view will display the same contents as a nice structured table. You can see that the first row is the header for our columns. Back to our Lakehouse, I click on the three dots next to the CSV file, select Load to Tables and New Table. Fabric's Lakehouse will parse and interpret the CSV file. So we use header for column names, the separator is the comma, and you can just click on Load. And in a few moments, you'll have a new table within the Lakehouse with your training data. Just hit refresh and you'll be able to view the contents of your table. You can see we have a number of columns in this data. These are the features that we'll use to predict the price of a home. Tables in Fabric Lakehouses are delta tables. If you click on the file view of a table, you'll find that behind the scenes, this table is actually stored as a Parquet file. That's the specialty of the Lakehouse architecture. Data is stored in the open source Parquet format and the table enforces schema and all of the governance that you want on your data. We'll now move on to the next step in this demo where we create a new ML model, and we'll do this in the Fabric workspace. So select our Looney workspace Power BI and switch over to the Fabric view. Building and training a machine learning model using no-code technologies is a Fabric feature rather than a Power BI feature. Click on New Item and here in this list, search for ML model. Go ahead and select this. Let's give the model a name, House Price Prediction Model Quick. And the reason I say quick is because I'm going to use quick AutoML training to train the model. And the location of this model asset is of course within our workspace Power BI. Let me tell you a little bit about how we'll train our regression model. Let's just click through this tour. We won't really need it. I'll explain concepts and terms as and when we encounter this. As a unified platform for end-to-end analytics, Microsoft Fabric has features for various data-related tasks. The Power BI service is one such feature for data analysis and business intelligence. Machine learning is another important offering. Fabric allows you to train machine learning models where you can set up your notebook, write your own Python code to train custom models. Or if you want to train models with absolutely no code, you can use AutoML, and you'll see that's what we're going to do here. AutoML or automated machine learning automatically trains and tunes multiple machine learning models and then deploys the best model version and makes it available for you to use. AutoML is great for those who don't have deep machine learning or coding expertise. As you use AutoML, there are other technologies that you'll encounter along the way. I'll explain them as we encounter them. Clicking on Start with AutoML will bring up a dialog that will walk us through the configuration steps for the model. The first thing, of course, we have to choose the data for training. That's present within the Looney Lakehouse. Select that, click on Next. And in the Lakehouse, we have two tables. Select King County Housing Data, KC Housing Data. Click on Next, and then you define the model's purpose. What is it that you're trying to do? Is it binary classification, multi-class classification, regression, or forecasting? We are trying to predict home prices, that is regression. Now, AutoML on Microsoft Fabric offers several options for how long you want your model training to run. When you train with AutoML, AutoML does not train just a single model. It will train several models on your data. The training of each model is referred to as a run. AutoML will also tune those models to get the best performance on your data. Once model training and tuning is complete, it will automatically make available the best model for you to use for predictions. Now, with this context, let's look at the choices that we have: quick prototype, interpretable, best fit, and custom. You can see that the time duration allotted to run AutoML using these different options are different. For example, the quick prototype will run model training for just 2 minutes or less. An interpretable or best fit will run for 30 minutes to an hour. The longer you let AutoML run model training, the more models it will be able to test out in that time period, and you're likely to get a better model overall. If you're simply prototyping your use case and you want to make sure that things are just working, you don't want the best possible model on your data, you can choose quick prototype. Now, the interpretable option will only train those models whose features you can interpret to figure out how exactly the model makes decisions. This is basically explainable AI. There are certain models like tree-based models which lend themselves to interpretation. The interpretable option will use only those models. Best fit will try all possible models, even those that are black boxes. And custom allows you to configure what metric you want to use to evaluate your model and how long you want model training to run. I'm going to select the custom option to train my regression model. I'm going to run model training only for 180 seconds. AutoML will run for roughly 3 minutes and train as many models as possible in that time. The metric that I'd like to use to evaluate the model is a standard metric for regression, the R square. The R square metric evaluates how well the model fits on our underlying data. It's a value between 0 and 1, with higher values being better. Let's click on next and move on to the next step where we set up the training data. You can see that AutoML has parsed our table and then it asks us to choose the prediction column. What is it that we'd like to predict with this training data? Make sure you select the price column. We are going to use all of the other features that we have to predict the price. AutoML will automatically take care of cleaning and transforming your data so that it's ready for machine learning. Here in Manage Columns, you can specify how you want missing values to be treated in your data. For every column, you can specify the data imputation method. ML models don't work well with missing values, and this is some pre-processing that you have to do. AutoML will do this for you automatically, but you can configure this to a certain extent here on this page. Auto allows AutoML to interpret the data type, or you can explicitly specify the data type using this dropdown. Whatever your type of data, you can pick your imputation method, or if you choose AutoML will figure out the best way to impute or fill in missing values. I won't really change any of these details here. Here at the bottom, you can see automatic featureization is turned on by default and I leave it on. AutoML will automatically set up the right transformation methods to prepare our training data. Click on Next. These are the final details that you need to specify. You can indicate whether you want to train multiple models using Pandas data frames. That's best for smaller data sets. We'll just go with that. Or if your data is very large, it's preferable to use Apache Spark. Apache Spark is a distributed data processing engine that parallelizes transformations across a cluster of machines. Now, all of the configuration parameters that we specify will set up a notebook that will be generated automatically by AutoML. I'm going to name that notebook Housing Prices Quick Validation Notebook. And here you're asked for an experiment name. Now, all of the different models that you train and the training of a single model is referred to as a model run. All of these are stored within a container called an experiment. Machine learning is an experimental process. You have to try out different models before you can get the best one for your data. So all our model runs will be logged under this experiment that I've called House Prices Prediction Model Experiment. Click on Next, and here is a screen where you can do a final review to make sure everything looks good, and indeed it does. Now, in the Preview Code tab, you'll be able to see the Python code that AutoML generates. Now, we won't go into the details of this Python. I'll just give you a big picture understanding of what's going on once we create the notebook. Click on the Create button, and in a few moments, the notebook will be set up for you. The notebook contains all of the code that you need to train your machine learning model. Observe that we are connected to the Lakehouse to access the data within the Lakehouse. This is no code ML, but there is code running behind the scenes. It's already been written for you. In this demo, we'll see how we can use AutoML to build and train a classification model. A classification model is used to predict a discrete category or class label based on input features. For example, this is what you'd use to classify emails as spam or not spam, or categorize customer feedback as positive, negative, or neutral. In our demo, we'll use details about an employee to see whether the employee was promoted or not. Here are the steps that we'll follow. We'll first upload the training data to the data lakehouse in exactly the same way as we've done before. We'll upload our raw file and convert it to a table. The next step is we'll use the AutoML wizard to create and configure the model. This in turn will generate a notebook. We'll look at the basic details of the notebook that we're executing and run the ML model. You'll find that the AutoML generated code is not always perfect. Now, if you're familiar with coding, you'll be able to inspect the code and make the changes that you need to train your model. Finally, the third and last step is we'll use the model for predictions via a very simple wizard that Fabric gives us. Let's start with the very first step where we upload our training data to the Lakehouse. Here I am in my Fabric workspace. We already have the Lakehouse set up from a previous demo, Looney Lakehouse. Click through to the Lakehouse, and here I'll upload the file on my local machine to this Files section here in the Lakehouse. Upload files will bring up the Finder window on my local machine where I can navigate to and find the file. The data that we'll work with is this HR Analytics dataset that I downloaded from Kaggle. Go ahead and hit upload, and this file is now available in our Lakehouse. All I have to do next is to create a table that will load in the contents of this file, and that's the table that we'll use with AutoML. Here is my HR Analytics CSV file. Click on the three dots, and here you'll find an option to load to tables. Let's create a new table. This will automatically detect the schema of the file. The separator is the comma. We'll use header for column names. And the default name of the table sounds good. It's called HR Analytics. Once the data has been successfully loaded, you can take a quick look at what the data looks like. Just click on the table, and this will give you a preview of the data. You can see that we have a bunch of information about employees, the department, the region, the education, gender, recruitment channel, number of trainings, age, other details like awards won, average training score, and finally we have the is promoted column. That's what we are trying to train the model to predict, whether an employee was promoted or not based on all of these other features. A value of 0 means the employee was not promoted. A value of 1 means that they were. With the basic setup, we are now ready to head back to our workspace and move on to the next step in our demo. Here is where we'll create, configure, and run a model using AutoML. In our Fabric workspace, click on New Item and find the option for ML Model. Select that option. First, of course, we'll name the model Promotion Prediction Model. Click on Create and choose AutoML. This is what we're looking for, automated machine learning. This will bring up a dialog that we are now familiar with. Our configuration, of course, will be a little different. The first is to choose the data source. We'll select the Looney Lakehouse, which is where our HR Analytics data lives in a table. Go ahead and select that table. Click on Next. The next thing is to define the purpose of your ML model. We are going to be training a binary classification model. It's classification because we are determining whether a particular employee was promoted or not, and it's binary because there are just two possible values. An employee was promoted, yes, no. Once you've picked binary classification as a task, the next thing you configure is the AutoML mode. The choice for this depends on what you're trying to achieve. Do you just want to quickly validate that your data can be used to build a model, use quick prototype, or custom and set a very small training time? If you want AutoML to run training using a variety of different algorithms and find the best fit on your data, choose best fit. This will train multiple models and it can run for up to an hour as AutoML tunes the various models that it tries out. The interpretable option trains only a subset of models available with AutoML. That is, those models that have interpretability built in, explainability built in. There are certain kinds of machine learning algorithms that allow for explainability, that help you identify what features drove a particular outcome or prediction from the model. Those are the algorithms that will be trained when you choose interpretable, as I've done here. When you hit next, you'll find that the AutoML wizard has connected to the HR analytics table, and here you can choose your prediction column. Unfortunately, the UI has a glitch where it didn't allow me to scroll all the way to the bottom. Make sure you choose is promoted as the column. All the columns other than this one will be used as features for model training. Now, if you'd like AutoML to handle missing data in specific ways, you can expand the Manage Columns section and change the data imputation method. You can choose to fill in missing values in your data using the mean, the median, the mode that is the most frequent, or you can just leave it as auto and let AutoML pick the right technique. And then we have automatic featureization. This allows AutoML to automatically generate features using whatever existing X variables we have in our data. Click on Next, that will take us to the section for final details. Again, our data set isn't that large, so we'll train multiple models at the same time using Pandas data frames. We won't train with Spark. The name of the notebook, Employee Promotion Prediction Notebook, and the experiment is called Employee Promotion Prediction Model Experiment. Go ahead and click on Next, and you can just hit Create, and this will set up the notebook for you. And this will create a notebook with sections that are very familiar. The code will be a little different, and of course, it will operate on the data that you've just specified. We can now move on to the next step in our demo where we review, create, and execute the notebook. The notebook has already been created. Let's take a look at what exactly it has. Now I'll close this left navigation screen and let's start looking at the notebook. Markdown here in this notebook is actually interesting because this tells you what exactly is going on in the notebook and how exactly the models are being trained. The AutoML that Microsoft Fabric uses is FLAML, Fast and Lightweight Automated Machine Learning. This is an open source library that Microsoft has integrated into Fabric to allow you to train multiple machine learning models and tune their parameters to get the best fit for your use case. With AutoML, the idea is that you don't write any code. The code is generated for you. You'll also find that the generated code is mostly about pre-processing your data, making the final best model available in Fabric, and saving out predictions to a table within your Fabric Lakehouse. The actual models, the algorithms that are being trained on your data is completely abstracted from us. In order to run training, all you have to do is click on Run All here and it'll execute every notebook cell. And I'll give you a quick overview of what exactly is going on. You can see that the notebook first installs scikit-learn and a specific version of it. Now, scikit-learn is used to pre-process the data and fill in missing values in your data. Next, there is some code related to logging and warnings. We can ignore that. The first step is to load the data from the table within your Lakehouse. The code that you see in this cell loads from the Delta table and then converts it to a Pandas data frame and then uses the data in that data frame for machine learning. Now you can always run this notebook step by step and view what's going on. For example, this displays the X values, the features that are being used to train your machine learning model. Then there is a cell with some long and complicated code that sets up a processor to fill in missing values in your data. Now, you don't need to know how exactly the missing values are imputed. We've set the right configuration when we set up the model, and the notebook should take care of the rest. You can see there is a lot of code here. For practitioners of machine learning who are well versed with Python, this code is not difficult, but for novices, it can be fairly complicated. But you don't have to write it. Fill_NA is the function that actually fills in missing values. In the next code cell, your data is split into two parts, training and test. You can see on lines 21 and 22, xtrain and xtest. This is a common practice in machine learning. The training data is used to train your model, and the test data is kept aside and never shown to your model during the training phase. The model is then evaluated on the test data so that it makes predictions on unseen data, and you can see how well your model generalizes to new unseen values. These steps complete the pre-processing of our data. The next step is to use AutoML to find the best model. I'll just give you a little bit of context about this code that you see here that makes use of a library called MLflow. MLflow is an open source tool used for managing the machine learning lifecycle, tracking experiments, models, and deployments created within Fabric. MLflow set experiment will create this experiment, house prices prediction model experiment, and will log all the training runs of our model to this experiment so that we can compare the different models in one place. Next, what we have is the configuration for AutoML. Observe here that there are no models that you actually work with directly. All of that is abstracted from us. The settings dictionary that you see here, those are just the AutoML settings. Time budget is 180, so that is the total number of seconds that AutoML will train for. Task is regression, that's because we're performing regression analysis. Metric is R square, that's the metric that will be used to evaluate the model. N concurrent trials is set to 3 by default. That's the maximum number of trials that will run concurrently. There are many more settings here, but I just wanted to highlight a few important ones. You can actually tweak these settings in code if you want to change anything from the default that AutoML has picked. When I run this, an AutoML instance will be set up, and this AutoML fit will actually start the training process. The with MLflow start run will ensure that all of the training runs will be logged to your MLflow experiment. Once you execute this cell, you'll find that the training process runs through for about 3 minutes. That's what we had configured. And in this time period, there'll be a total of 3 models trained. How many models get trained? That depends on how large your data is and how complex the model is. It just happens to be 3 in this instance for us. All of these training runs will be logged within our experiment, and we'll see that in just a bit. Before we click through and look at our training runs, let's see what the code in the rest of this notebook does. I'll scroll down. In this code cell, the best model based on the R square metric is accessed, and that's registered with the MLflow registry. The model path accesses the run from AutoML's best run ID, and MLflow.register model registers the model with the registry, and that's where it's available for predictions. The model registry holds your model before you deploy it, and it maintains multiple versions of the model. You can see that version 1 of our model was created. In the next cell, the registered model, that is the best model found on our data, is accessed and used for predictions. The predictions are then displayed right here in our notebook and finally saved out to a delta table. And we now come to the last step in our demo. Review the model output and the predictions from the model. That's it as far as the code is concerned. Let's take a look at the 3 models that AutoML trained. Here are the 3 models. You can click through to the container and this will give you the 3 training runs. Right up top in the properties section, you can see the metadata details of the different models. And then off to the left, you can expand and view the individual training runs of the model. Now on this page, if you were to scroll down, you'll get the metrics for the best model that was trained on your data. Now, given just 3 minutes to find the best model, AutoML really didn't find a very good one. R square here is 0.48, which is pretty terrible. A good R square is one that's very close to 1 or 100%. That's because we quickly wanted to validate our data. We were not really looking to find the best model fit on our data. There are a whole bunch of other parameters available here as well. We don't need to worry about those. There are details about the algorithm that was trained, the design parameters used by the algorithm, and so on. This is important if you're a machine learning expert and you want to dig in further. But for now, let's look at the individual training runs. These were different models or different configurations of models that were trained. Here is one with an R square of 0.29. This is clearly a very poor model. Here is the second model that was trained, and the R square of this model is 0.48. This is what was designated the best model, the one with the highest R square. Let me click on the third model run here, And the R square for this model is pretty poor as well, 0.29. That gave us a quick overview of the model training runs. Let's head over to our workspace, and there in the Lakehouse, we'll find the predictions table that was written out by our Python code. So if you refresh here, you'll find a KC house data predictions table. And if you scroll over to the very right, you get the price column. This price column contains the predictions made by our model on the test data. In this demo, we'll use AutoML for time series forecasting. Time series forecasting involves identifying patterns in historical time ordered data to predict future values. It automates the complex process of selecting appropriate forecasting models, performing feature engineering specific to time series, and then optimizing hyperparameters to generate the most accurate forecast based on your data. Time series forecasting is typically used when you have historical data in the form of sales or profits and you want to predict what future sales or profits will look like. You have to have a metric that varies based on time. Let's get started. The very first step here is to upload the dataset that we'll be using to train our model to the data lakehouse. Next step will involve using the AutoML wizard to create, configure, and run the forecasting model. You can see that these steps are very similar to the steps that we followed for regression and classification. And then finally, we'll view the model runs and the metrics associated with the model runs. Let's start with the very first step where we upload our training data to the data lakehouse. I'm in my Fabric workspace and I click through to the lakehouse once again. I have the data in the form of a CSV file on my local machine. I click on the three dots next to the Files section and I go to Upload Files. This will allow me to select the daily store sales data that I have on my local machine. I hit Upload and this file is now available in my Lakehouse. You'll find that the data that I have in this file is very simple. All I have is a column that contains the date and then the total sales for that date. The most important detail to notice here is that we have daily data. This is important to know for your forecasting model because this affects your forecasting granularity. So with daily data, your forecast horizon will be measured in days and not weeks or months or years. Back to the file section, let's load this into a delta table. Click on the three dots, select load to tables, and we'll create a new table that will contain this data. Name of this table is daily store sales. We'll use the header as column names and it's a comma separated file. All good. Let's go ahead and load the data, and here is what our daily sales data looks like. This means we can go on to the next step. This is where we create, configure, and run the forecasting model. The steps for this are very familiar to us. Go back to the workspace and let's create a new item. And this new item will be machine learning model. Search for new ML model in the dialog that comes up. You'll need to scroll down in order to find this. Since this is a forecasting model for daily sales, I'm going to call this store sales forecasting model, and the asset will be created within our current workspace. The next step, of course, is to use AutoML. Click on the option to start with AutoML and this will bring up our familiar wizard. The first thing, choose your data, and your data should be in a Lakehouse table. Here is our daily store sales data. The next step is to choose the model's purpose. This is where you specify the task for the model. Go ahead and select forecasting. Now the options here are quick prototype or best fit. Other options for interpretable models or custom options are not present. We'll just go with quick prototype, click on next. This is where you configure what is it that you want to predict. Choose the prediction column, and since there are just two columns available, it's pretty clear what you want to predict: the daily store sales. Total sales will be your prediction column. Next, you specify what column contains the time series data, that is our date column. It's quite possible that you have multiple dates in your data and only one of them forms the actual time column that you use for forecasting. That's why this specification is important. Next, you specify your forecast horizon and frequency. The forecast horizon defines how far into the future you want your model to predict values. We have daily data, and setting the forecast horizon to 1 means that we want to predict for the next day with all of the historical data that we have. Let's say we had weekly data and we had set a forecast horizon of 3. We want to predict for the next 3 weeks. The frequency specifies the time interval between the data points in our time series. It tells the forecasting model the granularity of our historical data and the steps at which predictions should be made. Our frequency is daily, and I set that accordingly. Next, we have the usual manage input data, where we specify how we want the missing values in our data set to be imputed. We'll stick with auto. Click on next, and let's go on. We'll use pandas data frames to train our model, and this is where we can specify the name of the notebook that will contain the forecasting code. I have my sales forecasting notebook, and the experiment will be called Store Sales Forecasting Model Experiment. Click on next. Here is a quick review of everything that we've configured. Click on create, and this will set up the AutoML notebook that will contain the code for forecasting. This is something that happened automatically the previous time, but here I wanted to tell you that in order to run this notebook, you need to connect to a Spark session. AutoML makes use of the Spark distributed processing system to perform a variety of operations, definitely to read data from delta tables and write predictions back to a delta table. Fabric manages the Spark cluster behind the scenes, and you connect to it via a new session. Select new standard session, and we are now set up to run this notebook. I won't walk you through some of the steps that are familiar to you, like installing scikit-learn 1.5.1. Please make note of the version of scikit-learn that you're using to train this model. In fact, the version of all of the libraries. It will become important at the time of prediction. Then there is some logging, reading in the data frame. And once you read in the data, there is display X that will just print out the features that we'll be using for training. This is the data that AutoML will work with to predict whether someone is promoted or not. Now, here's something that I've noticed. For basic use cases, you can directly use the code generated by AutoML, but AutoML often needs some tweaking. So even though it's a no-code feature, you still may have to go in and write code in certain use cases, as we are about to do now. Now, the code that I added here, I added after doing a bunch of debugging. I'll show you the changes that I've made, and then I'll explain why I needed those changes. Take a look at the data types of the X variables that the model will use for prediction. Observe that we have a few numeric data types, and all of our categorical variables are of type object. This means that the categorical columns are basically strings. Now, the way AutoML generates its code, it only considers numeric columns and columns of type category to be included as features to train your model. It will not by default include columns of type object amongst its features. So you are going to have to fix this. I'm going to change all of the columns of type object to be of type category, because those are all categorical variables that I want to include in my model features. And now when you run this code, you can see that the data types for the X variables have been updated. All columns of type object are now of type category. This means that AutoML code will now include these variables as a part of its machine learning training. When AutoML performs classification, it displays a simple visualization to show you how many records you have in every category in your dataset. You can see that our dataset is highly skewed. We have a large number of records where the employee was not promoted and very few records for when the employee was promoted. The dominant class has 91.48% of the samples. When you have an imbalanced dataset, machine learning models generally can't perform well because there are too few records of the minority class for it to be able to really learn from your data. AutoML is warning us here that there is additional pre-processing we may need to do, or we may need to change the algorithms that we use with this data in order to get a good model. This pre-processing might involve oversampling the minority records so that we have more records of the minority class, or use certain models that work well with imbalanced datasets. AutoML does not perform class balancing automatically. This is something you have to do yourself. At this point, it's not as automated as we'd like it to be. We're not going to make any changes as far as balancing the dataset goes. We'll just continue looking at the rest of the code. Here's the code to impute the missing values that exist in our data. This existed for the regression model as well. Next, we have the code where AutoML splits our data into training data and test data using train test split on line 16. Notice the code on line 11 where it chooses what columns from our X data frame should be used for training the ML model. AutoML only selects columns of types number, date, time, and category. If you remember, we had all of those categorical variables where the data type of the column was object. Because of this bit of code on line 11, those categorical columns would not have been included at all in model training. Now, since I wanted those columns to be included, I just changed them to be of type category so that this select D types code would select those columns. So like I said, automated machine learning is not fully automated yet. It generates the code for you, but you have to know how to tweak the code yourself to leverage the full power of machine learning on Fabric. When you execute this code cell, it will display the features from your data that will be used for machine learning. This is what I inspected and I found, wait, the categorical columns are not included. And the reason for that were that they were of type object rather than of type category. But now that we fixed that, you can see all of the features that will be used to train the model. Now we've said that AutoML training can run for a maximum of 30 minutes. All of the training runs will be logged to this experiment. MLflow set experiment will set the container that will hold the runs. Next is the specification for the AutoML settings in the form of the settings dictionary. Our time budget is set to 1800 seconds, that's 30 minutes. Task binary specifies binary classification. Another interesting setting here, use Spark true. This will make use of the underlying Spark distributed cluster for distributed training. This is all that we can configure in AutoML. Let's go ahead and run the AutoML trial. And you'll find that there'll be many more runs because we're running for 30 minutes. That's the maximum. It'll run for as long as it needs to find the best possible model on our data. The time budget of 30 minutes is the maximum duration. If AutoML finds that the model performance isn't improving after its tuning, then it'll simply stop training at some point in time. You can see that about 10 models have been trained, and if you click on the Run Comparison tab, you'll get a nice visual showing you the validation loss for the different models trained. The validation loss tells you how well the model's predictions perform against the actual values in the validation data that it's using. You can see that for certain models, the validation loss is higher than others. AutoML is still figuring out the best possible model. Training is still running. This chart is interactive. You can hover over the data points and see what training run produced this particular validation loss. Training is still running and many more model runs have been generated. Once training is complete, let's take a look at the run comparison chart, and here is what the validation loss looks like across runs. You can see that at some point at the right, it flattens out at a lower level and stops improving. That's when AutoML terminated training for our model. Before we examine the model and its parameters, let's run the remaining cells in this notebook. This is where we register the model, so a new version will be created for our model. And then we use the registered model to generate predictions. These predictions are displayed here in the notebook and also saved out to a table in our Lakehouse. Let's not worry about the predictions generated by the model here. Instead, in the next video, after examining the model parameters and performing run comparison, we'll use a wizard to perform batch prediction with this model. At this point, we've trained our classification model using the notebook that AutoML generated. We are ready to take a look at the result. Now, AutoML trained several different models and each of these were logged as a different run. And here are all of the runs right here within the notebook. I'm just going to select and click on one of these at random, and this will open up a view that will allow us to see the parameters of the run. Here is that view. This is a view of the experiment within which we have the models that were trained, and if you expand the model, you'll see the individual training runs for each model. And there are more than 20 plus runs. Let's select one of these runs. I've picked them at random. Here you can see the name of the run. This is child 0, the very first run that was executed, and you can see the metrics of the run. The default metric that's used to evaluate classification models in AutoML is the area under curve, the ROC underscore AUC, that is the receiver operating characteristic curve. The ROC is an actual visual representation. It's a graph showing a classification model's ability to distinguish between classes and is an indicator of how good the classification model is. The AUC represents the area under this ROC curve, and it gives you a single scalar value summarizing the model's overall discriminative power. The AUC value ranges from 0 to 1. An AUC between zero point 0.7 and zero point 0.8 is generally considered acceptable, and between 0.8 and 0.9 is considered good or excellent. So for this very first run, the AUC was about 0.7, which is pretty decent. Let's select one more run and take a look. Here the AUC value is 0.68. So this particular model that was trained with whatever design parameters it had wasn't that great. Let's select another one. And this one, the one that I've selected, seems to have performed a lot better. You can see the AUC value is 0.8. There was code in the AutoML notebook to automatically select the model training run with the best evaluation metric, so with the best AUC, and that would have been deployed and a version of that available. Now, if you'd like to compare the different runs and the validation loss and the AUC values for the different runs, click on this View Run List button, and this takes you to a page which lists all of the runs within this particular model training here on top, and you can select the runs that you're interested in. This will give you a nice visual representation of the various parameters of the run: validation loss, iteration counter, and AUC. The top pane has all of the runs listed, and I've selected all of the runs, so I get an overall view. Let's expand this. On the very left, we have the validation loss. The validation loss is a metric that tries to capture how far away the model's predictions lie from the actual values in the data that's being used to validate the model. You can see in the initial few spikes that the validation loss tends to be high at the start, but later on, the validation loss falls to a low level. The iteration counter is simply a steadily increasing counter which numbers the model runs. So this doesn't have much meaning. The ROC AUC gives you how well the model performed. The validation loss is used to guide the optimization of the model, but the final ranking and selection of the best model is done via this metric. The final model that would have been registered with the model registry in Fabric will be the one with the highest ROC AUC. These charts are interactive. You can hover over these charts and view the actual values of validation, loss, and the ROC AUC score for the different model runs. We are now ready to move on to the next step in our demo, using the model for predictions, and we'll do so using the prediction wizard. Now let's actually work with the registered model, the version which had the best AUC, and have it make predictions for us. Now you should find a tab somewhere at the top of the screen for the model itself, the promotion prediction model. If the tab is not already open, you can head to your main workspace and click through to the promotion prediction model, and you may have to hit refresh. Once you hit refresh, you'll find that a single version of the best model trained so far has been registered here. This is version 1. If you have other training runs for your model and you register new models that have better scores, you'll find that new versions will be available. And then you can pick and choose which version you want to deploy to production. You can see that version 1 of the model was created from child 20. So the 20th run, which had the best AUC, is the one that is registered. If you're interested in viewing the metrics and the parameters associated with the version of the model that has been registered here with the model registry, they are available here. You can see its AUC is 0.813. Now let's say you have some employee records in your data lakehouse and you'd like to use this model for prediction on those records. This is an example of batch prediction where you perform prediction on a whole batch of records. If you click on apply this version, you'll have under batch scoring an option to apply the model using a wizard. This will walk you through the process of selecting the table which contains your records for prediction and then apply the model on all of those records. Let's select the Looney Lakehouse in our Power BI workspace because that's what we've been working with so far. And I'm going to select the HR Analytics dataset once again. Now, this is the data that we use to train and validate the model. Typically, this is not the data you'd use to perform prediction. The model has already seen those records earlier, and the prediction result from the model is not a true test of how the model performs in the real world. However, the only data that I have available is the data that we use to train the model. I don't have a separate data set with the same features that the model requires. So I'm going to go ahead and select the training data itself. Once again, this is okay only as far as our demo is concerned because I just want to show you how the prediction process works. I'm not actually focused on evaluating the model that we've just trained, which is why I'm going to select the table with the training data. Here you can see the input table HR Analytics is going to be fed into our promotion prediction model version 1. The input columns or the features that will be used for prediction are listed here. Please note that the target column is promoted, even though it's present in the table, it's not used for prediction. These are all of the columns that we use to train the model. The same columns or features need to be available in the prediction instances as well. Click on Next. Here I specify the name of the table where the predictions will be stored. I just called it Predictions Table. Next, let's move on. The final step is map to output. What should be the name of the output column which holds the prediction? I'm just going to call it predicted. The output from the model will be called is promoted, but I'll save it as predicted in the final result. This wizard configures a notebook behind the scenes that accesses the model using Python code and then uses it for predictions. Here is my notebook name, Promotions Predictions Notebook. This will be saved as a notebook in my Fabric workspace. And here is a preview of the code snippet used for predictions. The data is read from the original HR Analytics table, and the data with the prediction information is stored out in the predictions table. The MLflow transformer takes the input data and feeds into the model and gets the predicted results from the model. The input calls contain the features used for prediction. The output call is the predicted column that will contain the output from the model. The model name and model version are the model that we use for the prediction. We just have one version of this promotion prediction model. This is just a preview of this code. Go ahead and click on Next and let's create the notebook. This prediction wizard sets up the notebook that you can simply execute to get predictions. Now, all you have to do is execute this code cell that you see here on screen. But when I did that, I encountered an error. And scrolling down to the very bottom, the error seemed to say that the model could not be loaded because some attribute underscore remainder calls list could not be accessed on some scikit-learn column transformer packet. Now, I must admit this left me a little confused to start off with. But then I realized that this is a scikit-learn problem. There is something that the model is looking for in a scikit-learn package and it's not available. This means that there is likely a mismatch between the version of scikit-learn that this prediction code uses and the version of scikit-learn that our model was trained on. If you remember, and I pointed this out to you when we had trained the model, we had installed scikit-learn 1.5.1 and that's what we had used for model training. You need to add that pip install in this notebook as well. The scikit-learn version that we use for prediction should exactly match the version that we used for training. Only then will the model work. Once you have the right version of scikit-learn, execute the code for predictions and you'll see that it will run through just fine. And of course, the predictions are stored in an output table. That's the table we'll look at now. Head over to the Looney Lakehouse. And the Lakehouse view may not have refreshed yet, so make sure you click on the three dots and click refresh so that the tables are refreshed. And you should find a table called Predictions Table. This will contain all of the original data on which we performed predictions. And for the purposes of this demo, we just did it on the training data. And you have a predicted column at the very right. Because our data was fundamentally imbalanced to start off with, you'll find that the predictions are not great. This is not an amazing model because the data set is fundamentally skewed. There are not enough records within the data set of employees who have been promoted. This means you can see that the predicted column does predict promotions for a few employees, but very few. It gets most of them wrong. When we work on Microsoft Fabric, you work within a workspace, and a workspace contains all of your Fabric assets, and this includes your Power BI reports, your semantic models, everything. Now, in any organization, you might have workspaces for different purposes. For example, you might have a development workspace where you try out new things. The development workspace is where you prototype and experiment. You then might have a test workspace where you test your assets before pushing out those assets to production, ready to share your Fabric assets with the world, and you'd like that to be in a different workspace. That would be your production workspace. Easy way to achieve this is via deployment pipelines on Fabric. They provide a structured way to manage the lifecycle of your BI content. Deployment pipelines create an assembly line with development, test, and production stages where every stage is a workspace. This helps you build, validate, and release your content safely. Your experimental content will remain in your dev workspace, your test workspace is for testing, and only live reports and live data will be available in your production workspace. In this demo, you'll see how you can work with deployment pipelines. We'll first set up the dev workspace and the deployment pipeline itself. Now, the deployment pipeline is not associated with any specific workspace. It's just part of Fabric. We'll then set up a test workspace and do our first deployment from our development environment to our test environment. We'll then deploy once again all of our assets from our test environment to the production environment. Once your assets are live in production, it doesn't mean prototyping has stopped. We'll simulate this by making a change in the dev workspace, and then we'll redeploy our workspace assets from dev to test to prod. And finally, we'll check that our deployments have been successful by verifying continuity across environments. Let's start with the very first step in the process, setting up the dev workspace and pipeline. Now, here I am in our workspace, Looney Workspace Power BI. So this is not the one we are going to be using for the deployment pipeline. Click on the three dots off to the left, and you should find an option for deployment pipelines. Go ahead and select this. Remember, your deployment pipeline does not belong to a specific workspace. The deployment pipeline manages the lifecycle of your assets across workspaces. So it's not associated with a workspace in Fabric. Now you can see the steps involved in working with deployment pipelines. Let's get started. Click on New Pipeline and give your pipeline a name and maybe a meaningful description. I've just called it Looney Pipeline. And immediately you can see that the three stages of your pipeline are set up for you. The development stage is where you'll prototype your Fabric assets. The test stage is where you'll test your assets, and they'll go live in the production stage. Now, dev, test, and production are the standard names for these stages, but you can rename these stages if you want to. Let's say you want to call the development stage prototyping. Since that's more common in your organization, click on the edit button and change the name of the stage. However, having these names be dev, test, and production or development, test, and production, these are pretty universal. So we'll just stick with these names. Click on create and continue. One thing I should tell you here is that the UI that you're seeing is the new UI for deployment pipelines. There is an old UI that's also available. I should warn you upfront that at the time of this recording, this new UI is very new and it's kind of glitchy. You might expect a button to be available and enabled, but it's not. You can switch back and forth between the new and the old UI till this problem is completely fixed. I'm sure at some point they'll completely retire the old UI and just have the new one. Now, with one of the stages of this deployment pipeline selected, you can open up this pane here at the bottom, and this will show you what assets are present in that stage. Now, we haven't assigned a workspace here to any of these stages, and that's why there are no assets listed in the bottom pane. Let me quickly show you how you can use the old UI if needed. Simply select the slider and slide it over to the left. And what you see here is the older UI for the deployment pipeline. We still have our three stages: development, test, and production. And you can see there isn't a workspace assigned to any of these. Now, I prefer the old UI in some situations and the new UI for others. So it's good that you should know how both of these look. Let's go back to the new UI and let's take a look at the deployment history of this deployment pipeline. And this should be absolutely empty. We haven't performed any deployments yet. It's also possible for you to share this deployment pipeline with other team members so that they can work with this as well. Manage access will allow you to set up sharing. And finally, if you click on this settings icon, you can configure the settings for this deployment pipeline. Right now, we just have the pipeline name and the description. And finally, if you no longer want the pipeline to manage your assets, you can delete the entire pipeline. The next step is for us to assign a workspace to the first stage, the development stage. I'll create a new workspace for this and create some assets in that workspace. I'm going to call this workspace Looney Workspace Dev, so it's very clear what this workspace is meant for. It's meant for creating new assets that's primarily used for prototyping and experimentation. Now, here is our new workspace. It's completely empty. Let's create some fabric assets in this workspace, and I'm going to create a few different types of assets. I'll walk through the creation of these assets very quickly since that's not the point of this demo. The first asset that I create is going to be a lakehouse. We've already seen how to create a lakehouse, and I'll create a lakehouse called Looney Lakehouse within my dev workspace. Our lakehouse has been successfully created. Let's create one more asset, and I'll now create a fabric warehouse. A warehouse is where you'd store structured data meant for business intelligence. I'm not going to add any data or anything else to the warehouse. I'll simply name the warehouse and ensure that it is created. The next asset that I create is going to be a notebook. Click on New Item, select Notebook, and I'm going to leave this notebook completely empty. Fabric notebooks have data sources associated with them, and if you want, you can add a data source to this notebook. I'll just pick one of our existing data sources. In fact, I'll pick the Looney Lakehouse that we just created in the dev workspace. Let's give our notebook a meaningful name so that we can identify it. I'll just call it Looney Notebook. At this point, I have a lakehouse, warehouse, and a notebook, all fabric assets. The next thing I'm going to do is create a Power BI semantic model and a Power BI report. You can do this by selecting report as the new item. Then, of course, you have to get data. Simply upload any data set from your local machine. It doesn't matter what the data set is. You don't need to transform the data. You don't need to do anything. Remember, this is all towards another objective, creating assets that we can use for deployment via the deployment pipeline. When you create a report, you'll be asked to create a semantic model as well. So I have my Looney semantic model, and here is my report. I'll just name the report. I'll just call it Looney Report for the lack of a better name, and I hit save. I have all of the assets that I plan to work with at this point in time. Let's take a look at our workspace. The lakehouse, the warehouse, the semantic model, the report, and the notebook. Now that we have a workspace full of fabric assets, let's head over to our deployment pipeline. Select deployment pipelines from the left navigation menu, and let's assign this dev workspace to the development stage of the pipeline. Once you perform this assignment, you'll encounter a warning dialog. Workspace includes unsupported items. There are certain types of fabric assets that will not be deployed using deployment pipelines. And the two examples that we have are our semantic model and the Looney report. At the time of this recording, Power BI assets are not supported by deployment pipelines. That's what this warning is telling us. You can have those assets in your dev workspace and still have that workspace be part of the deployment pipeline, but those assets won't be moved to the other stages. They won't be moved to test nor to production. I now have the workspace assigned to the development stage, and if you expand the pane at the bottom, you'll be able to see what the assets are in this workspace. You can see the lakehouse, the notebook, and notice Looney report and Looney semantic model. The compared to source column says unsupported. These are not supported by deployment pipelines. Now, there'll be a time when you finish prototyping and experimenting with these assets and you'd like to deploy to test. Well, you need a workspace for test. Let's create a new workspace called Looney Workspace Test, and we'll assign this workspace to the testing stage of the deployment pipeline. Now, this test workspace that we've created is initially empty. It has no assets. Here is our pipeline, and I'm going to assign the test workspace to the test stage of the deployment pipeline. Before you run this notebook, you need to be connected to a session. Click on Connect and choose the standard session. We don't need a high concurrency session since we are just running a simple forecasting model. The AutoML forecasting code at the time of this recording was a little buggy. I had to make a few tweaks to the code in order to get the right output. I'll show you what they were. Let's install scikit-learn. It will be used behind the scenes for some of our forecasting models. I'll only walk you through the most relevant code cells in this notebook. I'll ignore the others. Here is the code cell where we actually read the data and set up a pandas data frame. Display X will display the data that we are working with. It's great for a quick sanity check. This is our time series data. And we come to the code here which has a little bug. The bug in this forecasting notebook, specifically for the data that we are working with, is with this code cell, create fill NA processor and the fill NA operation. Now, we won't worry about what this bug is, but I'll show you what its manifestation is. After we perform the filling in of missing values in our dataset, we split our dataset into train and test. You can see the train test split function on line 20. The most important detail to understand in that particular line of code is shuffle equal to false. This data is not shuffled when we split into training data used to train the model and test data used to evaluate the model. That's because with time series data, there is an inherent order to the data. The data is arranged in terms of date, and the fluctuations in the data based on the dates is important for the model to pick up. This train test split uses the first 80% of the data to train the model and the remaining 20% to evaluate the trained model. In order to show you the bug that this AutoML code introduces, I'm going to print out the shape of the training and test data. So here is my print statement on line 22. The shape of the data is the number of rows and columns in the training data as well as the test data. I print out the shapes of the data before we run the code on lines 26, 27, and 28. These three lines of code fill in missing values in our data. Shapes of the data will tell us the number of records in the data before we run the code to fill in missing values. And then I'll print out the shapes of the data after we run the code to fill in missing values, and you'll see that something is off. So let's go and execute this particular code cell. You can see that we have 400 records in the training data with 2 columns and 100 records in the test data. This is the 80% 20% split that we saw in train test split. Now let's continue. I'll show you what the bug is. I'll add a new code cell and I'll print out the shape of the training and test data after we filled in the missing values. Now there are 2 things that jump out here. The first is that the training data contains just 1 column instead of 2. That is actually correct. The input features in a forecasting model include just the date series. What we are trying to predict is the sales number for those dates. The sales numbers form the target for the forecasting model. What's strange and what's the bug here is that the test data contains 200 records instead of the original 100. And then I used xtest tail 10 to look at the last 10 records in the test data, and you see they're all for the same date. So the code for filling in missing values is somehow buggy. It simply duplicates one of the dates 100 times to double the number of records that we have in the test data. We can fix this in a very easy way in this particular data set. We simply won't fill in missing values because I know that this dataset does not contain any missing values. I've commented out all of the lines of code where we fill in missing values, and I'm going to re-execute this code cell. So this gives us 400 records in the training data and 100 records in the test data. That's before the code for filling in missing values. Since we are no longer filling in missing values, if you execute this line of code, you'll see that the result will say 400 and 100. Let's take a look at the last few records of the test data to make sure that everything looks right. You can see that these records are all different dates. Our example here and our previous experience with the classification model should have made it clear to you that AutoML, though very useful to give you the initial coding template that you need, is not completely a no-code solution. Let's continue executing the cells in our notebook. This is where we set up the experiment for our sales forecasting model, and then we configure the AutoML trial and settings. Now, by default, the time budget allocated was 2 minutes. That's because we used the quick training for AutoML, I've just increased that to 300 seconds. So we'll train for 5 minutes. This will allow AutoML to try many more model combinations with different design parameters, that is hyperparameters. The task setting is what tells AutoML what kind of ML model we like to train. A forecasting model, TS underscore forecast, time series forecast. An interesting detail to note here is the estimator list. Notice that it has estimator, LGBM, XGBoost, extra tree, XGB limit depth, and profit. These are all the algorithms that will be used for time series forecasting. Many of these are actually not time series algorithms. Other than profit, XGBoost, extra trees, XGB, all of these are algorithms that are used for regular regression analysis as well. So how are they used for time series forecasting? AutoML automatically sorts your data by the time column and it creates lag features. So for any time t for which you're trying to create a forecast, it'll use features like the value of sales at time t-1, t-2, t-3, etc. It'll also compute average values of sales over the last 2 days, 3 days, 4 days, and so on. In this way, it trains the model to predict the target at time t using information from time t-1, t-2, all the way till a certain time in the past. Thus, it uses the past to predict the future. Now that you've understood the basics of forecasting, let's go ahead and create an AutoML instance and run the AutoML trial. AutoML now will train a variety of different models with different hyperparameters and will allow you to compare runs and give you the final result. Let's expand this and take a look, and you can see a total of about 4 different models have been trained. Let's do run comparison, and here you can see the validation loss of the 4 models. We look at the individual runs of the model in just a bit. Meanwhile, let's register the model with the model registry. That's what this bit of code does. You can see version 1 of the sales forecasting model was created. Let's now get the model to predict on the test data. This will be the best model that was found on our data. And here are the predictions. The predicted values will be a sales forecast for every date that we have in the test data. Let's compare the actual values against the predicted values by putting them together in a pandas data frame. That's what this additional bit of code does. When you run this code, you'll see for every date in the test data what the actual value was from our dataset and the predicted value from the model. So how does this model get a predicted value for the very first date in the test period? Well, the first date in the test period is just after the last date in the training data. The model will use information from the training data to make the prediction for the first date in the test period. To get the forecast for the second date in the test period, it will use the predicted value from the first date and any information that it needs from the training data, and so on and so forth for all the dates in the test data. We'll just save the predictions out to a delta table within our Lakehouse, and then we'll go ahead and take a look at the individual runs of the model. This brings us to the last step, step 3 in our demo, view the model runs and metrics. Let's scroll back up in our notebook to where the AutoML training runs were listed. Let me click through to the model. This will open up a tab within Fabric where you can select the individual model runs and view the parameters. You have the main model selected and you take a look at the run details, you'll get the details for the best model that was trained on this data. And the default evaluation metric for a forecasting model is MAPE or MAPE. This stands for mean absolute percentage error, and it's used to measure the accuracy of a time series forecast. It tells you on average what percentage of your forecasts are off from the actual values. A MAPE of 10% means that on average your forecast is 10% away from the actual value. So lower values of MAPE are clearly better, and the best MAPE value that our models were able to achieve was 0.19 or 20% roughly. You can click on the individual model runs to see the MAPE scores for the different models that were tried out by AutoML. Here is a MAPE score of 0.22. Let me select one more run here. This is our best model. You can see it has the same MAPE score, 0.1925. And finally, if you'd like to compare all of the runs of your model, click on View Run List. This will allow you to select whatever runs you want to compare. I'm just going to select all of these And below you can see the charts showing you the validation loss, the iteration counter, and the MAPE scores. This gives you a single visualization where you can see how your model runs performed. At this point, we've set up the deployment pipeline and we've set up the assets in the dev workspace. We are ready to perform our first deployment from the dev workspace to the test workspace. Now let's go to our deployment pipeline, and here I have the test stage selected. If you hover over this little indicator that you see here on screen, you can see there are changes made to the content since the last deployment. We haven't deployed yet, but essentially what this means is that these two stages, the dev and the test stages, are out of sync. We have assets in the dev stage that we haven't yet pushed out to the test stage. Now, if you select the test stage and look at the pane at the bottom, you'll get a list of assets that can be deployed between stages. And if you look at the compared to source column, you can see that there are these three assets, our Lakehouse, Warehouse, and Notebook, that are only present in the source. You can deploy to a particular stage only from the previous stage. So you can only deploy from development to test. Let's now perform the deployment. Now this new UI is glitchy, and for some reason, the deploy button wasn't enabled. I'm just going to switch over to the old UI. And here you can see the deploy button is very much enabled, and that little orange icon that you see tells you that there are changes in the dev stage that are not present in test. In the old UI, the classic UI, you can click on this icon to expand and view the assets that are present in each of the stages. You can see the Lakehouse, Notebook, and the Warehouse in the dev stage, but they're not present in the test stage. Let's fix that by clicking on deploy. You get the warning about unsupported items, our semantic model, and our report. That's totally fine. Let's continue. Click on continue, and here you can see the assets that will be copied over to the test stage, to the workspace in the test stage. And we'll continue deployment in case one or more items fail. Now, the deployment is in progress, and in a few moments, you'll find that the test stage is now up to date with the dev stage. Once you see this green checkmark icon between two stages, you know that those two stages are in sync. And if you now take a look at the workspace in the test stage, you'll find all of the items that were present in the dev stage, all of the Fabric assets that could be deployed. We'll do that in just a bit. Meanwhile, let's switch over to the new UI, the new deployment pipeline UI, and you can see there is a successful deployment message there for you. And if you click on deployment history, using that little icon, you can see the details of our current deployment, deployed to test, and number of items. If you expand this, there are our 3 Fabric assets that are supported by deployment pipelines. You can also view the assets in your test stage in the test workspace using the pane here at the bottom. You can see the 3 assets, the Lakehouse, Notebook, and Warehouse. If you look at compared to source, it says same as source, where the source here is the development pipeline. Now let's head over to the test workspace and take a look at the assets within it. And here are the 3 assets that were deployed from dev. These assets will be identical to the assets that we had in the dev workspace. If you click on the notebook, notice the notebook contents are exactly the same, including the data items that the notebook is connected to. Observe that the notebook in the test workspace is connected to the Lakehouse in the test workspace. Fabric ensured that the connection was updated as well. Your notebook in the test workspace does not point to the Lakehouse in the dev workspace. When you use deployment pipelines, Fabric ensures that all of your assets and even related connections like these are updated correctly. Back to our deployment pipeline, at this point, our dev and test stages are completely in sync, which means we can move on to the next step. We can deploy from test to production. Let's say all of your tests are now complete, you're confident in those assets, and now is the time to set up production workspace and move these assets to production. Click on apply and create the Looney workspace prod, and this workspace will initially be empty. We just created it. Don't worry, this is something that will be fixed once we deploy from test to prod. Back to deployment pipelines, let's assign this workspace to the production stage. You'll see that yellow highlight and icon indicating that that stage is not in sync with the previous stage, the test stage. With the production stage selected, If you look at the contents of the pane below, you can see that the three assets in the test stage are Lakehouse, Warehouse, and Notebook. And the compared to source column tells us that these are only present in the source. And the source, of course, is the test stage. That's the stage that production is connected to. Let's go ahead and deploy these assets to the production stage. The new UI still has the glitch where the deploy button is not enabled. So I'll just switch back to the classic UI to perform the deployment. Here is the deploy button, it's enabled. Before I click on that, notice the orange icon between the test and production stages indicating they're not in sync. The icon between the dev and test stages is the green check mark indicating that those two stages are in sync. Click on the deploy button and you'll get a dialog confirming what fabric assets will be deployed. Continue deployment in case one or more items fail. I leave that checked. And in a few moments, all of the assets in the test stage will be pushed to the production stage. They'll be copied over to the production workspace. And you can verify that by clicking on the show more link that you see there. Here are our three fabric assets, the Lakehouse, the Notebook, and the Warehouse. Let's just switch over to the new UI and see what a fully deployed pipeline looks in the new UI. I have the production stage selected, and in the pane below, you can see compared to source says same as source. So all three fabric assets match the source, that is the test stage. Our final verification here is by looking at the prod workspace directly. Open up the workspace and you should find the three fabric assets there. Back to the pipeline by clicking on the icon on the left, and let's take a look at deployment history. There should be two deployments here, two test and two production. Now your development team is probably constantly making changes to the dev workspace. Maybe they're adding new assets, maybe they're changing existing assets. Let's simulate that. So let's make a change in the dev workspace corresponding to the dev stage of our pipeline. What I'm going to do is just create a new lakehouse. That's the simplest change I can think of. I'll just call this Looney Lakehouse new, and you can see that it's in the dev workspace. Click on create and the new lakehouse will be created. We now have a new fabric asset in the dev workspace that's in the dev stage of the deployment pipeline. Back to our deployment pipeline, and you can see from the change in color and icon that the test stage is no longer in sync with the development stage. I have the development stage selected, and you can see the fabric assets in the development stage. You can see our Looney Lakehouse new in here. Let's select the test stage. The last entry says that there is a lakehouse that's present only in source. So it's not present in the test stage. So let's go to the next step in our demo. We'll redeploy all the way from dev to test to prod. Deployment, of course, requires us to go back to the old UI, the classic UI. Let's go ahead and flip that slider over. The orange icon between the dev and test stages tell you that these are out of sync. The green icon between the test and production stages tell you those two are in sync at this point in time. I'll now deploy from dev to test. Click on continue. These are unsupported items, we know that. And then click on deploy. Observe that there's only the new lakehouse that's going to be deployed from the dev stage to the test stage. The deployment is now complete. Notice the green check mark between the dev and test stages showing that they are in sync. But now the test and production stages are no longer in sync because the test stage has changed. The workspace in the test stage should have the new lakehouse, and you can see that's present in here. And if you click through and look at the workspace itself, you'll find Looney Lakehouse new present in the workspace. Now that we verified this, let's head back to our deployment pipeline and now push from the test stage to the production stage. First, let's look at the differences. What's different? Well, the original assets are present, but Looney Lakehouse new is not present. That is the fabric asset that we need copied over to our production workspace. And clicking on deploy should accomplish this. Go ahead and hit deploy. That's the confirmation that we want Looney Lakehouse new to be deployed. And the deployment is now complete. And of course, you should do a quick sanity check to make sure that the new lakehouse is present in the production workspace. And indeed it is. We can now move on to the last step in our demo, where we verify continuity across environments. We'll just check to make sure that all of the assets are present in the right environments. First, let's look at deployment history. We've had 2 deployments to test and 2 deployments to production. That looks correct. You can see that originally production had 3 assets and then we added 1, that is the new Lakehouse. Originally, test had 3 assets and we added the 1, the new Lakehouse. Things look good here. You can also click on the Show More icon to see what assets are present in each of the 3 stages to perform a final verification that the assets are set up correctly and that the deployments have gone through fine. This verification can be performed in the new deployment pipeline as well. Simply click on the different stages of the pipeline to verify what assets are present on each of these stages. If you see same as source in the compare to source column across all stages, you know that the pipeline is fully deployed and all stages are in sync. In this demo, we'll see how you can load and transform data using data flows, but we won't work with regular data flows. We'll be using Copilot. We'll be working with Dataflow's Gen 2, which is the data integration and preparation experience within Microsoft Fabric, and it utilizes the familiar Power Query interface to ingest, clean, mashup, and transform data. Copilot assists with Dataflow's Gen 2 by helping you create and understand Power Query steps using natural language. We'll describe the transformation that we need to perform, and Copilot will generate the corresponding M code and add the transformation to the data flow. Let's take a look at the steps involved in this demo. We'll first create the destination where we'll store the transformed data. That's going to be a lakehouse. If you've not worked with lakehouses before, I'll explain what it is in a bit. We'll then load the source CSV into a data flow Gen 2 and then explore and deduplicate the records in our data. Now, let's say this is data that you are planning to use for machine learning. You may want to label encode the categorical columns, that is, convert the categories to a numeric format. I'll show you how you can do that with Copilot's assistance. We'll clean and handle missing data in our datasets, and we'll write the data out to a lakehouse destination. And we'll view this data in the lakehouse. Let's start off with the very first step here, creating the lakehouse destination. Now, a lakehouse in Microsoft Fabric is a modern day data architecture platform for storing, managing, and analyzing structured, semi-structured, and unstructured data in a single location. A lakehouse is a storage architecture that combines the flexibility and scale of a data lake with the structure and querying capabilities of a data warehouse. Here I am in my Fabric workspace. We'll continue working in the Looney workspace Power BI. Click on the new item and I'll now create a new lakehouse. In the dialog that pops up, find the lakehouse option and select it. All this will ask for is the name of the lakehouse. Simply call it Looney Lakehouse and hit create. You'll have to wait a few moments for the lakehouse to be created. And once that's done, let's take a look at the major components that exist in the lakehouse. Off in the left sidebar, you can see there are 2 components, files and tables. Both of these are currently empty. Let me select files and let me explain what goes in here. I'd mentioned earlier that the lakehouse is a storage architecture that allows you to store structured, semi-structured, as well as unstructured data. In a Fabric lakehouse, the file section acts as a file explorer for the underlying data lake storage. This is where you'll store data in the raw or semi-structured format like your CSV files, JSON, Parquet files, and you'll organize them into folders. The table section is currently empty. This is where you'll store your processed and transformed data. This contains data organized into structured tables that are known as delta tables. These have defined schemas, they support ACID transactions, and are optimized for SQL queries. The next step in our process is to create a data flow to import our CSV file, and this is where we perform the transformations as well using Copilot. That's the core of our demo here. Data flows are the dedicated extract, transform, and load engine for Microsoft Fabric. Back in our Fabric workspace, where we now have our data lakehouse created, click on New Item to create a new data flow. Search for Dataflow Gen 2. That's the latest version that's recommended that you use. You'll need to specify a name for this, Looney Diamonds Dataflow Gen 2. Click on the Create button. and this data flow is now available in our workspace. Click through to the data flow. We'll now access the CSV data that's on our local machine and apply transformations using Copilot. Select the option to import from a text CSV file. Here you'll need to connect to a data source. The data is available locally. You can simply browse your local machine to access the data source. I'm working with the diamonds dataset that I downloaded from Kaggle, and you can see that it needs cleaning. That's why I've named it as such. Click on the next button. Here you can quickly preview the file that we'll work with. You can see that every record contains information about a diamond, and we have information such as the carat, cut, color, clarity, its XYZ dimensions, and price. Go ahead and hit create, and this will open up the Power Query editor. Now you should know that even though we have the same editor interface, data flows run on the cloud. When you work with Power Query in Power BI desktop, that's running locally on your machine, whereas this will run on Fabric on the cloud. Off to the left, you see the steps that have been automatically added when we loaded data in. Our headers in the first row were promoted and the column types were changed based on what Power Query inferred. Power Query uses the M programming language, which is very powerful for transforming and working with data. The Power Query editor generates M code automatically when you use its navigation menus and its context menus to perform operations on your data. We'll go one step further. We'll explore and deduplicate our data and perform additional transformations with the help of Copilot. So we won't deal with navigating menus, selecting options, nothing. Back in our Power Query interface, click on the Copilot option, and this will bring up a pane off to the right. And here you can see what Copilot can help with. Get data from a source, add a step to perform a particular transformation, or describe the query you've written so far. Let's start with our very first step. Before I remove duplicates in my dataset, I'd like to know how many records this data contains. So I say, give me a count of the current number of rows. And notice that it adds a custom step giving me a count. The original dataset contains almost 54,000 records. Now, this is just a temporary step for me to explore and understand this data. I'll hit undo, and then it restores my original query. Now, instead of navigating menus to figure out how I can remove duplicate rows, I'll just say remove duplicate rows, and Copilot will automatically add a step for this. It's correctly found the right step, and you can see the corresponding M query for this table.distinct is what checks for duplicate records in our dataset. This is there in the function input at the center of the pane. Let's verify that we now have fewer records because duplicates have been removed. Now could you count the new number of rows? And here it says it has 53,794 records, about 200 records for duplicates. It's pretty clear that Copilot with data flows works very well. It's so much easier for you to clean and transform your data. We'll take this further in the videos that follow. Like with all generative AI models, Copilot gives me different responses, often for the same query. I've found that it gets the numbers right, but it often mixes up the visualizations and doesn't always get the visualization right on the first try. Now, in this particular example, you'll find that it picks the perfect visualization for what I've requested. But that was only this time when I was recording the demo. When I was actually trying out the demo offline, it didn't suggest the right visualization at all, no matter how I prompted it. Here is my prompt. I'd like to view the current profit and see how we are doing against our target profit of $500,000. The target profit is, of course, something that's not present in our data. However, Copilot should be able to compute the current profit using the data. Once again, I'd like you to note how I have phrased my query. I'd like to view. If you preface your prompts with give me a visual, show me, or I'd like to view, it'll actually generate your information within the Copilot pane. It won't edit the report directly. This is an important point to keep in mind. Here is our query, current profit against target, and you can see it gives me a card display. Now, if you think about it, a card visual is not the right one to display our progress towards a certain target. A card visual is great to show the current state of affairs. Copilot has responded to my query just fine though. Based on the available data, the current profit is about $286,000, which is 57% of the $500,000 target. So it hasn't forgotten the target, but the first visual that it generates is not the right one. This is what follow-up prompts are for. Now, if you're not happy with the visual that it has generated, you can either suggest a visual or ask for it to generate a different visual. Thanks to the ongoing conversation, Copilot has the context for this follow-up prompt. Can you use a visual to display this information? It knows that this information refers to current profit versus target. Observe how I have phrased this particular prompt. Can you use a visual to display this information? And this subtle difference will actually change what Copilot does. I've asked it to use a visual and it generates a gauge chart, which is exactly the kind of chart that I was looking for, and it has added it directly to my report page. Now, I won't say that Copilot is super precise about this. Sometimes it adds the visual to the chart, sometimes it will just display it within the chat pane, and then you can of course add it to the report as you please. But I've noticed just from experience that these subtle changes in the way you phrase these queries, these nuances matter. I asked it to use a visual, so it actually used the visual in the report. Let's say this is not something I want in my report. I can simply delete this, right? I can just get rid of it and then move on with my natural language queries of Copilot. I've cleared the conversation. Let me take a look at the data that I have to figure out what else I need. The data pane shows me that I have a sales number and an industry column, and I'm curious about sales by industry. Again, notice the show me prefix for this prompt. This means whatever analysis it does, that will be within the chat pane. It won't actually update my report. And here you can see a nice bar chart showing me how the sales vary by industry. This gives me total sales by industry. Let's take a look at how Copilot actually arrived at this particular bit of analysis. The chart looks correct, but I'd like to verify that Copilot did the right thing. So I asked, show me our total sales by industry. The data used was industry and sum of sales, and there were no additional filters applied. This looks correct. I'll now click on Explore Answer to dig into this data further and maybe use a different visual to represent this. What we have here is the horizontal bar chart for sales by industry. In addition to sales, let's say you want to represent profit in this bar chart as well. You can click on Add Data in the X-axis section and just select the profit field in your data. This way, we are actually exploring the data without interfering with the underlying report. Now we have both sales and profit in the same horizontal bar chart. Now, with this horizontal bar chart, I'm forced to scroll to see all of the different industries. I think this would be better displayed if I used a column chart, a vertical bar chart. I'm going to click on the visual option here and switch this over to be a column chart. And I think this looks a lot better. The exploration pane allows me to dig into raw numbers rather than exploring visualizations. This is in the matrix section. The matrix section gives you the raw numbers for both sales and profit, exactly what we've represented in the chart. If you'd like to add filters to this data, maybe you want to filter by segment, or maybe you'd like to filter by region, you can use the add filter option that you see on top. And of course, you can also rearrange your data in other ways. An exploration is a separate Power BI asset that you can save. You can simply save the exploration to your workspace, just like you would save a report or an ML model or anything. So when you save the exploration, make sure you give it a meaningful name, save it to a workspace, and this exploration will be available for analysis later. Let's say you've kind of done your analysis part way and you want to come back to this, you can save this exploration as a separate asset. And this exploration will be available as a workspace asset. Let's head to the workspace. Let's save this report so we don't lose all the changes we've made. And there you can see our exploration has been saved. You can see that the type of the asset is exploration. It's a relatively new asset in Fabric. It's marked as being currently in preview. And of course, you can click through to the exploration and pick up from where you left off. If you have new ideas about how you want to view the data, bring up the exploration and work within that. And once you're satisfied with this exploration, you can always add this to a report. Now I'm going to use data flows to clean and transform this data with the end goal of using this dataset for machine learning. Now, I won't actually use this data for machine learning. We'll use a different data set when we come to the machine learning bits of this journey. But the transformations that I perform will be related to ML. The next thing I'm going to do is label encode the categorical columns. Label encoding is one way of converting categorical data to numeric form so that it can be fed into machine learning models. Remember, ML models only understand numbers. Label encoding is typically used for ordinal data where there is an inherent ordering to the categories, from the best to the worst or from the lowest to the highest. Now, let's assume that we are using this data for regression analysis where we try to predict the price using the other features of a diamond. This dataset has a color column that is a letter. Now, colors have an ordering. Some colors are better than others as far as price is concerned. Here's my prompt to Copilot to label encode this column. I'm planning to use this dataset for regression analysis. Please label encode the color column from J, that is the worst, to D, that is the best. Add this as a new column next to the original color column. Now, the reason I ask it to add a new column is that I want to compare the label encoded values with the original ones to make sure that things have been set up correctly. Copilot very helpfully does this for me, and it does so using a series of steps. Let's take a look at the first of these steps, color order. This is where it maps the correct order of colors. D is the worst, J is the best, that's what we had said, and you can see Copilot has set this up. Adding the label, that's the actual encoding of the color column, and then reorder is when the color label column, that is the encoded column, is placed next to the original. You can quickly verify that the colors are encoded correctly. E has a value of 1, so if D is 0, E is 1, and J has a value of 6. This looks right to me, so I can go ahead and ask Copilot to get rid of the original color column. We'll just stick with the encoded one. And once it gets rid of the original color column, we'll just rename the encoded column to color. And that's exactly what it does. I'm left with the color column, but now this color column has numeric values. Let's specify what we'd like Copilot to do next. Label encode the clarity column. If you look at the data, there is a categorical column called clarity with values such as SI2, SI1, VS1, VS2. This is an ordinal category. This means there is an inherent order to the clarity of the diamond. And this is what I'd like to label encode. Let's take a look at the prompt I have. Please label encode the clarity column in this order. There's no way for Copilot to tell what the actual order is. There is no descriptive label. If you had something like good, better, best, that's something Copilot can understand. But with these I1, SI2, VS2, Copilot has no idea. This is why I specify the actual order here. I1 worst, IF best. And then I give the ordering of everything else in between as well. Copilot needs this information. My instructions here are very explicit because for a complex transformation of this kind, I've seen that Copilot tends to make mistakes. It'll just get the ordering wrong, then your encoding will be wrong. This should be in ascending order from the worst to the best. So I1 should be 0, then followed by SI2, that should be 1, SI1 should be 2, and IF is the very best. And I ask Copilot to place the new column next to clarity so that I can verify the encoding. Let's go ahead and send this to Copilot and let's see if it does the right thing. What I've noticed is that for these more complex operations, it's always best that you verify. You can see that there are a number of steps that it has to add to our applied steps in order to perform this transformation. The first is the clarity order. Make sure that the ordering of clarity is correct. I1 is the worst, that should have the lowest numeric value. IF is the best, and that should have the highest numeric value. The remaining steps are to actually perform the encoding and place the column next to the clarity column so that we can verify this. And let's quickly take a look. You can see at the bottom row 16, I1 has been encoded as 0, that is correct. SI2 has been encoded as 1, that's correct too. SI1 has been encoded as 2, that's correct as well. So things look good. We're satisfied with the encoded column. Let's get rid of the original clarity. I right click and remove columns. You can use Copilot for this as well. I just thought I'd do it manually to show you how you normally work with Power Query. And I'm now going to rename clarity encoded to call it just clarity. Now there is one more column that I need to label encode, and that is cut. You can see cut has different values such as ideal, premium, good, very good, etc. Let's try label encoding this. And here I'm going to ask Copilot to infer the right order. Because these have descriptive names, I find that Copilot often gets this kind of label encoding correct. It's always safer to be explicit about your order. I just thought I'd use this to see whether Copilot actually interprets the order correctly. My prompt is much more high level. Please label encode the cut column with the worst cut as 0 and then with steadily increasing values. Again, please add this as a new column next to the original column. So I don't tell it what the worst cut is and what the best cut is. Let's have it run through and then we'll examine the result to see whether its interpretation is correct. Now, when I look at the cut encoded values, I see values like 9 and 7, and this immediately triggers a kind of warning that things have not gone correctly. I don't have 9 categories in the cut column. There are maybe 4 or 5 or 6 at the most. Where did these high values come from? I then glance over the cut column and I see there are some strange categories here. Unusual underscore good, unusual underscore premium. These are not categories that should exist. Clearly, the data is distorted in some way where certain categories have the unusual underscore prefix. So I need to clean the values in this column before I actually use it. This is what caused my encoding to be wrong. There are additional categories here that I did not expect. I can either click undo to undo this operation, or you can see that a single step has been added to perform this encoding. I can simply delete that one step and the operation will be undone. And now let's try again. We first need to clean our data before we can encode it. Here is my prompt. Please remove the prefix unusual underscore from the values in the cut column. There are some errors in the data. Make sure you specify the prefix exactly with a capital U so that it uses an exact match to actually find and remove this prefix. Before I run this, observe that records 11 and 13 have this unusual prefix in the cut column. I'm now going to ask Copilot to fix this, and records 11 and 13 now no longer have the unusual prefix. Well, this looks good, so we can go back to our label encoding. The column named cut has various diamond cuts. Please label encode the cut column with the worst cut as 0 and with steadily increasing values. Please add this as a new column next to the original cut column. And this time around, the encoding is perfect. Let's take a look at the M code for this transformation. Notice the cut order. It starts with fair, then good, very good, premium, and then ideal. This is the right order. This means our encoding is correct. At this point, we can get rid of the original cut column and rename the encoded column to cut. Let's do this manually. Right click and select remove columns. And let's rename cut encoded. Right click, select the rename option and rename the encoded column to cut. We now have our pre-processed data. There is just one additional pre-processing that I need to do. Our data contains some null and missing values. I'll just get rid of those. Back to our data flow, and you can actually spot some nulls in our data. Record 9 has a null in the price field and record 15 has a null in the table field. I'm going to get rid of all rows that have null values. And this is what I tell Copilot. Please remove rows with nulls in any column. And you can see those records have disappeared. We'll now move on to the next step in the process where we'll write our data to a destination. We'll write to the Lakehouse and create a semantic model. We've applied the transformation steps, but the data flow has not run through. For that, we need to specify a data destination. Select the Lakehouse as an option here, and we'll pick the Lakehouse that we created earlier in this demo. Connect to a Lakehouse. Here you can see that I'm connected to the Lakehouse as contact@lunicorn.com. That's my login. And here you can pick the Lakehouse in your workspace. You can see that I have Looney Lakehouse here. Make sure you select that and make sure you specify the name of the table where you want the cleaned and transformed data to be stored. Diamonds clean is what I've called it. Click on next. This will show you the columns in your data and the interpreted data types and how they'll map to the destination, the Lakehouse. We have the source type and the destination type. Everything looks good. Let's go ahead and save the settings for these column mappings. And at this point, we have the destination configured. All we have to do is run the data flow to perform the transformations and store the final result. I'll just rename the query itself. Instead of calling it diamonds needs cleaning, I'll call it diamonds clean. Make sure you save the data flow. I'm just going to save and close because I'll actually run the data flow from the workspace itself. Here is our Looney Diamonds data flow Gen 2. Click on the three dots and select refresh now. This will cause the data flow to be executed. So you can see the run has started, which will apply all of the transformations that we had specified using natural language queries, and it'll store the result in the final destination. Let's take a look at the recent runs. Seems like one run failed previously, but the current run seems to be in progress. Let's hit refresh and wait for this to run through. Seems like write to data destination is going on, and soon this run should succeed. At this point, we've successfully written out our data to the Lakehouse. Let's go and verify whether this data is indeed present in the Lakehouse. Let's click through to the Lakehouse, and in the tables, you'll find the diamonds clean table. And you can see all of the encoded columns. This has no missing values, no duplicates. It's now ready for machine learning. In this demo, we'll go back to using Microsoft Copilot, our old friend. Copilot has already eased up so many of the tasks that we perform on Fabric as well as in Power BI. Copilot allowed us to transform data using data flows. Copilot allowed us to generate smart narratives based on our data. And in this demo, we'll use Copilot to build visuals for our Power BI report, answer questions on our data, build new report pages, and build the entire dashboard. Here are the steps that we'll follow in our demo. First, we'll prepare the data and set up the report. Next, we start asking questions of Copilot and create visuals based on those questions. And then, based on whether we like the visual or not, we can include it as a part of our report. Once we have a report page with a number of visuals set up, we'll get Copilot to answer questions based on our data, and you'll see how it cites the individual visuals in the report in response to your questions. We'll also see how we can build entirely new report pages using Copilot queries. Based on how you phrase your prompt, you'll find that an entirely new report is generated. And finally, at the very end, we'll set up an entire dashboard using natural language queries with Copilot. What I found with this demo was that it upends many of the old ways of working with Power BI. Power BI was all about finding the right dimensions on the x-axis, the right measures on the y-axis, and kind of configuring your visuals manually. You no longer have to do that. Let's get started. The very first step is to get the data and prepare our report. Only then can we use Copilot. I'm going to do this demo using Power BI on Fabric. I'm in my workspace in Fabric, and at the bottom left, you can see I'm in the Power BI experience. Click on Create and select Get Data. We'll select a dataset that's available on my local machine. This is a dataset that you've used before, the AWS SaaS sales dataset. We've never used this dataset to build a dashboard yet in this journey, and that's exactly what we're going to do. But the way we're going to do it, that's different. Click on Next. This will allow you to preview the data and, of course, transform the data as needed. Click on Next, and this will bring up the Power Query editor where we can transform the data if we need to. I'm going to get rid of a few extra columns. This row ID column, that's not really meaningful for any kind of analysis, so I get rid of it. There are other columns that fall in the same category, such as the date key column. So I'm going to go ahead and remove this column as well. And there's one more column, the license column, and I'll get rid of this one as well. Let's quickly verify the data types of the different columns. You can see order date is of type date. We are all set here. Go ahead and create a report. Now, a report, of course, needs a semantic model to represent our data. Specify the name of the semantic model. I'll just call it AWS SaaS Sales and click Create. I'm going to hit Control S or Command S, and you can save the report as well. Dashboard with Copilot is what I've called it. Let's switch over to the edit mode and let's get working with Copilot. Let's move on to the next part of our demo where we create visuals based on questions. We've already set up everything that we need to work with Copilot in an earlier demo. So we have the Fabric capacity provision, we have the settings on our portal configured, and our workspace currently uses the paid Fabric capacity. I just wanted to remind you of those prereq steps that you need to perform before you can use Copilot. Click on the Copilot option here, and this will bring up a pane off to the right, and this is what we'll use. Within a report, Copilot can assist you in several different ways. If you're curious about all the different ways in which Copilot can help, click on this little icon here at the bottom left called Prompt Guide. This will allow you to get a quick overview of the kinds of queries you can pose to Copilot. You can ask what's in your data. You can ask it to suggest content for a new report. You can ask it to create a report that shows a particular bit of information or a particular visual. This will set up an entire report page. You can ask for an executive summary of all of the visuals in your report. Or once you have some visuals set up in your report, you can get Copilot to answer a question about the data. My first query here is rather general. What reports can you suggest for my report on SaaS sales for AWS? So this is a very open-ended question. I'm looking for ideas from Copilot. Let's go ahead and send this and let's see what Copilot has to say. And in a few moments, you'll get the response from Copilot, and it has suggested a number of different reports or visuals that you can create. It has suggested first a sales overview, giving you overall sales performance. Then a breakdown by sales by region, customer segmentation, and product performance. It asks you to explore SaaS sales distribution across different regions. Customer segmentation is examine sales by customer segment and industry, and review sales and profit by product. This gives me some ideas about the different kinds of analysis that I want to set up. Now you're familiar with generative AI models. Any conversation you have with Copilot is a session, and it remembers whatever you've discussed previously in the session. If you'd like to start afresh because you've completed one conversation and would like to move on to the next, you can click on that little broom icon that you see right at the top. This will clear the current session, all of the conversation so far, and you can move on with your next question. Let's have the next question be very simple. Give me the total sales across all orders. When you phrase your query in this manner, such as give me or show me, it'll actually generate the analysis and show it to you within the Copilot pane. Notice that the response is not just a number, but actually a visual that you can directly include in your report. This is the KPI chart or a card that Power BI supports. You also get a nice natural language summary. Based on all the available data, the total sales is about 2.29 million. Just below the card for sum of sales, there are two options, add to page and explore answer. We'll look at how those work just a little bit later. Let's now look at this option here at the bottom, how Copilot arrived at this. I find this incredibly useful. If you're not sure that the number is correct, or you want to know the workings behind Copilot's arriving at this number, this is where you'll dig deeper. So Copilot tells me you asked total sales across all orders, data used was sum of sales, and no filters were applied. This query happened to be simple, so maybe we don't need additional information, but this is actually very useful, especially as things get more complex. Let's say you want to explore further starting from the current point. You have the total sales across all orders, but you want to dive deeper into the data. You can click on Explore Answer, and this will bring up what's known as an exploration that's currently in preview. An exploration basically gives you a number of widgets that you can use to dive deeper into your data. Copilot generated a visual, a KPI card for total sales, but let's say you want to view this data using a matrix. Simply select the matrix option. This will give you a tabular representation of the same data. Or if you'd like to view the same data using a different visual, you can select the visual from this drop down available here. You can switch the visual around and see how best to represent your data. Explorations allow you to view the same data in different formats and also allow you to slice and dice your data in different ways. In the rearrange data section at the bottom right, you'll find different ways to view the same data, maybe slice by different dimensions, view different metrics, and so on. Let's close this. Now, let's say this is a visual that you'd like to include in your report. You can simply click on Add to Page, and this will be added to the current page of your report. And you can, of course, position it where you want it to be. Now, I realize that the sales numbers are showing up to 2 decimal places. Let's see if we can fix this. Let's ask Copilot how we can fix this. Is it possible to round off the value shown to the nearest integer? This is my prompt, and Copilot in Power BI at this point in time cannot do this directly. And it gives me a very clear response. You can't directly change the aggregation or formatting of a value using this interface. It clearly says that to round the value shown on the card to the nearest integer, we need to update the measure in the semantic model or using the visual formatting options. That's a capability that Copilot doesn't yet have. Now, since these actions have to be done outside of this chat, it tells me, do you want guidance on how to do this? Or would you like to proceed with another request? I simply say yes to say I'd like guidance on how to do this, and it'll give me exact steps for how I can actually round off this display. Now, the steps it has given me is about editing the DAX formula to include the round function. And this is a very valid way to change the measure. Copilot has given me the DAX expression in this particular response, but previously when I tried out the same query, it gave me the steps I need to follow using the visualizations format pane. And those steps were not perfect. And this is where you have to be a little wary of generative AI. Its answers tend to be slightly imprecise. It's up to you to ensure that whatever you're adding to your report is completely accurate. Copilot can't help with perfect accuracy. Now I'm going to open up the visualization pane with my card selected and go to Format Visual, and in the General section, there is a Data Format section. This is where I can specify the formatting options for this data's display. So let's go ahead and format this to be displayed in the form of a currency because this is a dollar amount after all. I would have turned on the thousands separator here, but it's already on, and decimal places is set to auto. I'll change this and set decimal places to 0 because I only want an integer amount. With this change, my card display is how I want it to be. So far, we've got Copilot to do two separate things. First is show us visuals that we then examine and add to our report if we so choose. And the second one is answer questions about our data. We'll now see another capability that Copilot has. We'll see how Copilot can build new report pages for us with the right analytical visuals. Now, if you change the way you phrase your prompt, you can get Copilot to create new visuals or create entirely new report pages. Now, here I've said create a visual showing the average discount and total quantity sold per country. Queries which start with create a visual won't just display the information within the Copilot pane, it'll actually set up a visualization and add it to the current page of your report. You can see a clustered bar chart here showing you sum of quantity and average of discount per country. Now, let's say you did not want this visualization to be in this particular report page. You then need to phrase your prompt a little differently. Here, I already have the visualization that I'm interested in. I'm just going to follow up and ask Copilot to add this to a new report page. Now, sometimes Copilot may do what you ask it to do, but it may go above and beyond as well. Here, it has created an entirely new page in my report. That's exactly what I wanted. It has named the page well as well, country sales and discount analysis. It's added the horizontal bar chart with the average of discount and sum of quantity by country, but it's added other visualizations as well. It has created an entire dashboard. If this is not what you wanted, you can simply remove the elements that you no longer need. But you can see that this dashboard is pretty comprehensive. We have the sum of quantity, average of discount across the entire data set. Then we have the two bar charts, and then we also have a map. The map shows you the different countries where products were delivered and the sum of sales in each country. And there are filters and slicers added to the report page as well. Now that you have so much information, you can pick and choose what makes sense to you. Remember, Copilot is not super precise. It'll give you roughly what you ask for, but it's liable to make mistakes. And that's something you have to keep in mind and you have to work with it. Let's get some inspiration from Copilot. I click on Copilot once again, so the pane comes up, and I ask Copilot, can you suggest what content I can include in a new report page? Maybe there are types of analyses that I haven't done yet. Let's take a look at what Copilot has to say. Copilot helpfully gives me an outline of the entire report. It first suggests sales performance overview. That could be the first page of our report. It then suggests profitability analysis. Copilot then suggests a regional sales breakdown, and you can see what it's asking us to compare, and then customer segmentation. You can, of course, ask queries based on any of these, but I have ideas about what I want this report to include. So I have my own query. You can be very clear with Copilot that you'd like a new page in your report with whatever analysis you have in mind. Can you add a new report page with KPI charts and analysis of how sales, profit, and quantity vary by segment? So I'm very clear about what kind of analyses should be included in this new report page. Let's take a look at what Copilot does. Copilot builds an entire report page for me. You can see that it has named the report correctly as well: sales, profit, and quantity by segment. Those are the analyses I asked Copilot to perform. Copilot has added a title to my report page as well: sales, profit, and quantity by segment. That's the title. I have two KPI charts giving me total sales and total profit. Those are at the very top of the screen. So total sales 2.3 million, total profit 286.4 thousand. There are three bar charts for total sales by segment, sum of quantity by segment, and sum of profit by segment. In addition, since we had specified that we want analysis by segment, you can see at the very top right of the screen, there is a slicer. This slicer will allow you to filter by segment and zoom into analysis for individual segments. Copilot can thus generate very comprehensive visuals for you. Now let's try this once again. I'm going to add one more page to my report here. And of course, I'll do this via a prompt. Can you create a report analyzing profit and sales by product and subregion? So I'd like to view my data using product and subregion as dimensions. And here is the entire new report page created by Copilot. Name: profit and sales analysis by product and subregion. That's exactly what I wanted. The two bar charts on top give me sales by product and profit by product, and the two bar charts at the bottom give me sales by subregion and profit by subregion. And then, of course, I have the KPI charts showing total sales at the very top of this report page. One thing I've noticed with Copilot, and I'm hoping this is something that will be fixed later on, is that it always generates the most commonplace charts. So you can see we have just bar charts here. So it defaults to bar charts and line charts, and it doesn't use the other interesting visualizations that Power BI supports. Even though this particular report page has useful data, I find it kind of bland because all the charts are the same. Well, you can get Copilot to fix this. Make sure you're specific about what you want it to do. Could you update this report to use pie charts for the region analysis? So the two bar charts at the bottom, I want them replaced by pie charts because they analyze by region, and you can see Copilot successfully makes this change. Once you get the basic visualizations in a report page set up, you can always interact with Copilot to improve upon the visualizations and display results in a more engaging fashion. In the next part of the demo, I'm going to get Copilot to build an entire report page, that is all of the visuals in a report step by step, so that we have a complete dashboard. Now, in this dashboard, I'd like to use the map visualization as well. I'd like to make sure that our semantic model is configured correctly for all of the visualizations that I plan to use in my dashboard. I click on Open Data Model to view the semantic model associated with the data that underpins this report. The semantic model holds all of the tables and relationships in our data. Now we have just a single table and no relationship, but I'd like to specify additional configuration for the columns in this table, and that's why I switch over to editing mode. In our AWS data, I have a column called country. This is clearly a geographic region, and I want to set its property as such. With the country field selected, under properties, go to the advanced section. The advanced section will allow us to configure the category of data that this field holds. You can see it's currently uncategorized, but I'm going to switch this over to be country region. This data categorization will give the map visual a hint that this is a geographical category. We have another geographic field in our data and that is city. Select the city. Again, under properties, go to advanced, and instead of uncategorized, change the data type to be city. This will allow our mapping visualizations to correctly interpret the data. We've now come to the last part of this demo where we use Copilot to build up a dashboard step by step. Rather than asking Copilot to perform a whole bunch of analysis and place it on a new report page, I'd like to customize the report page with visuals of my choice. Let's get started. The dashboard that we'll build will be on a new page of our report. So click on the plus icon to create a new page and let's give it a name. I'll just call it dashboard. You can of course name it something more meaningful. Let's clear out our existing session so that we start with a brand new session focused entirely on creating this dashboard. Now, at the very top of the dashboard, I'd like KPI cards showing me some important overall information: total sales, total profit, and the overall average discount. Because I use the term create, Copilot knows that I don't just want the visuals in the Copilot pane, I want Copilot to actually build the visual. And the visual will automatically be added to the current page of your report. And you'll see that it creates 3 KPI charts and positions them nicely within your report and gives you an updated title as well. So we have total sales, total profit, and the average discount. And with just these visuals, it has changed the title of this particular report to be Key KPIs Overview. Don't worry, we'll fix the title to be the right thing at the very end. The first step of our dashboard is done. Here is my second prompt asking for the next set of visuals to be set up. Next, add a bar chart that shows sales broken down by industry. So I'm very specific about what I want, and you'll see that it very nicely adds a bar chart with this information. By default, Copilot always sets up the horizontal bar chart. You can see the total sales by industry here, but you have to scroll down to view all of the bits of information you're interested in. I'd rather this be a column chart. So I just say, please make it a clustered column chart. Make sure you have the visual selected so that it knows what visual it has to update. Copilot will make the changes correctly. And here is my clustered column chart. I'm definitely happy with this one. I'm also happy with where it's positioned in my pane. So I'll leave it there and let's move on to the next step, the next visual I want in my dashboard. This time I want a table. Add a table that shows sales, profit, and quantity sold for each product. Observe that in each of my prompts, I'm very clear about the visualization Copilot should use. We've seen in previous videos how you can actually explore the right kind of visual with Copilot's help. But here I'm very clear about what I want. I just want Copilot to build it for me. And so when I send this next prompt to Copilot, it'll set up a nice table with all of the information that I asked for along with a total, and it's placed it at the appropriate place in my dashboard. I'm happy with what I have here, and here's the next visual I want to be part of the dashboard. Create a donut chart to show the proportion of sales by customer segment. Again, I'm very clear about the kind of visualization I'm interested in, and I use the action verb create so that this visualization will be created and added to the report right off the bat. Now I'd like to view a different kind of chart. I want a scatter plot to show sales versus profit for each product. I've chosen a scatter plot because both profit and sales are continuous variables, not categorical, and the relationship between them is best represented using a scatter plot. There isn't a clear location where this could be added, so it was placed on top of the other charts. You can simply move it to where it should be within this report page. Let's understand how to interpret this scatter plot. It says sum of sales and sum of profit by product. We have sum of sales on the x-axis, sum of profit on the y-axis, and every point in the scatter plot represents a single product. So you have total sales and total profit for each product represented in the form of a point on this scatter plot. If you hover over the individual points, you'll find that they represent individual products. Now let's say we want to view a map. Create a map to show the countries to which sales are made. So I'd like to highlight on a map those countries to which AWS sells SaaS products. And this automatically creates Well, not a map, clearly a table. But you can see that Copilot has realized its mistake. This goes to show that Copilot clearly checks its own work. After responding to my query, it set up a visual and then checked to see whether this is indeed the map that I had asked for, and found that it was not a map, but instead it was a table. And you can see its response here in the window. It appears that a table visual was added instead of a map. Would you like me to try again to create a map visual that displays the country to which sales are made? It knows my query wasn't answered and is trying to fix things. So I'll just say, yes, please create a map, and then it'll go ahead and try and change the visual to a map, and it does so successfully. The points in this map visualization highlight the countries to which sales are made. Now, if by some chance you're creating this report and you do not see the map visual, instead you get some kind of message in a yellow bar. The message might say something about allowing data sent to Azure Maps to be processed outside your tenant's geographies. This requires you to request your administrator, or you can do it yourself if you are the administrator, to head over to the admin portal and enable the setting that says data sent to Azure Maps can be processed outside your tenant's geographies. Only if that setting is enabled will you be able to view maps within your Power BI report. Our report is now close to complete. Just a few more finishing touches. I'd like to drill down deeper into this data using a slicer. So I just say finally add slicers for segment. Every order is associated with a segment, and I'd like to select individual segments and see how all of these different metrics change. And Copilot duly adds the segment slicer to my chart, and I'll place it somewhere where I can use it. At this point, all of the charts in my dashboard are final. However, if you have finishing touches you'd like to apply, you can do so. One thing you may want to change is the titles of all of these visuals. Now I'll show you an example of how you can change the title of a visual. Here I say change the donut chart title to sales distribution by customer segment. I prefer that to sum of sales by segment. Now, since I have just one donut chart, Copilot is able to identify that chart even though it's not explicitly selected, and you can see that it has appropriately updated the title as well. Thus, you can use natural language queries to update the title of the report page and any other titles that you want to. And that's it. We have the dashboard that we want. Let me quickly verify this in view mode. So I save the dashboard. Let's switch over to view mode. I've hit refresh and that automatically brings me to view mode. And I'm going to use the slicer, and all of the dashboard visuals update accordingly. You can hover over the individual visuals, get all of the information that you expect in Power BI, and we did all of this without creating a single visual ourselves. Now that we've understood explorations, let's go back to using Copilot within our report. I'm going to click on our report dashboard with Copilot, and make sure you save or don't save the exploration based on what you want to do. And here, when I reach the report once again, click on the edit button and open up the Copilot pane. You'll find that all of my previous queries to Copilot have disappeared. So if you save your report and then navigate away and then you come back to your report, you won't have your previous conversation history, at least at this point in time. Just something for you to keep in mind in case you were expecting continuity. Let's ask the original question once again. Can you give me the total sales by industry? This was our last question to Copilot before we went off to view the exploration. Now this gives me the same horizontal bar chart again. Now I should tell you at the time of this recording, Copilot tends to prefer horizontal bar charts rather than vertical clustered column charts. Now if you remember, the vertical clustered column chart represented this data a lot better. Now we don't have to configure that ourselves. We can simply ask Copilot to do this for us. Could you make this a column chart? And Copilot understands exactly what you mean. It's changed the visualization in the Copilot pane to be a clustered column chart, and it also gives me that narrative, the little natural language summary. The natural language summary tells me that finance leads all industries in total sales, followed by energy and manufacturing. And here is the column chart. I think this looks great. This is a bit of analysis I'd like in my report, but I want a little change to this visual. Here is my follow-on query. Great. Could you now add profit bars to the same chart? Copilot remembers conversation within the session. It has the context that it has given you total sales by industry in the form of a clustered column chart, and it will now add profit bars to the same column chart. This continuity in the conversation is super useful because you may not be satisfied with Copilot's original response. Now I like this new updated chart and I'm ready to add it to my report. And that of course is very simple. Click on add to report and position it wherever you want it to be. I think the first page of my report is progressing extremely well. Let's continue with Copilot and generate more visuals. Here is my next prompt. I would like to view the total profit by region. What chart would you recommend for this? Could you suggest a few different options? Now, this is a different kind of query. I'm not asking for an answer. I'm asking for options so that I can then determine what I should choose. This is a way to use Copilot for inspiration. I found that I often end up using more commonplace visuals, and sometimes you might find that another visual is more impactful. Copilot can give you suggestions based on what you'd like to show. It starts off with a few common suggestions, a bar chart and a column chart, but it has a few interesting suggestions here as well. It says, use a map visualization if your data includes geographic information. We did say region, that could imply we have geographic information, or a pie chart, which gives you a quick view of each region's share of the total profit. I've found that Copilot struggles with more arcane charts. For example, a tree map can be used to display hierarchical data using nested rectangles, and it's often used when you want to see a share of a whole for a particular category. Here is my prompt. Could you please set up a tree map of total profit by region? And here it sets it up perfectly fine. But the previous time I ran this query, it refused to generate a tree map. Copilot came back with, I don't know how to set up this visual, and it started suggesting other visuals that it could create. So once again, it's not that it will work perfectly each time, but with the right prompting, you'll get the result that you need. Let's say you change your mind and you want this represented as a pie chart instead. The tree map isn't that clear. Could you please change this to a pie chart? Now our tree map visual is currently selected, so it knows what visual it has to change. Plus it has the context from the conversation, and it updates our tree map to a pie chart. And this is something I'm going to accept within the report page. Our report seems to be coming along quite nicely here. So let's move on and ask a follow-up query. So now I'm moving on to a new visual. So you can clear the session if you want to, or just continue using the current session. Here is my next prompt. Show me the total sales over time. Copilot has access to our data. It knows what columns we have in our data, and it will correctly identify the only time-related column that we have. That is order date. So it gives me sum of sales by order date. This is exactly the visualization that I was looking for. So I'm just going to accept what Copilot has given me and add this to my report. And this fits in nicely here at the bottom. I'll just position this chart correctly, and then I have one last query for one more visual that I'd like to add to this particular page of my report. Here is my question. Show me the top 5 most profitable countries. This is a slightly more complex query because it's not just about profits by country. We'd like Copilot to actually sort based on profit and also find the top 5. So there's an additional filtering that needs to be applied. In addition to giving me the right visualization, it gives me a great narrative. Based on the available data, the top 5 most profitable countries are dominated by United States, United Kingdom, and then the remaining countries. So there is a major concentration of profit in the US and the UK. And here is a chart that bears out the view. Let's go ahead and add this to the page. The horizontal bar chart has 5 bars because we asked for the top 5 most profitable countries. And if you expand the filter column here on the left, you'll see that a top 5 filter has been applied. So it's not just visualization. Your visuals can be sorted and filtered using Copilot as well. We can now move on to step 3 of our demo, where we use Copilot to ask questions about our data. Once you build a dashboard on a single page of your report, you can now ask questions of your data, and Copilot will make use of the information in the dashboard to answer your queries. It can, of course, look at your entire data, but if you have a visual that directly helps answer the query that you post Copilot, you'll find that Copilot references that visual. So not only do you get natural language responses, you get visuals backing up the responses. Let's take a look at this. Which industry is the most profitable? And Copilot tells me that the finance industry is the most profitable. That's good. It also tells me what the total profit is for finance, 50,348.97, followed by energy, that's at roughly $45,000, and manufacturing at $38,000 roughly. Observe there is a 1 right next to the narrative. That's a reference to a visual in our own report that backs up this response from Copilot. We happen to have a visual that shows us sales and profit by industry, and this particular reference highlights that visual. So if you click on that one, the visual where you can verify what Copilot has claimed is highlighted. Let's ask a different question. What date had the highest sales number? So, what one day was the value of sales the highest? And you can see that Copilot correctly identifies March 18th, 2020. And then we have a line chart telling us what daily sales were by order date. The little reference link has correctly identified the line chart as backing up this response from Copilot. It's not like Copilot can only answer questions based on the visuals that we already have in our report. It has access to all of our data and it can compute whatever answers it needs to. Here is an example. Which country sold the most products? This is my question to Copilot. The answer is not present in any of our visuals here. We have a visual showing the country with the highest profits, but not where the quantity of sales in terms of number of products were the highest. Copilot tells me that United States sold the most products leading all countries. In addition, it gives me a visual that I can now add to my report page if I want to. If a particular response from Copilot is not present in your report page, it will simply ask you if you'd like to add it, and it will actually respond in the form of a visual. A report page full of visuals can be hard to parse. Copilot allows you to summarize all of the data that you see. Give me an executive summary of the details in my report. We'll produce a summary that references everything that you've shown here within this page of your report. The first paragraph talks about overall sales and industry specific sales. So the first reference refers to the overall sales of about 2 million. And finance emerges as a leading industry in both sales and profit. The second reference highlights the chart, which actually shows us this. The next paragraph gives us a summary of profits by region. And if you hover over the reference link, you can see that EMEA leads in profitability. The third paragraph talks about country-wise profits, and we have a chart for that as well, and that is the reference link that Copilot has provided. And the very last paragraph talks about sales over time, and our line chart is appropriately referenced. And in this manner, you can use Copilot to answer questions about your data, whether or not those answers are represented in the form of visuals within your report. In this demo, we'll explore Smart Narratives in Power BI. Smart Narratives is an AI-powered visual in Power BI that automatically generates text summaries explaining the key insights and trends found in your reports or specific visuals. These narratives are dynamic, meaning they update automatically as you interact with the data by filtering or cross-highlighting your data. This feature helps quickly convey the main points of your data analysis in natural language, making complex reports easier to understand at a glance. You'll find that smart narratives can be generated in two ways. The first is custom smart narratives. This asks natural language questions of your data and generates a narrative summary. And this is something you can customize significantly by adding your own static tests, formatting specific values, or even creating dynamic values using DAX measures. And then we have Copilot Smart Narratives. This refers to leveraging the separate Copilot pane to generate narrative summaries with the help of generative AI. You can ask Copilot questions like summarize this page, or explain the insights in this chart, and it will use generative AI to provide a dynamic text summary based on the current view of data. Here are the steps that we'll follow in this demo. We'll first load and clean the data that we'll use to visualize, and then we'll generate smart narratives for this data. Before we can add smart narratives to our report, we need to create the right kind of visuals which the narrative will be able to analyze. Those are our base visuals. We'll then generate and customize our smart narratives. We'll add our own static text. We'll also format the values displayed in the narrative. We'll then move on to interactivity and visual narrative features. And finally, we'll use Copilot powered summaries. Copilot powered summaries are not available in the free trial that we set up. We have to set up a paid Fabric capacity for that. I'll explain this further when we get to it. The first step, of course, is to load and clean the data. And that's what I'll turn my attention to first. Observe that we are working on Power BI desktop. So I've moved away from the Power BI service, and just for a little change, I'm working on the desktop. These narrative features are available if you run Power BI on Fabric as well. Click on Get Data and let's load data in the form of a text or CSV file. Now, the dataset that we'll work with is the AWS SaaS sales dataset. This data is freely available on Kaggle, and if you'd like to download this data directly from Kaggle, here is the source URL for this data. It's also available along with the assets of this course. Here is a quick preview of the data. Let's click on Transform Data because there are a few changes we need to make. I'll get rid of some columns that are not relevant for our analysis, and I'll ensure that the order date is of the right date time type. Click on Transform Data and this will open up the familiar Power Query editor. The first thing, of course, is to observe the data types of the individual fields and see whether they are all interpreted correctly. All of the data types seem to be correct except for the dates. You can see sales, quantity, discount, and profit are numeric types. Before we tackle the dates, let's get rid of some columns that we don't need. This row ID column is just a unique identifier for each row. So I right click and hit remove to get rid of this column. Next, I have this date key column. I already have the order date. I don't really need this date key. So I right click and remove this column as well. Next, here is the license column. I don't need the license IDs for these different licenses. So I get rid of this. Let's tackle the order date. It's interpreted as text while I want it to be interpreted as a date. So I right click, specify change type, and I select date as the option, and this results in an error. And when you click through to these errors, and there are multiple errors here, you can see that certain dates were not interpreted correctly using the formatting that we had specified. This is the same problem that I encountered earlier. The dates in the dataset are in the month, day, year format, whereas the default interpretation for Power Query in my setup is that of Indian date, so day, month, year. Under View, I'll bring back the Query Settings pane, which shows me the applied steps, and I'll get rid of this step that we just added for change type. And this time, when I interpret the date, I'll do so using English United States as the locale. So right-click Change Type using locale, and this will bring up a dialog where you can specify the data type and the locale that you'd like to use. Data type is, of course, date, and switch the locale over to English United States. And with this, all of our dates will be interpreted correctly. Click on OK, and there should be no errors in the data that you load in. We're satisfied with how our data looks. Let's go back to the Home tab and hit Close and Apply. And we are now ready to move on to the next step in our demo, creating base visuals for the narrative. This step will allow us to demonstrate the context-aware nature of the smart narrative. We'll place multiple visuals on a page, and then Power BI will synthesize insights across these visuals and generate smart narratives based on what it has parsed. I'm going to set up two types of visuals. First will be a clustered column chart, and the other one will be a line chart. My clustered column chart will display profitability by segment and industry. You can see that I've selected both segment and industry, and those make up my x-axis. On the y-axis, I'm interested in the profits generated by the sale of these AWS SaaS products. So go ahead and select profit. Sum of profit is the aggregation on the y-axis. The second chart is going to be a line chart showing sales by order date. Select order date and select monthly as the granularity. So I don't want this extreme detail, but I want this monthly granularity. And on the y-axis, I show sales. At this granularity, the trends in the data become clearer. It's actually easier for us to visualize. And if we can interpret and visualize the data, the summaries will make more sense to us. In the next video, we'll generate smart narratives for the page as a whole and for a particular visual. But let me tell you something up front. When I generated smart narratives for a particular visual, I got the narrative for the entire page. And that, of course, included the smart narrative for that particular visual. Just something for you to keep in mind. At this point, we are almost there. We've enabled Copilot as a preview feature on Power BI desktop. We went over to our Azure portal and provisioned a paid Fabric capacity. And then we went back to our Fabric workspace and configured our workspace to use the provisioned Fabric capacity. In addition, we looked at the administrator settings to ensure that Copilot and OpenAI service could be used by everyone in our organization. You can see at the top right that we are not signed into our Fabric account from Power BI desktop. This is a connection that needs to be made next. You can just click on sign in by clicking on the top right, or you can follow along with me. I'm going to delete my current smart narrative and click on the smart narrative visual yet again, and this time I'm going to choose Copilot. As soon as you select Copilot, Power BI desktop realizes that it can't run locally. It needs Fabric powering its backend. It'll bring up a dialog asking you to connect to your Power BI service. This is what runs on Fabric. So specify your username and password and connect. I just want to sign in with my Microsoft account on this app alone. So that's what I've chosen here. And once you're signed in, it'll ask you to select the workspace to see if it meets Copilot requirements. Now, if your workspace is on a trial capacity, that won't even be available here. I have multiple workspaces within my account. Most of them use the trial capacity. The only workspace that does not use the trial capacity is the workspace that we are currently working on, Looney Workspace Power BI. This has a paid Fabric capacity. That's the workspace that I select. Go ahead and click on OK. Our Power BI desktop now is connected to Power BI service running on Microsoft Fabric. If all of our other settings for Copilot have been configured correctly, you should see this dialog pop up. And this is where you interact with Copilot using natural language queries to generate any kind of summary you want on your data. At the top, Copilot gives you a starter prompt. Give an executive summary, answer likely questions from leadership, or create a bulleted list of insights. At the bottom, you can see the reference visuals that Copilot will use in order to generate your summary or respond to your queries. It defaults to the current page, but you can have it look at the entire report if you want to. The default prompt is summarize this data, and you can see behind the scenes our narrative has been updated in response to this prompt. I'd like to use our own prompt. I don't want to use the default. Give an executive summary, just a little bit different. Click on update and you can see the narrative behind this dialog has been updated. And here is the detailed executive summary from Copilot. Summaries from Copilot come automatically formatted. They are far better to look at, easier to read, and just more natural. They've been broken down into logical paragraphs: sales performance, profit by segment and industry, trends and shifts, segment profitability. Next to every bit of data that has been extracted from our visuals, you can see a reference link. And if you hover over this, you'll be able to see what visual this information came from. In order to get the steepest monthly increase between July 2023 and December 2023, the reference visual was the line chart in page 1 and the visual itself is highlighted on your page. Copilot generated summaries are also dynamic. You can interact with your visuals. I've selected retail as an industry. I've selected all segments in retail. And here in the smart narrative, observe that the visual has pending changes and you need to hit refresh. This will send the updated visual to Copilot behind the scenes and give you updated insights. You can see that the insights here are quite different. They allow you to drill down into the data. Now, the executive summary summarizes all of your visuals based on the current page or the whole report. you can ask Copilot to dive into something more specific. Here is my updated prompt. Could you explain how the different segments perform across industries? There is a very specific bit of analysis I want Copilot to do. For this, it only need look at the clustered column chart that I have. I'm going to go ahead and hit update, and here is my updated narrative trying to answer my question. You can see at the bottom, SMB is the top performing segment, and then strategic, and then enterprise, with some industry specific variations. I'd like to ask another question. Select the narrative. This will bring up the dialogue. Can you explain the monthly fluctuations in the total sales? And here I'm going to select a particular visual, not the page as a whole. I know that the sum of sales by year, quarter, and month is sufficient to answer this question. So I ask Copilot to look just at that visual. And with that, I hit update to get the updated summary from Copilot. Remember, Power BI has to go behind the scenes, hit Copilot on the server, and then give us our response. And here is our narrative based on the question that we asked. And that's it. Once you have a workspace with a fabric capacity provision, using Copilot is super straightforward. I'm just going to save this as smart narratives on my local machine. We are now ready to move on to the next step, generate and customize smart narratives. You'll see that the narrative is not a locked black box output. It's a specific starting point that we can use to enhance the report and fit our specific business language and highlight the most important insights. This is what will allow us to build a tailored story around our data. Smart narratives can be added as a special visual to your report page. In the visualization pane, you'll find an option for a narrative. Simply drag that and place that in your canvas, and this is where you generate smart narratives. Observe that there are two options here. The Copilot option uses generative AI for our summaries. Custom option is also AI powered, but it doesn't make use of generative AI models. Let's go with the custom option first. In order to use Copilot, we need to set up a paid fabric capacity, and I'll show you how to do that later on in this demo. As soon as you select custom, Power BI will run analysis on the visuals that we've generated in this report and generate natural language summaries based on those visuals. You can see the first summary here. Sum of sales trended up, resulting in a 548.74% increase between January 2020 and December 2023. The first four insights related to sum of sales are all generated based on the line chart that we have in our data. The last three insights are based on the bar chart. The last three insights note talk about industry and segment and how profit varies across these. You can see that the line chart based summaries tend to highlight trends, steep trends, recent trends, long trends, and so on. Our bar chart based summaries tend to perform comparisons across the different values on the x-axis. Now, let me go ahead and get rid of this visual. So I'll just hit delete and remove this visual, and I'll select a particular chart and show you how you can generate a summary by using this summarize option. Now, this would seem like it's a visual level summary, but when you select custom, you'll find that you get a summary across the entire report here as well. Power BI's documentation says that this is how you generate a visual level summary, not at the report level. However, what I got here was a report level summary. Slightly confusing. However, I don't think this is a big deal. You can simply get rid of those summaries that pertain to the line chart visual and retain those summaries that pertain to your clustered column chart visual. In the summary, you can see that there are certain terms that are underlined in blue. These are terms that have been extracted from your data. I'll click through to this term showing the percentage increase in sales, and you'll see the details behind this particular term. You can see this value was automatically generated while summarizing the report. Just below that, you can see the natural language query explaining the term, percentage change for sum of sales between first date of time series and the last date of time series. You can see the actual value there, 548.74, and you can see that it's formatted as a percentage up to 2 decimal places. Now, this is something you can configure. You can change the formatting to be general, currency, decimal number, or scientific notation based on what makes sense for your data. If this is a currency, you can make use of one of many currency symbols that Power BI makes available to you: dollar, euro, and so on. Now, for 548%, showing two decimal places doesn't make sense to me. So I'm just going to reduce the number of decimal places down to 0. Every dynamic value shown in your smart narrative is associated with a name. And that's the name you see here at the bottom, hash V1. This is an auto-generated name. When we set up our own dynamic values, you'll see that I customize the name to be more meaningful. Let's get out of this dynamic value customization dialog, hit save, and the changes have been applied to our narrative. Notice the percentage now says 549% with no decimal places. This is a great way to format your visual for easy reading. Even this very simple smart narrative contains a whole bunch of dynamic values from our data. Let's select this January 2020. You can see this is the first date of the time series. And if you'd like to format the date a different way, you can use this drop down to change the formatting. January 2020 is an intuitive way to view the date, so I'll just go ahead and leave that. Let's look at December 2023, and you'll see that this is the last date of the time series. Again, I'll leave the formatting. Now, this second paragraph in our narrative identifies a trend in our line chart. Let's click through and you'll see that this is the sum of sales with the steepest and most recent trend. Power BI's AI-powered analysis extracted this information from our data. Next, Narrative Insights have identified a downtrend in sales with a drop of about $13,000. So let's click through and view this value. You can see here that this is the first trend reversal that was identified. The value extracted from the data is usually 13,911, and you can see it's of type general. So we haven't specified that it's currency or percentage. So it just takes on the default general type. Clicking through to these dynamic values that are underlined in your narrative is a great way to see how these values have been extracted and see whether they make sense for your business report. Let's move on to the narratives from the second visual, our bar chart. SMB had the highest sum of profit. The SMB dynamic value was identified using the natural language query segment with the maximum sum of profit. Another dimension on the x-axis is industry. Click through to energy, and this has been identified as the industry with the highest value of sum of profit. Now, there are many numbers here in this narrative which are actually currencies, dollar values. Let's say you are planning to pass this report on to higher level management along with these smart narrative summaries. A good practice would be to format these numbers as actual currency values. Click through to the dynamic value and you can change the categories in right here. Use the drop down here to select currency as the kind of value that you're displaying. And you can use the drop down for currency to indicate what currency symbol you'd like to display, whether it's the dollar, euro, pound, yen, anything. You can see a whole host of symbols are available for you to pick from. We'll just go with the plain dollar, English United States. You can see that the comma is highlighted in green. This will add in a thousands separator to our numeric specification. Let's leave that and let's hit save. And you can see that 13,911 now has a dollar symbol to the left of it. If this is a report that's going to be viewed by others, it makes sense to painstakingly go through and change all of the numeric values that are currencies to have the currency symbol. Let me click through to another dynamic numeric value that is currency. And instead of using the drop down, you can simply click on the dollar symbol and it'll set up the formatting for you. Of course, if you'd like to use the symbol of another currency, you have to use the drop down. So I'm going to go ahead and do this for a few numeric values so that the formatting looks good. Before we move on, I'd like to show you something interesting about a smart narrative that tells you a little bit about how this works in Power BI. Notice at the very bottom, there is that little eye icon. While generating smart narratives, Power BI asks a number of questions of your visuals and then extracts the answers of those questions, and those answers become part of our narrative. The presence of that little eye icon indicates that this is a question that Power BI asked, but the response was not really relevant or significant for our narrative. And that's why Power BI has hidden that particular narrative from us. Just a little interesting insight into how smart narratives are generated. At this point, I'm done with the first level of customizations for my report. I have my smart narratives. I've explored the dynamic values used by those smart narratives. I've understood how those dynamic values are computed, and I've also formatted those values to have the right kind of display for my report. In this demo, we'll see how you can leverage Copilot to work with DAX. DAX is an acronym for Data Analysis Expression, and this is a formula language developed by Microsoft, primarily used in Power BI, Analysis Services, and Power Pivot in Excel. It's a collection of functions, operators, and constants that you combine to create calculations on your data. So DAX is kind of like Excel formulas, but designed specifically for data modeling and analysis within these tools. In this demo, we'll work with DAX expressions. These are the specific formulas or code that you'll write using the DAX language. DAX expressions are used to define calculated columns, calculated tables, and most commonly measures, that is, dynamic calculations like sums, averages, or complex business logic that respond to user interactions and reports. In this first demo, we'll work with general DAX expressions. And here is how we'll begin. We'll first make sure that Copilot is enabled and available for DAX queries. Next, we'll run our Copilot query on Power BI desktop, and then we'll use a number of Copilot queries to explain, modify, and optimize DAX. Let's start with our initial setup where we'll enable Copilot to run DAX queries. You'll see that Copilot is a deeply integrated feature within the developer environment. It's not just a report level tool. You'll see that this AI assistant is designed not just for analysts, but also for developers who work directly with code. Now, the same DAX queries can be run on Power BI desktop and in the Power BI service on Microsoft Fabric. Here I am on a new report in Power BI desktop, and I've already loaded in the data that I'm going to use. This is the same global superstore data that we've used in earlier demos. And I'll head over to the file option to verify that Copilot is enabled for DAX queries. Go to Options and Settings here and click through to Options. This will bring up a dialog. And since Copilot is a preview feature, you'll need to head over to Preview Features to enable Copilot for DAX queries. Scroll down below and you can see that this is already enabled for us. You can see the checkbox there, Write DAX queries with Copilot. That's already checked. Now, the reason it's checked is because I had explicitly enabled this when we enabled Copilot for smart narratives. Now, if you did not select this checkbox at that point in time, make sure you select it now because we are going to be using Copilot with DAX. Click on OK, and here in your Power BI desktop, off to the left, you'll find an icon for DAX. Click on this icon and this will take you to an interface where you can run DAX expressions and view the result right here. You can of course write DAX expressions here manually, but that's not the point of this particular demo. This demo shows you how you can use Copilot to do the difficult work for you. Click on this little option off to the left and this will bring up a Copilot input text box. Before we go any further, let's pause here and review how it is that Copilot works in Power BI desktop. Notice on the top right that I'm actually signed in on Power BI desktop. That means my desktop application is connected to my Fabric account. In the Fabric account, I'm connected to the Looney Workspace Power BI, which has a provisioned Fabric capacity. If you remember, I'd mentioned the fact that our Fabric account cannot use the trial workspace to work with Copilot. We need a paid Fabric capacity. And we had provisioned a paid capacity in the Azure portal. A capacity just offers the compute resources to run the assets in our workspace. We had chosen the F2 capacity because that was more than sufficient for our demo. After having provisioned the capacity, we had changed our workspace settings license info to use the Fabric capacity rather than the trial capacity, and we had selected Looney Fabric capacity, the capacity that we had just set up. The capacity was configured for our Looney Workspace Power BI, and here on Power BI desktop, I'm actually connected to that workspace. And this is why I have Copilot available. And this will now help me create and run DAX expressions to understand my data. so I don't have to worry about the actual coding. We've enabled Copilot for DAX queries. We are now ready to move on to the next step in our demo. The second step, we'll run our first Copilot query on Power BI desktop. Let's write our very first query. I ask Copilot to show me a table of total sales and profit by category, and I hit send. This will head over to Copilot and then generate a query for you. Now, you can't really see the query here because it's scrolled up, but you can always review your query and choose to keep the query if it satisfies your requirements. Let me keep the query and we'll take a look at what exactly this query does. A little bit of terminology for those who are new to DAX. A DAX expression refers to the formulas that we use in calculated columns, measures, and to generate tables. The sum function that we've used here is a DAX expression. A DAX query is a statement that starts with evaluate. Evaluate both retrieves and returns table results from a data model. This uses the evaluate statement that returns the result of our function as a table. Summarize columns is a DAX function used to create summary tables over a set of groups, similar to a SQL group by. Here, the expression groups by the global superstore category column and computes the total sales and profit and gives us the result in the ascending order of category. This expression looks absolutely right to me, so I'm going to go ahead and run this DAX query, and here is the result. Total sales and total profit for each of the categories in our data. In this demo, we'll interact with our reports and see that the smart narrative is a living, dynamic element of the report, not a static text box. We'll see that it responds to filters and provides an interactive exploratory analysis. Before we move on to interactivity, I'm going to customize the report further. Let's say there are specific details that I'd like to highlight that have not been automatically generated by the smart narrative. For example, I'd like to highlight to my management the total sales in January 2022. So I've added that text at the very bottom of the report, and now I'm going to generate a dynamic value displaying the sum of sales. Click on the value button here to create a new dynamic value. Now, the way you create a dynamic value is by asking a natural language query of your data. So click on plus value, and this will bring up a text box where you can input your natural language query. Power BI will use this natural language query to extract the right dynamic value from your data. So we're looking for the sum of sales in January 2022, and Power BI says it's about $18,000. This is clearly a currency, so you can click on the dollar sign to format this as such and then name your value. It's important that you name your dynamic values accurately because later on when you review those values, you should understand what they represent. Sales January 2022 is what I've called it. Go ahead and save the changes and observe that this dynamic value has now become part of our smart narrative. You can see that it's underlined in blue just like our other dynamic values. You'll see why those values are dynamic in just a bit when we interact with our report. I'll quickly verify that Power BI has correctly extracted this value, hover over the chart, and you can see that January 2022 sum of sales is 18,542. That's great. We've got the right value here. Now I want to add more detail based on segment and industry. So I say the total profit for the transportation industry is, and let's ask the natural language query question of our data, sum of profit for transportation. Go ahead and select this, and you can see it's about $7,400. I format this as a currency and I name my value, sum of profit, transportation. Go ahead and save this. Power BI is great at giving you accurate results for these dynamic values. However, it always pays to verify this. So here is one, $2,000 or so, $4,000 or so, and then here is the third component, $1,500 or so, giving us a total of about 7,400. That looks right. There is another industry that I'm interested in that I'd like to highlight, the total profit for the tech industry. Let's create a dynamic value for this. Click on plus value and let's ask a natural language query of our data, sum of profit for tech, and Power BI tells me it's about $24,000 and I format this as a currency. Let's name our value, sum of profit tech, and I'm going to go ahead and save this. This is the third dynamic value that we have generated. And I leave it to you to hover over the individual bars and see whether this value is correct. You can see that with smart narratives, You're not restricted to the dynamic values that were automatically gleaned from your data. You can set up your own. Now, if you'd like to review these values, make some changes, you can click on the review button here, and this will give you all of the dynamic values in your narrative, the custom ones that you've set up. If you'd like to view and review the auto-generated values, you can always toggle the slider at the bottom, show auto-generated values. However, we are more interested in the three custom values that we've created. This is where you can review the values, edit them, delete them, or make any other kinds of changes. You can click through and see that there are no filters or slicers affecting this dynamic value at this point in time. We'll get to that part in just a bit. Our smart narrative is now almost complete, and we are now ready to interact with our charts and see how that affects the smart narrative. Now, if this is a report that you send to your management might click around on the report. For example, dive down deeper into enterprise healthcare. Observe that as you make the selection, the smart narrative updates to reflect your selection. Many of the narratives that were relevant earlier now have that eye icon. They've been hidden because they're no longer relevant based on the filtering that you've applied. The dynamic values in your narrative have updated as well. Sum of sales trended up with a 39.4% increase between February 2020 and December 2023. Just like your charts now reflect the selection you've made in your visual, your narrative does too. What about those custom narratives that we've added? They've updated as well. You can see that the sum of sales in January 2022 is still applicable for enterprise sales in the healthcare industry, and that has a value of about $800. The remaining two narratives were about the tech industry and the transportation industry. They have nothing to do with enterprise healthcare, which is what we have selected, and you can see that the dynamic values for those are hidden. You can make additional selections and interact with your charts, and your narratives will update accordingly. Here I've selected two segments from within the healthcare industry. In addition to updates in the existing narratives, some new narratives have been generated as well. For example, healthcare in segment SMB made up 85.93% of the current sum of profit. With every selection you make, the visuals update and the narrative updates as well to correctly reflect your selections values. It's not just selections in the bar chart. You can make selections in the line chart as well. Let's say you'd like to zoom in to sales for a particular time period. Here I've selected the month of June 2021. I select that particular point. My bar chart updates, so does my narrative. You can see all of the insights that relate to trends have disappeared, but the insights for segment and industry are now visible, and we have additional insights. For this particular month, SMB had the highest total sum of profit, followed by strategic, and then followed by enterprise. If you look at the custom narratives that we had added, the first one is hidden, sum of sales in January 2022. Well, that's a different time period than one that we've currently selected, so the value is hidden, but we have the total profit for transportation and tech for that particular month, June 2021. Let's select another point in our line chart, January 2022. And this will display all three of our custom narratives, the three at the bottom. And of course, the other narratives have been updated as well. We don't have any trend analysis, but we do have segment and industry specific analysis. Let's remove all of the filtering that we've applied, and I'll show you one last feature in custom smart narratives before we move on to Copilot summaries. We'll see how we can view visual level narrative using an icon. Currently have the line chart selected, and I'm going to make this change to the line chart. Head over to the visualizations pane and there go to the center format pane and click on the general tab. Here under header icons, you'll find a whole number of icons that you can add to the header of a chart. You can see that many of these icons are automatically enabled. Scroll down to the bottom here and you'll see an icon for the smart narrative. This is disabled by default. Just go ahead and enable this. And now if you hover over your selected chart, that's our line chart, you'll find a little icon. And if you click on that icon, this will bring up the smart narrative for that particular visual. Only the insights that correspond to the visual to which you've added the icon will be displayed here in this pop-up. In this particular part of the demo, we'll see how summaries have evolved in Power BI. These automated summaries have been available for a while in Power BI reports on the desktop and on Fabric. However, now we have a fully interactive conversational AI experience with the help of Autopilot. You'll find that these summaries are more meaningful, more interesting, and just better overall. If you've used any Microsoft product in the last year, you're likely already familiar with Microsoft Copilot. This is Microsoft's AI powered assistant integrated across all Microsoft 365 applications. It's also part of Windows and, of course, Microsoft Fabric. In order to use Copilot powered summaries in your Power BI desktop or even on the service, you need to have a paid Fabric capacity. So far, we've been using the trial capacity, and while that allows us to access a whole host of features, Copilot is not included as a part of the trial. We need a Microsoft Fabric capacity, which is a dedicated pool of computing resources that we purchase on the Azure portal. So, in order for you to be able to do this demo, you need access to the Microsoft Fabric account that we already have, but you also need access to the corresponding Azure portal where you'll provision a capacity. I'm going to continue generating my summaries in Power BI Desktop. We'll connect our desktop report to Microsoft Fabric. I'll show you how you can do that as well. Now, there are a number of settings you need to configure before you can actually use Copilot in Power BI Desktop and in Microsoft Fabric. I'll show you what those settings are. Head over to File in order to set up the settings to allow Power BI Desktop to use Copilot when we connect to a Fabric workspace from the desktop. So under File, go to Options and Settings and then click on Options, and this will bring up a dialog that allows you to configure various settings for Power BI Desktop. Microsoft Copilot is currently a preview feature. So head over to Preview Features and scroll down till you find a setting that says Summary with Copilot Visual. So notice that little checkbox that's currently unchecked. Go ahead and check that checkbox. While I'm here, I'm going to check a few more boxes as well. We'll need it for later demos in this journey. I want to be able to write DAX queries with Copilot. Summary with Copilot Visual is needed for smart narratives. And later on, we'll use Copilot for Q&A. And I check that box as well, improve Q&A with Copilot. Go ahead and click on OK. And you might need to restart Power BI Desktop. And here I am after the restart. This is just the first step to set up Copilot. Observe that I'm currently not signed in on Power BI Desktop. At the top right, you can see the button for sign in. I'm not signed in to my Fabric account. This is what I'm going to fix. I've switched over to my browser window where I'm in my Fabric Looney workspace Power BI. This is the workspace that we've been using so far. Now, this workspace currently uses the trial capacity, and I've just mentioned that we cannot use Copilot with the trial capacity. Open up Workspace Settings and click on License Info. This is what will allow us to see what compute resources this particular workspace uses to run. You can see the license configuration says trial. This makes use of the trial capacity. The compute resources associated with a Fabric trial capacity are very powerful, but they don't support Copilot. This is the first thing that we need to fix. And in order to set up a paid Fabric capacity, you need to have access to an Azure subscription account. The account that I use to sign into Microsoft Fabric has a corresponding Azure subscription as well. And I've switched over to the Azure portal. I've accessed and logged into my Azure account here at portal.azure.com. The Fabric capacity is a paid resource, so you need an Azure subscription with billing enabled. It's also possible that your Fabric administrator has already set up a Fabric capacity and you can just use that within Microsoft Fabric. Otherwise, you'll have to set one up yourself using an Azure subscription. Here on Azure, I'm going to provision a Fabric capacity, and every resource on Azure has to be placed within something known as a resource group. A resource group is just a logical container that holds all related resources. So select the resource group feature, and here I have a number of different resource groups already created. I'll just create a new one for our demos. Click on the Create button, and all you need to do is specify the name of the resource group that I call Looney Power BI Fabric RG. You can place the resource group anywhere, It's generally a good practice to have the resource group in the same region where you'll provision resources. I've chosen East US. Go ahead and review and create this resource. Click on the create button and wait for a few moments for the resource group to be created. And then you can click through. The resource group is currently empty. There are no resources provisioned within this group yet. Our next step here is to provision a paid Fabric capacity that we'll then have our Fabric workspace use. Click on the create button and in the marketplace search for Fabric capacity. This will give us a number of search results. Click through to the first one. That's the one we are looking for. Here, click on the create button. We'll provision this Fabric capacity within the resource group that we had just set up earlier, the Looney Power BI Fabric RG. And then I specify the name of the capacity. I call it Looney Fabric capacity. You can choose where you want this capacity to be located. Your capacity to be located where most of your users are. So I've just selected Central India. Every capacity has a capacity size specified in terms of CUs or capacity units. The F64 capacity, the default, has 64 capacity units. I'm going to go ahead and change this because the F64 capacity is very expensive. The capacity units determine the processing power available to the capacity and in turn to our workspace assets. Higher the number of capacity units for our capacity, the more processing power is available to run concurrent jobs. For the purposes of our demo, we can pick the SKU with the lowest number of capacity units, that's 2. And you can see that this is still going to cost me about $3,000 a month. That's about 24,000 rupees. So capacity units are expensive. Go ahead and select this. And we have the basic configuration for our capacity setup. Go ahead and hit review and create. Azure will perform some basic validation and you can just click on the create button and in a few moments, your capacity will be provisioned and deployed. Once the resource is available, you can just click through to the resource and verify everything looks good. There's nothing more that we need to do here on the Azure portal. I'm now going to switch back to our Fabric workspace. I've used the same account as my Fabric login account for my Azure subscription where I provision the workspace. Let me show you by heading over to the admin portal that the capacity is now available for us to use. Access to the admin portal is only available if you're the Fabric administrator for your organization. So this admin portal link will only be visible to you then. It's totally fine if you're not the administrator and can't actually see this. I just wanted to show you that the capacity is available here. I clicked on capacity settings and here under Fabric capacity, you can see our newly created capacity is listed, the Looney Fabric capacity with the capacity SKU of F2. There are a number of configuration settings associated with a particular capacity. Those are not details that we need to worry about. You as a Copilot user need to ensure that your workspace uses a provision paid Fabric capacity. So this is just for your reference to tell you how a capacity is set up and where you can view the capacity settings on the admin portal. Now, before I actually configure the capacity for this current workspace, I'm going to enable Fabric for my current user account. The operations that I'm about to perform now can only be done by a Fabric administrator. If you're not the Fabric administrator for your organization, you need to request the administrator to perform these configuration settings so that you can use Copilot. I've clicked on the tenant settings link in the admin portal and here I need to enable some settings that I'll find in the section at the bottom, Copilot and Azure OpenAI service. Make sure that these settings are all enabled. Users can use Copilot and other features powered by Azure OpenAI. Another important one is data sent to Azure OpenAI can be processed outside your capacity's geographic region. You have to have these settings enabled in order to use Copilot. You can see that the first setting is enabled for the organization as a whole. As an administrator, I've set this up. And the other one, data sent to Azure OpenAI, can be processed outside the capacities region. This needs to be enabled as well. And data sent to Azure AI can be stored outside your capacities geographic region. Now, it's better to have the other settings enabled as well, but these are the absolute requirements to use Copilot. All of these are enabled. I can now configure the Fabric capacity for my workspace and then use that for Copilot. So head over to Workspace settings, head over to license info. This is where we configure our capacity. And here in the license configuration, select the fabric capacity. And in the drop down, you'll find our newly provisioned capacity available. Go ahead and select that and choose the select license. Our workspace is now making use of this paid fabric capacity, and this will allow us to use Copilot with all of our assets here on Fabric. And if we connect to this workspace via Power BI desktop, we can use Copilot on the desktop version of Power BI as well. I'll set up this last bit of configuration in the next video connecting to this workspace from Power BI desktop, and then we are all profit Copilot. Now, you may not have realized this, but visuals in Power BI dynamically generate DAX queries behind the scenes whenever you interact with the report. So, any visual that you display is powered by a DAX query. If you apply filters or perform cross-highlighting, that generates a DAX query as well. These queries retrieve the necessary aggregated data from the underlying semantic model, and the results returned by these DAX queries are then used by Power BI to render the visual accurately. I'll actually show you this in action. We'll see how we can access the DAX query generated by a visual, a very simple visual, and then we'll use Copilot to refine and optimize that query. For this part of the demo, I'm back on Power BI desktop. Now I've added a very simple clustered column chart to my report here. The information that it will display will be very straightforward. Total sales by category. So select category, place that on the x-axis, and on the y-axis, I'll display the total sales. So here we have it, a simple clustered column chart showing you the sum of sales per category. Now there is a DAX query powering this visualization. We'll make use of the performance analyzer to access the DAX query that lies behind this visualization. Now, the performance analyzer is available in the Optimize menu. So head over to Optimize, and there you'll see an option for Performance Analyzer. This is a tool built into Power BI desktop that helps you understand how your report elements are performing. It records the time it takes for each visual on a report page to update, and it will break down the duration into components like the DAX query time, the visual display time, and other operations. By analyzing these durations, you can identify bottlenecks and optimize slow-running visuals or complex DAX measures to improve your report's loading and interaction speed. The performance analyzer records your actions as you interact with the report. So I'm going to go ahead and start recording. Now, I'm not going to do anything complex with my visual. All I'll do is refresh the visuals displayed here in this report. And once I do that, I'm going to hit stop. Let's take a look at the actions that were performed behind the scenes. The only visual displayed is this one, sum of sales by category. Let's expand this to see the individual components. You can see the DAX query was run, then there was the visual display, and there were other actions. Now, clearly, this is a very simple report, and our data set is fairly small too. There won't be any performance bottlenecks here. But let's say you were working on a complex report and you found that your DAX queries were running slowly. How do you optimize those queries? Let's say you're not an expert on DAX, and this is exactly the situation where Copilot is very, very useful. The first thing I'm going to do is run the query in the DAX query view. That will allow me to access Copilot. When you click on this link, you'll go back to the familiar DAX query view, and here is the DAX query that underlies the visual. Now, this might seem complex, but it's actually a fairly straightforward query. On lines 3 through 6, we have the grouping and summarization operation. We group by category and calculate the total sum of sales. Now, on lines 8 and 9 is some additional code that might seem a little strange. Now, it's quite possible that you have a large number of categories in your data. The Power BI visual will not render all of the categories. Power BI performs a top N operation to display only the top 1001 categories by default. Now, because we have just 3 categories, this doesn't really affect us. And finally, we have the evaluate that runs the query, displays this information to us, and this information is ordered by total sales in the descending order and the ascending order of category in case of tiebreakers. And of course, Power BI renders this in the form of a bar chart. Now, Copilot doesn't know where exactly this DAX query came from. I'm going to select the query and ask Copilot a question. Describe the visualization this query would be used for. I want to see whether Copilot is capable of understanding this query and interpreting what it's used for. Let's take a look at the response here, and it seems like the response is perfect. The query summarizes the total sales by product category and then returns the top 1001 categories. And this query would be used for a bar chart or a column chart that displays total sales for each product category. This explanation is perfect. It's pretty clear that Copilot knows its DAX. Now, let me ask another question. I'll just close this Copilot window. It's okay if I can't recover my work. I don't need the additional context. And I'm going to select this query and bring up Copilot once again. And here is my question. I say, modify this query to also show the total quantity sold. This follow-up prompt asks Copilot to refine the original query. And here you can see it's done that just fine. And on Power BI desktop, you get this nice diff view as well. I found that this diff view exists in Power BI service, but it comes and goes. Sometimes it shows up, sometimes it doesn't. Any code lines that are highlighted in red are code lines that were removed, and the ones in greens are the ones that have been modified or added. I'll show you a better diff view in a later query. Let's go ahead and keep this query. And here you can see the changes that were performed. The main change here is on line 8. Sum quantity, the total sum of the quantity sold. Let's quickly run this query to verify the results. And for each category, we get the total sales and the total quantity. And the next is the most important follow-up prompt. I select the entire query and I ask Copilot to optimize or simplify this query and explain your optimizations. If your performance analyzer has discovered that your queries are running slowly, this is the prompt that you'll use. You can use Copilot to refine your queries to run faster, to make them more performant. And here is that really interesting view that's available currently on Power BI desktop. This is the diff view, or the view that shows differences between the original code and the updated code from Copilot. Everything that you see in red here up top is the original query, and Copilot has rewritten it. That's why it has changed completely. The lines in green are the new lines that have been added, and these are just comments explaining what optimizations Copilot has applied. Remember, I asked for these. Summarize columns is used with measure-like extensions without wrapping sum in calculate. That makes the computation simpler. Use top end directly over summarize columns to limit to the top 1001 columns, so we don't use an extra variable. And we use explicit descending ascending in the order by clause for clarity and performance parity. Let's take a look at the new code. If you look at the lines in green, 8 through 17, this is the new code that Copilot has generated. The code is essentially the same as before. Copilot has gotten rid of the temporary variables. This has reduced the readability of the code, but has likely made it more performant. And in the order by clause on lines 19 and 20, you can see that the explicit order is specified, descending for total sales and ascending for category. This query looks just fine. I'm going to go ahead and keep this query, and I'll run this within my DAX interface, and let's view the result. And there we have the 3 categories in our data, the total sales in each category and the total quantity for each category. The result is the same as before, but our query is optimized. I have one last question of Copilot before we call it a day and move on to DAX measures. I ask Copilot to format this DAX code. A very useful prompt if you have legacy DAX code in your code base that is not well formatted. Copilot can do it for you. You don't need to do it yourself. Now, our code was already reasonably well formatted, but you can see that Copilot has gotten rid of a few spaces to make the formatting even better. Well, this looks good. I'm going to accept this query, click on Keep Query, and one last sanity check. Let's run this query and make sure it gives us the right results. We'll now work with Copilot to create DAX queries on the Power BI service within our Microsoft Fabric account. We'll see that Copilot can be used not just to create new queries, but it also will explain, modify, and optimize existing complex code. I've found that Copilot is addictive. Once you've used Copilot, you'll hardly ever write your own code. You'll simply review the code that Copilot generates for you. Here I am in my Microsoft Fabric account and I'm in my Looney Workspace Power BI. This is the workspace that uses the paid Fabric capacity that we had provisioned earlier. If you look at the license info, let's verify that indeed we are using the Fabric capacity, and yes, we are. This means that we are all set to use Copilot. We'll work with the global superstore data that we had uploaded earlier, and the semantic model for that data is here within the global superstore folder. Let's click through to global superstore, and here in the page for the semantic model at the top right, you'll find an option for write DAX queries. Go ahead and select that option. Off to the right, you can see the data set that we are connected to. This is what Copilot will use to generate DAX expressions. We have the data available, and you can take a quick look at the fields available in this data set. And in addition to the data, you can take a look at the semantic model. This will show you all of the calculated columns, the measures, and the relationships in our data. There's really none. The semantic model doesn't have very interesting information. I'll now get rid of this existing query here and then use Copilot to generate new queries. Click on this Copilot icon. Given our capacity, everything has been provisioned correctly. This should just work. The first query here is very simple. Can you compute the average discount across segments? Now we have a column named segments in our data set. Let me keep the query that it has generated, and we'll take a look at what this query does. The evaluate command, as we discussed before, is used to execute a query before returning the result of a table expression. Here, the summarize columns expression returns a table. Summarize columns is what we use to group and aggregate our data. We group by segment and compute the average discount. And this is done by invoking the average function in DAX. And then the result is ordered based on the ascending order of the segment. I'm going to run this query, and it's pretty clear that this query was perfect. I get the 3 segments in our data along with the average discount for each segment. This clearly works for simple queries. Let's test this further. Let's try a slightly more complex query. List all the subcategories with total sales greater than $50,000. Let's see the expression that this will generate. You can see that this query is much more complex. I'm not going to explain the entire query to you, but we'll look at the basic components. At the very top, this DAX query defines a measure called total sales. A measure is just a dynamic calculation that operates on aggregated data, and it will respond to filters, slicers, etc. if you use this measure in a visual context. Next, on lines 7 through 11, we invoke the function summarize columns to get the summary by subcategory, and we store that in a variable. And then finally, when we scroll down here, you can see the evaluate command. Evaluate performs a filter operation where it looks at the summary by subcategory and checks whether total sales is greater than 50,000. And it will display only those subcategories in the result. Now, this looks right to me, but I don't want to accept the query right away. There's a little tweak that I want Copilot to perform. If you look at the order by clause, you can see that the result is returned in the ascending order of subcategory. This is something I'd like to change. Well, you don't have to make the change yourself. Let's specify a follow-up query to Copilot. So I haven't accepted the previous result. So my follow-up query is in the context of the current conversation. This is important. Could you please sort in the descending order of total sales? So I want the subcategory with the highest value of total sales to be displayed first. I'm going to run this, and though you can't see the whole query, you can see that Copilot has made the change that I suggested. Order by total sales descending, and then a tiebreaker order is subcategory ascending. Let's keep this query and then quickly look to make sure nothing else has changed. We have the total sales measure, then we have the summarized columns, and then we have the filter operation. Everything looks as expected. Let's go ahead and run this query and see if it gives us the results that we were looking for. And there you see it. Subcategories listed in the descending order of total sales, and only those subcategories where the total sales number is greater than 50,000. Let's try another query. I'm going to clear the existing query. I've cleared the interface. I'll click on Copilot again, and here is my prompt. Display total sales by year using the order date column. Instead of just sending this prompt to Copilot, I'm going to click on Write a DAX query. This is a more explicit instruction to Copilot saying that I want a DAX query in response to my prompt. Here is the result of the query. The code on line 6 groups by the year, and then on line 8, we compute the total sales, the sum of sales. And the order by clause displays the result in the ascending order of year. Now, I'm not going to accept this query because I suddenly realize that I want to refine this query further. Could you also include the total profit? So, in addition to total sales, I want the total profit. We'll send this to Copilot and you can see that it has modified the existing query. You can see on line 10, there is a computation for sum of profit. Let's keep this query and take a look to see whether it meets our requirements. Yes, we group by year from order date, that's on line 6. We compute total sales on line 8 and total profit on line 10. I think we can go ahead and run this query and take a look at the result. And the result is exactly what we wanted. Now, if you've ever used generative AI, you know that it often gets things wrong. What I've found though is that generative AI works very well for these basic programmatic use cases, such as generating and evaluating DAX expressions. However, I would still recommend that you check the query and test it out before using it in production. I've cleared my user interface here. Let's try a more complex query. Show the top 10 customers by total sales along with their profit. I want to limit the display to just the most profitable customers. Let's go ahead and run this and let's keep the query and take a look at what it looks like. On lines 5 through 12, there is a summarize operation where the summarization is performed based on customer ID, first name, and last name. For every customer, DAX computes an aggregation of total sales and total profit, that is, sum of sales and sum of profit. Next, we have the evaluate statement where we use the top n function. So we say we want the top 10 customers from the customer aggregation that we had calculated earlier based on total sales in the descending order. And this uses select columns to extract the fields that we'd like to display: customer ID, customer name, total sales, and total profit. And it orders this by total sales in the descending order, and the tiebreaker sort is by customer name in the ascending order. Let's run this query, and here are the top customers based on total sales. Tamara Chand is at the very top with sales of about $22,000. And let's scroll down. At number 10, we have Grant Thornton with sales of about $11,000. Now, you have to admit that this DAX expression is quite complex. Let's say you'd like to understand what exactly this expression does before you actually run this expression. Well, Copilot can help you with this as well. I've selected the entire query in my interface and then I ask Copilot to explain this query. You can type out explain this query as a prompt or simply select the button that says explain this query. And Copilot will give you a very detailed explanation. Let's click on show more and I'll scroll and show you what the explanation is. We won't worry about the actual details. You can see that the explanation is step by step. First, there is an aggregation by customer, and then it shows you the exact code that does the aggregation. This is the summarized columns for the aggregation. And then you can see step 2 is it actually uses top n to select the top 10 customer. And step 3 in the expression is where it projects and formats the final output. I find this an incredibly useful feature. If you feel that Copilot has generated an expression that you don't understand, make sure you ask for an explanation. And if the explanation makes sense to you, then you can use that query in production. Now, I'm going to go ahead and close this Copilot pane. And when you do so in the middle of a conversation, it will ask you whether you really want to exit Copilot. You won't be able to recover your work. That means the current session that you had ongoing will be lost. That's totally fine by us. I'm just going to say yes, and I'll move on to generating our last DAX expression. This is going to be a really complicated one. Click on the Copilot icon once again, and here is my prompt. Display total sales by year and the year-over-year growth percentage. So there is a lot of information that I want, and you'll see the resulting query is quite long. Let's keep the query and take a look at what it does. On lines 5 and 6, it creates a base measure for total sales across the entire data. It then uses DAX's time intelligence feature to compute the total sales for the previous year. This is on lines 9 through 13. It then uses this information to get the year-over-year growth percentage, that is on lines 16 through 19. You can see how well Copilot has commented this code. I especially find this comment on line 15 very useful. It gives you the formula that it has used to compute the year-over-year growth percentage, current minus prior divided by prior. And then finally, we have an evaluate for the summarize columns where we group by year, display the total sales for each year and the year-over-year growth percentage. Let's go ahead and run this and take a look at the results. And for each of the years for which we have data, we have the total sales and the year-on-year growth percentage. And of course, there is no growth percentage for the first year here. Well, hopefully this proves that Copilot is not just for simple DAX expressions, but also for complex ones. In this demo, we'll continue working with Copilot and DAX. We'll see how we can use Copilot to generate DAX measures. Measures in Power BI are dynamic calculations that are defined using the DAX formula language. Measures calculate results on the fly based on the current context. For example, if you have a filter interacting with a report and the report makes use of a measure, the measure will be recomputed based on that filter. Measures are typically used for aggregations like sums, averages, or counts, or complex business logic that needs to respond dynamically to slicers, charts, and table selections. Here are the steps that we'll follow in this demo. We'll first look at the old way of creating measures using quick measures manually. We'll then see how we can create measures in Power BI desktop using Copilot. You'll see how much easier this is. We'll then switch to using Copilot in Microsoft Fabric and see how we can create advanced measures. And finally, we'll use the generated measure in a visual to demonstrate the end-to-end use case. Let's start off with the first step, that is the old way, where we use quick measures to manually create measures. Now, Microsoft has always known that DAX measures are kind of complex and not many people have the expertise to create complex measures. Quick measures is a bit of functionality that has existed for a while, which offers a guided interface to create DAX measures without writing code yourself. Using quick measures, you select the kind of calculation that you want to perform and then drag and drop the fields involved in the calculation. We'll use that first and you'll see Copilot is so much better. Here I am in Power BI desktop and I've already loaded the dataset I've been using. This is the same global superstore dataset that we used in the previous demo. In the Home tab, click on Quick Measure here at the top and this brings up an interface. Right up top, you can see Power BI's recommendation. Copilot can help with your DAX queries. Measures are actually more difficult. They were great when Copilot wasn't available. The first thing you have to do to set up a measure is to select a calculation. Notice the various categories here. You can aggregate per category, perform filtering, and so on. I'd like to set up a calculation that uses a filter, so go ahead and select filtered value. Next, it asks you to add the base value and the filter. Let's open up our data pane and let's find the base value. That's the value on which you want to perform the filtering. And I choose the sum of sales here. So I'd like to filter the sales based on the filter condition that I specify. I'd like to filter by state. As soon as you add state as a filter, Quick Measure will display a drop down showing you all of the states available in your data. So you can go ahead and select the state that you want to filter by. I want to filter by California, so I'll just hunt for that and select that. Click on the Add button to add this filter to our measure. As soon as you hit Add, you'll find that Quick Measure generates a DAX expression representing the measure that you just computed. You can see the DAX expression off to the top left here, sum of sales for California. In order to add this measure to our data model, click on the check mark here and this measure has been updated. Let's view this in the model view. If you take a look at the tables on the right, I'll scroll to the very bottom. Observe the new measure at the bottom, sum of sales for California. We've successfully added a new measure using quick measures Let's quickly verify this measure in a visualization. In our report view, I'll just select and drag the new measure now available in our data model onto our canvas. And this shows me the sum of sales for California. Remember, the measure is a dynamic value. Let's say I were to add a category to the x-axis of this visual, the segment. This will give me the sum of sales for California across each of the segments: consumer, home office, and corporate. Let's use quick measures once again to create yet another measure. Now, you know that Copilot is far easier to use than this, but quick measures is what has existed for so long. It's only recently that Copilot has come into the picture. I select the calculation I want to perform first, year to date total. Go ahead and select that. The base value here is sum of sales that's pre-populated from previously. Instead, I want sum of profit. So I drag that value into the base value field. The year-to-date computation requires our date field, and that's the order date. So drag that into the date field and click Add. This will set up the DAX expression to perform this calculation, and you can see this at the top left of your screen. As you can see, before Copilot, quick measures were a great way to write complex DAX queries when you weren't a DAX expert. Let's not worry about what exactly and how exactly this query computes the year-to-date totals for profit. Let's accept this measure and check whether this has been added in our data model. Notice at the bottom right, you see sum of profit YTD. You can view these newly added measures in the model view as well. I'll just switch over to the model view, and under measures, you can see there are two measures: sum of sales for California that we added earlier, and now sum of profit year to date. Let's use this new measure in a report to verify that things are working well, and then we'll move on to creating measures using Copilot. Select sum of profit and let's drag that onto the canvas. You see a single bar in a clustered column chart here. I'll now add a category to the x-axis. Now, which category should I pick? Let's pick region. Drag region and place it on this clustered column chart. And here we see the sum of profit year to date by region. Now, quick measures really doesn't use AI or Copilot to generate measures. But this was the best way to create measures for a novice DAX user. That is until now. Now we have Copilot. We can now move on to the next step in our demo, where we create measures in Power BI Desktop with the help of Copilot. With this, you'll see the huge change that Copilot has brought about while creating DAX expressions. We move away from navigating menus to simply stating our intent. Generating DAX measures using Copilot is not very different from generating DAX queries, but there is an extra step that's involved here. Now, here I am in the DAX query editor, and I have the model tab enabled so I can see the new measures that are added to our model. Now, asking Copilot to generate a DAX expression for measures is no different than generating queries. However, measures are fundamentally different in one way, in that it's a DAX formula that's saved within your semantic model that defines a dynamic calculation. We've seen that measures are used within Power BI reports. They actually change the semantic model. You'll see that the prompts that I use to generate measures will be a little different, and there is an additional step involved to update the semantic model. With that said, I'll click on the Copilot icon off to the top left of my screen, and here's my first prompt. Create a measure to compute the total profit. Observe that I make it very clear that I want the DAX query that is returned to create a measure. Let's send this to Copilot. It'll generate a DAX query. Let's keep this query and let's take a look at what exactly it does and how creating measures is different. The first thing you ought to note here is the define measure statement on lines 3 and 4. This allows you to declare a measure within a DAX query itself. When this measure is part of the DAX query, it has not been added to your semantic model. The defined measure exists only for the duration and scope of that specific query. You can use this to create ad hoc measures needed only for that particular data retrieval without cluttering the main semantic model. But I'd actually like to add this measure to my semantic model. What do I do then? You can see that little comment, that little hint that you see just above measure, update model, add new measure. Another thing I'd like to point out is notice there is a button right next to run that says update model with changes. Any measure that you define in a DAX query can be added to your semantic model by clicking on this button. Now, before I show that to you, let's quickly run this query to ensure that this does indeed evaluate the total profit. This looks fine. The total profit is displayed here on screen. Now, let's click on this button, which wasn't enabled before. This button is enabled only when you define a measure in your query. And if you click on this button, you will get a confirmation dialog, and then you can confirm that yes, indeed, you want to update your semantic model. This is something you cannot undo. You'll have to explicitly delete the measure from your model if you want to get rid of it. And our model has been updated. Notice under measures, you see 3 measures. We have total profit there as well. Let's use our usual technique to confirm that this measure exists and it works. I'm going to head over to the report view here in Power BI, and I'll create a new page that will make use of this total profit metric. I'll add a tree map to my report that will allow us to visualize the total profit based on category and subcategory. And we'll of course make use of our measure. So select the total profit measure, drag that onto the tree map, and let's select the category that will be added to the data field and the subcategory as well. And here is our tree map that makes use of our measure. We'll now move on to the next step in our demo, where we create advanced measures in Fabric with the help of Copilot, of course. In my Fabric account, I'm in the Looney Workspace Power BI, and this is the semantic model for the global superstore. In order to bring up the DAX query interface, I click on Write DAX Queries off to the top right. And here in my semantic model, I have no measures. Remember, this is not really linked to the Power BI report that I'm working on locally. Let's clear the existing query and I'll ask Copilot to create a new measure. So I'm clear here that I want a DAX measure so that the define measure statement is included in the query that this returns. Create a DAX measure that shows the average discount applied across all orders. Here is the DAX query that defines the measure that we are interested in. If you look at the comments on the first 4 lines, Copilot has helpfully generated these comments to explain what exactly it's doing here in creating this measure. You can see we have the define measure statement that defines the measure average discount across orders on the global superstore. We don't need to worry about how exactly DAX computes the measure. That's something you can study on your own. But notice that the update model with changes button is now enabled, and in order to add this measure to our semantic model, I need to click on that. But for sanity, let's just run this, and here is the average discount across all orders 0.14. The moment a DAX query includes the define measure statement, this button update model with changes is enabled. Let's click on that and let's confirm that indeed we do want to update our semantic model. And you can see over to the right that a new measure has been added to our model. And this is something that we can use in a visualization if we want to. Let's try a new query using Copilot. Create a DAX measure to calculate the profit margin, not the total profit, but the profit margin. Keep the query once it's generated and we can take a look at what exactly the query does. It has the same define measure statement defining the profit margin as a measure. It computes the profit and the sales and divides profit by sales to calculate the profit margin. And then of course there's a sanity check to evaluate this across the entire dataset. Let's run this, and here is the profit margin across all our orders. Let's update our model with the changes, that is, add this measure to the model. And our semantic model now includes the profit margin measure as well. Let's generate one last measure here, once again using Copilot, of course. Clear the existing query and let's send a new prompt to Copilot. I want a measure that counts the number of high-value customers, and this is defined as customers whose total sales exceed $5,000. The query here is definitely more complex than ones that we've seen before. You can see we have a measure called high-value customers that's been defined. If you feel that your measure is not being computed in a very optimal manner, you can always send a follow-up prompt to Copilot. I'm going to select this entire DAX query here, and here is my follow-up prompt. Can you optimize this query and explain your optimizations? Let's send this to Copilot, and you can take a look at the rewritten code. And wait, suddenly the diff view started working in Power BI service as well. I definitely found this view a little more temperamental on Fabric as opposed to Power BI desktop. On line 2, you can see the optimization that Copilot has applied, push aggregation to the storage engine and avoid per row calculate calls. And this is the updated, more optimal DAX query. You can explore the differences further on your own. I'm just going to go ahead and keep this query and execute this query and update my model with this new measure. Click on Run to execute this query first. Here is the number of high-value customers across the entire dataset, and I then click on the button to update my model with changes. Confirm, yes, I do want this updation, and watch the new measure added to your semantic model, high-value customers. Let's validate that these measures work well by using them in visuals. I'll now create a new report and set up two simple visualizations. Let's head back to our main workspace, click on the three dots next to your semantic model and select the Create Report option. Now, the first visual, in fact, both visuals are going to be clustered column charts. So I add the very first one to my pane here. And in this clustered column chart, I'd like to view the number of high-value customers by market. So I select market on the x-axis and high-value customers, my generated measure, will be displayed on the y-axis. You can see at a glance that APAC has a large number of high-valued customers followed by the US and then by EU. Let's try one more. Another clustered column chart where I'd like to view the profit margin based on ship mode. So I add ship mode to the x-axis and I select our newly generated profit margin measure to the y-axis. And this will give us the average profit margin based on ship mode. Now, so far we've used a single explain by variable to understand its impact on the target. But typically when you set up the key influencer visual, you'll use multiple explain by variables. Our target remains the same, total credit amount. The first variable that I add is overdraft limit. Now, when you use a continuous value in your explain by variable, make sure you right click and choose don't summarize if you want the key influencer visual to use its raw values. Let me add a few more variables to explain by. Employment status, that's the second variable that I add in. And you can see that as I add in variables, more influencers show up. I've added the sum of years with bank and I right click and choose don't summarize because that's a continuous value. And I'm going to add in marital status as well. And now we have a pretty interesting looking key influencer visual. Let's analyze this. Let me switch over to increase and we'll see the factors that influence the total credit amount extended to a customer to increase. Based on our bank customer data, it seems like employees who are retired tend to have higher credit amounts. Their total credit amount is on average $49,500 more. Let's take a look at marital status. It seems like divorced employees tend to have higher credit amounts. Customers who have higher overdraft limits tend to have higher credit amounts. It's pretty clear that the same factors probably influence both the overdraft limit and the credit extended to the customer. And another influencer here that makes intuitive sense, if the customer has been with the bank longer, they tend to have higher credit extended to them. If you'd like to drill down into the analysis of the individual visuals, you can simply click on these key influencer bubbles and the chart will change to display that analysis. Here is the bar chart showing the influence of the categorical variable employment status on the credit extended to the customer. At this point, you're very familiar with how to interpret this chart. This visual needs no explanation. Let's look at marital status divorced. And here, once again, you can see that divorced individuals tend to have a higher credit limit by far compared to the average across the other categories. This relationship is interesting and not very intuitive. This definitely bears further investigation. When your target is continuous and the influencer is a categorical variable, you'll see a scatter plot to help you interpret the impact of this variable. Let's select the last influencer here, the years the customer has been with the bank, and when it goes up by the standard deviation, that is 4.2, the credit amount extended to the customer also tends to go up by about $2,000. Now, I'd like to draw your attention to something here at the bottom, the sort by option. You can see that by default, the influencers are sorted based on their impact. This ranks the influencers based on the strength or magnitude of their effect on the metric being analyzed. An influencer with a higher impact score means that its presence or a specific value for that influencer changes the average value of the outcome metric more significantly than influencers with lower impact scores. So the influencer with the highest impact is employment status, then marital status, then overdraft limit, and then years with bank. But let's say you're more interested in the count. Sorting by count ranks the influencers based on the number of data points or records that fall into the segment being described by that influencer. An influencer segment with a higher count represents a larger portion of your dataset. If you'd like to answer the question, which factors apply to the largest groups in my data, you'll sort by count. Here you can see that years with bank had the least impact, but based on count, it affected the largest number of records. If you look at the darker circle around our light gray bubble, you can see that almost all customers in our dataset were affected by this influencer factor. If you sort by count, marital status is at the bottom, and you can see that it affects only about 1/4 of our dataset. The darker outline covers only 1/4 of the bubble. Let's go back to sorting our key influencers based on impact, and I'm going to switch to see what causes the total credit amount to decrease. And here you can see that the key influencers are a little different. When marital status is single, the average total credit amount is about $20,000 lower. This is compared to the average of other values of marital status. And this encompasses 34% of the data. So that's pretty significant. Credit amount also seems to be lower when employment status is unemployed. This is intuitive, but also when employment status is employed. This seems strange. This definitely bears further investigation. Lower values of the overdraft limit gives us lower values of credit amount, and the same is true for number of years with the bank. Let's click on the first bubble, and here you can see that this is a pretty significant influencer. The dotted red line tells you that the average credit amount for other values of marital status is about $44,000, whereas for those with marital status single, it's about $16,000 or so. That's the light blue bar. No wonder this was considered a significant influencer. In a similar manner, you can click through and see the interpretation of the various other key influencers here on this chart. The key influencers tell us what individual factors are important for a particular metric, what individual factors drive a particular metric. The top segments tab tells you who they matter for. The purpose is to show how the visual moves from individual drivers to concrete data-driven personas. It automatically performs segmentation to find high impact clusters. Top segments are defined by groups where there are multiple influencers that combine to form a group. Let's switch over to the top segments tab here in our key influencers visual, and there is a drop down here on top which tells you when the total credit amount is most likely to be low or high. Let's switch over to high and see what the top segments are. The two bubbles here indicate that there are a total of two groups made up of a combination of influencers. It's in these segments that the total credit amount extended to these customers tends to be high. The size of the bubble indicates the number of data points in each segment. You can see that the bubble for segment 1 is higher. So let's hover over that. The average credit amount extended to customers in this segment is roughly $69,000, and in this second segment is roughly $67,000. These segments have higher values of average credit amount compared to others. You can click on these individual bubbles to drill down and view more details for a particular segment. On the left, you can see which customers make up this segment. Customers where overdraft limit is greater than 1500 and the limit is less than or equal to 3200. The horizontal bar chart tells us that the average credit amount extended to customers in this segment is about $69,000, whereas the overall average across the entire dataset is $34,720. The donut chart tells you what proportion of the total dataset falls in this segment. You can see that it's roughly 21%. That's the narrative there. Let's click on the second segment. Here, customers have an overdraft limit of greater than 3,200. Their average credit amount is $67,000 approximately. That's the horizontal bar chart compared to the overall of 34.72K. And these customers comprise of only 11% of the records. Let's switch from high to low to see what segments the total credit amount tends to be low. And there are 3 segments here as well. The bubble for segment 1 is the highest, encompassing more data points. Let's click through and take a look. If the overdraft limit is less than or equal to 0 and the customer has spent less than 6 years with the bank, here the average total credit amount extended is only about 13,000 or so dollars, far less than the overall average of $35,000. And you can click through and take a look at the other segments as well. What characterizes a segment and what's the average credit amount of each segment compared to the overall average. What we just studied was how to interpret the key influencer visualization for a continuous numeric target. So I'm going to name this page Credit Amount Key Influencers. In the next video, we'll see how you can interpret key influencers for a categorical target. In this demo, we'll work with the Key Influencers visual in Power BI. This visual helps you understand the factors that drive a specific metric or outcome. It uses AI, specifically machine learning algorithms like logistic regression, to analyze your data and automatically identify which columns, that is, which influencers, have the most significant statistical impact on the chosen metric. In this demo, we'll first start off by understanding the key influencers visual. We'll first see how key influencers work with continuous targets, where the field that you'd like to analyze for which you want influencers is a continuous numeric value. We'll make use of explain by variables to understand what the influencers are. The key influencers visual offers a top segments view showing you what segments most affect the target. And finally, we'll apply the key influencer visual to analyze categorical targets. We'll perform the same kind of analysis using single and multiple explain by variables, and we'll interpret the top segments view. Let's get started. Let's understand the basics of the key influencers visual. We'll work with key influencers in Power BI Desktop, so you can use the Power BI service as well if you want to. Key influencers is a visual, and you can select this visual and add this to your report. There are a number of data fields that you need to configure. The first is the Analyze field. This represents the target variable whose behavior you want to attempt to explain, like why this value increased, decreased, or why does it belong to a certain category. Power BI's AI will look at the columns you put in the Explain By field to see which ones most significantly influence the outcome specified in the Analyze field. Power BI's AI will examine each field placed here to determine its statistical significance and impact on the target metric. These are the 2 required fields, and these are what we'll focus on. There are other fields that you'll configure if you're figuring out key influencers for aggregations and so on. I've already loaded in the data that we're going to use, bank account customers data. Now let's set a continuous numeric value as our target. Now this data set has a field called total credit amount. This is the credit that's extended to the different bank account customers, and this is what I add to the Analyze field. I'm curious to see what key influencers drive the total credit amount extended to a customer. We start off by looking at just one explain by variable. I'm going to select the account type. And now the visual populates. Power BI has run some machine learning behind the scenes to figure out how account type influences the total credit amount. Let's orient ourselves with this visual here. Off to the left, you have the key influencers. It seems like account type is business is a key influencer. We'll interpret that further in a moment. Off to the right, there is a chart explaining why account type is a key influencer. We'll interpret this in a bit as well. The first thing to note is that there are 3 types of accounts: business, checking, and savings. The key influencer bubble here on the left tells us that when account type is business, then the average total credit amount extended to the customer increases by 49.5K, $49,500. This seems to indicate that business account holders get higher credit overall compared to other types of account holders. The target metric that we are trying to analyze is numeric in nature. And if you click on this drop down on top, you can see what key influencers causes the target metric to increase or decrease. These are the options you'll see for numeric targets. Let's leave this as increase and let's interpret and understand this graph that you see and the fact that account type business is a key influencer. The three bars that you see here show the average credit amount extended to customers with account type business, checking, and savings. The red horizontal dotted line that you see is the average credit amount extended to all customers except those who have account type business. So this is the average for those with account type checking and savings. This very first bar corresponding to business customers tells us that the average credit amount extended to business customers is far higher, almost $68,000. This is about $49,500 above the average for the customers with the remaining account types, checking and savings. And this is the message that we see in the key influencer off to the left. This is why account type business is a key influencer because it tends to increase the average credit amount extended to customers. Let's look at account type checking. Here, the average of total credit amount is about $22,600. This is above the overall average, which is at about $18,800, but not significantly so. This is why account type checking is not a key influencer. And if you look at the average credit amount extended to customers with account type saving, that's below the average, about $15,000. This is clearly not a factor that causes the total credit amount to increase. Now, when we have multiple influencers, this checkbox here at the bottom will prove very useful. This will allow you to only zoom in on those variables that are influencers. Now, what if you're interested in analyzing what causes the total credit amount extended to customers to fall? Let's switch our analysis over to decrease from increase. And here you can see the key influencer is different. You can see that if account type is savings, that causes the average total credit amount extended to the customer to fall by about $29,600. Let's interpret this key influencer using this bar chart that you see here. Now, the horizontal dotted red line gives us the average total credit amount extended to checking and business customers, customers other than those with account type savings. This value is around $44,000. If you now hover over the bar for savings, you can see that the average credit amount is only $15,132. This is about $29,600 less than the average for the customers with the other account types. And that is the message that we see in the key influencer off to the left. Now, for customers with account type checking, well, their average is a little higher. And for customer with account type business, we know that this is a key influencer that causes the credit amount extended to increase. Let me get rid of this account type variable and let's take a look at another variable. Instead of account type, let's take a look at the type of loan that particular customer has taken. Since our explain by field has changed, we have a different key influencer now. Before we interpret this, let me show you a configuration that you can set up for this particular visual. Head over to the tab for Format Your Visual in the Visualizations pane, and here you'll find a section for Analysis. Expand that. The first thing to observe here in the Analysis type is that it's for a continuous target. The total credit amount is a continuous numeric value, and that's why this analysis type has been set automatically to continuous. Another setting that we can turn on here in this visual, a very useful setting, is counts. Let's turn on counts and I'll show you what information it adds to the visual. Take a look at the bubble representing type loan is car. Observe that there is a thin dark blue colored outline around this bubble. The outline doesn't cover the entire circle, but only a part of the circle. The counts field represents the number of data points in our dataset that satisfy the specific condition being evaluated. You can see what proportion of the data set have type loan as car, and that causes their credit amount to decrease in the current visualization. Let's first interpret our key influencer visual by looking at what causes total credit amount to increase based on type of loan. If you hover over the bubble of the key influencer, you'll get a nice narrative summary. Here you can see the influencer. If there is no loan, type loan is none, then the average credit amount increases by about $45,000. And this influencer contains about 35% of the data. So it's a pretty significant influencer. There are 35% of the records with type loan none. This additional information we get because we turned on the counts feature. Now let's take a look at the bar charts here. For loan type none, the average credit amount extended to the customer is about $64,000, which is about $45,000 above the average for the other types of loans. That's represented by the red dotted line. Let's switch back to decrease here, and we've seen that for type of loan equal to car, that causes the average credit amount to decrease, and this is by about $29,000. And this influencer contains about 33% of the data in our dataset. Again, a pretty significant influencer given this proportion. And if you take a look at the bar chart, the average of total credit amount for those with car loans is about $15,000. This is much lower, about $29,000 lower than the red dotted line that represents the average across the other loan categories. Let's get rid of loan type as an influencer as well, and we'll quickly change the explain by field. So far, all of our explain by variables have been categorical. Now I'm going to select the credit score and add that to explain by. Make sure you right click on the numeric field added to explain by and choose don't summarize. This will ensure that the visual considers the raw credit score while figuring out whether it's a key influencer or not. And indeed it is. I'll switch over to increase and I'll analyze this. Let's click on this bubble here, and you can see that as credit score increases, total credit amount also increases. So an increase in credit score of roughly 63 leads on average to a 19,000 roughly unit growth in total credit amount. Analysis on continuous variables is done based on the standard deviation of the continuous variable in the explain by field. The value of 62.84 that you see here is the standard deviation of the credit score. So one standard deviation change increases the total credit amount by roughly $19,000. And here you can see a scatter plot showing the linear relationship between credit score and the average of total credit amount. You can see that at different credit score values, you have multiple data points in the number of customers, and these have been aggregated in this visualization. Now, if you were to switch from increase to decrease, you'll find that a one standard deviation fall in the credit score results in a roughly $19,000 fall in the total credit amount. So if your explain by variable is numeric and your target is numeric, you see a scatter plot visualization and you see how one standard deviation change in the explain by variable causes the target variable to change. We've now come to the very last part of this demo, analyzing categorical targets. Now, earlier we used key influencers to interpret what drives a numeric metric, that is the total credit amount. In this part of the demo, we'll switch datasets and work with customer loan records from a bank and see what drives whether a loan is fully paid or charged off. This will allow us to answer business questions like what makes a customer more likely to pay their loan off or cause their loan to be charged off. This will allow us to analyze what characteristics are most associated with a loan default or a loan being repaid. I'm back in Power BI desktop and I'm on the second page of my report. Loan status key influencers is the name of this second page, and I need to load in new data. I click on Get Data and select Text CSV. I have the credit train dataset on my local machine, and this is what I want to load in. Quickly preview the data and let's load the data in, and I immediately realize that there are some errors in this dataset. This is something I want to fix. It's important that we see what those errors are and deal with those errors as needed. Another thing to observe here that this is a very large data set with about 100,000 records. So let's click on View Errors and see what the errors are and see how we can deal with them. Now, the first thing I notice is that there are errors in the bankruptcies column. Let's click on Credit Train off to the left, that is in Other Queries, and this will allow us to easily identify what columns might have an error. I'm going to scroll over to the right and you can see that there are a few records in the bankruptcies column that have an error. Since our data set is fairly huge and that's sufficient for our analysis, you can just get rid of the bankruptcies column. You can simply select the bankruptcies column, right-click and choose Remove Errors. Now, by mistake, I've selected the tax liens column as well. It doesn't matter. There are no errors in that particular column. This should get rid of all of the errors in our data. Close and apply. We are now ready to move on to analysis using Key Influencer Visuals. Open up the visualization pane, identify the key influencer visual there and add it to your canvas. Let's expand it to fill the entire screen. The data pane shows us the additional data set that's available, the credit train data set. The metric that I'd like to analyze, our categorical target, is the loan status. There are two possible values for this. The loan status can be charged off or fully paid. And I'm curious about the influencers that drive this. Now, the first influencer I've chosen is a categorical influencer, the purpose of the loan. If your visual doesn't display properly, just make sure that your dropdown correctly has the target selected. Do you want to understand what influences the loan status to be charged off or fully paid? I'm interested in charged off, so that's what I'm going to select first. And here are the influencers based on what the loan is taken for. Before we go further, let me head over to the Format pane, go to the Analysis section, and I'll turn on Counts so that we get what proportion of data is affected by that particular influencer. Another thing to note here is the analysis type. Our target metric is a categorical variable. Loan status can be either charged off or paid, and analysis type is categorical. We can now turn our attention to interpreting this visual for a categorical target. For numeric targets, we saw what caused the target metric to increase or decrease. For categorical targets, we see when a particular target metric is more likely to be a particular value. Hovering over the first bubble, we get to know that when the purpose of the loan is small business, the loan status is 1.8 times more likely to be charged off compared to other values of purpose. And this influencer affects a very small proportion of the data set, 0.31%. So maybe this is an influencer you won't pay that much attention to, even though it has high impact. Here's the second one. When it's a business loan, the loan status is 1.5 times more likely to be charged off. The count of this influencer is still low. It affects about 1.47% of the data. Let's move on to the next one where the loan purpose is take a trip. 1.26 times more likely to be charged off. Again covers a very small proportion of the records in our dataset. Let's look at this last one. Purpose is debt consolidation. Such loans are 1.07 times more likely to be charged off. So this is a very minimal increase, but this influencer contains 78% of the data in our records. Let's see how we understand the first influencer using the bar chart. This is where the purpose of the loan is small business. If you look at the red dotted line on the bar chart, on average for categories other than loan purpose small business, the fraction of the loans that were charged off was around 22%. That's the indicator as seen by the red dotted line. But when you hover over the bar corresponding to the small business loan, the tooltip tells you that of the 277 records in our data with this kind of loan, 41.52% of the loans were charged off. That's almost double the proportion of the average. And that's why this is a high impact key influencer. In a similar manner, you can assess the impact of the other influencers that you see in this visual. If you were to order the influencers by count rather than impact, you'll find purpose is debt consolidation goes to the very top. As we've seen earlier, that category includes about 78% of the records. Let's go back to ordering by impact. Now, for this single variable, purpose of loan, there are multiple key influencers. If you only want to focus on the influencers, make sure you check on the checkbox only show values that are influencers. This keeps your bar chart uncluttered and makes it easier for you to interpret your data. Let's switch categories. Instead of seeing what influences loans to be charged off, let's see what the influencers are for the loan to be fully paid. It seems like loans taken with the purpose of wedding are 1.19 times more likely to be fully paid compared to others. But again, a very small proportion of the records is covered. I'll leave it to you to explore the remaining influencers here. I'm curious about another variable. So let's get rid of purpose from the explain by field, and I'm going to add a continuous variable in the explain by field. Make sure you right click and choose the don't summarize option so you work with the raw credit score values. And let's switch to charged off to see what ranges of credit scores make it more likely that the loan is charged off. When you're analyzing a categorical target and the influencer that you've specified is a continuous variable, what Power BI does is that it bins the continuous variable so that we have ranges of values. This is done automatically behind the scenes. For example, here you can see years of credit history is in the range 3.9 to 12.3 years. That's when the loan status is 1.26 times more likely to be charged off. You can see this is a pretty significant influencer that affects roughly 19% of our data. Let's take a look at the bar chart here. At the bottom, you can see there are three categories into which the years of credit history has been divided. 3.9 or less, 3.9 to 12.3, and greater than 12.3. The dotted red line on the chart tells us that for years of credit history, 3.9 and fewer years and more than 12.3 years, the proportion of loans charged off is about 21.9%. The tooltip on the key influencers bar tells us that for this particular category, 25% of the loans tend to be charged off. And that's why this is a key influencer. Let's switch over to fully paid, and you can see that people who have a higher number of years of credit history, more than 12.3, are 1.1 times more likely to have paid off their loans. We've interpreted the influence of single variables in the explain by field. I'm now going to add in multiple variables. So I've added years of credit history, home ownership, and years in current job. And this will set up several key influencers for us. The years of credit history is clearly the most impactful. We've already seen this before. But home mortgage is also impactful. When customers have a mortgage, they are 1.06 times more likely to have their loan be fully paid. Let's quickly switch and see when loans are more likely to be charged off. And here, the most impactful influencer is home ownership is have mortgage. If customers have a second mortgage, the loan status is 1.39 times more likely to be charged off compared to other values of home ownership. Another influencer is years in current job. When this information is not available, the loan status is 1.33 times more likely to be charged off, and this affects a significant proportion of the data, 4.33%. Now let's look at the top segments driving loans to be either charged off or paid. So I've set loan status is more likely to be charged off, and you can see there are 4 segments here. Remember, the size of the bubbles indicates the number of data points in that segment. If you look at the bottom, you can see the population count in each segment. The first segment has about 13,000 records, and you can also see the percentage of the population where the loan status is charged off. And in every case, this percentage is higher than the overall average, and we'll be able to view the details when we click through to a bubble. You can see that there are multiple influencers that apply to this segment. Home ownership is not home mortgage, so it's a value other than home mortgage, and the years of credit history is greater than 3.9 and less than or equal to 12.3. Take a look at the horizontal bars. In this segment, 25.9% of the loans are charged off compared to the overall average, where it's just 22.5%. And this affects about 13.3% of the records. That's what is included in this segment. Viewing the top segments information in this manner allows you to dive deeper into these customers to figure out why they have such high rates of loans being charged off. I'll now switch over to fully paid, and you'll find that there are 2 segments in this category. And just like with each of the others, you can get more detail by clicking on the bubbles and viewing each segment in turn. In this demo, we'll see how Power BI helps us with anomaly detection. Anomaly detection is a process used in data analysis to identify data points, events, or observations that deviate significantly from the normal or expected pattern within a dataset. The purpose of anomaly detection is to flag unusual occurrences that might indicate errors, fraud, system failures, or unique opportunities. In this demo, the very first step is to load and prepare the data. It's important that we have a clean and reliable dataset to work with. Next, we'll create the baseline time series visual, and then we'll enable and tune anomaly detection on this visual. We'll then dive in further and investigate these anomalies and get explanations for them. We'll also see how we can get explanations for increases and decreases in the data in a line chart. And finally, we'll see how we can use a line chart for forecasting, predicting values out into the future based on the past. Let's start with the very first step where we load and prepare our data. For a little variety, I've switched back to using the Power BI service on Microsoft Fabric. And I'm going to place all of the assets for this particular demo in a new folder called Global Superstore. This is a different Superstore data that I'll be working with. Let's go ahead and load this data in. I click on Create and it gives me a number of options to load data. Click on Get Data and this will specify a number of options allowing you to indicate where your data source is. Well, my data is a CSV file on my local machine, so I choose the text CSV option and here I choose to upload the file. You can then click on the Browse button here and this will bring up the Explorer window on your local machine. Find the location of the Global Superstore dataset and go ahead and upload it to our Fabric account. Click on Next. This will allow you to preview the data that you've just loaded and transform it if required. A quick glance at the data shows me that the data format is just fine. Order date and ship date are both dates and they are interpreted as dates. If you scroll over to the right, there are a number of numeric columns here: sales, quantity, discount, profit, shipping cost. All of these are interpreted correctly as well. So at first glance, everything seems right. We can go ahead and create a report using this data. The Power BI service on Fabric automatically opens up the Power Query editor in case you want to make any edits. Now, the name of my data was called Global Superstore 2. I just edited my query to be called Global_Superstore. Now, here you can choose to create a semantic model alone or a report. I'm going to select Create a Report because this will automatically set up the semantic model under the hood. Notice that you're first prompted for the name of your semantic model. I'm going to place this inside the Global Superstore folder and the semantic model is called Global Superstore as well. Go ahead and hit Create. Once our data has been successfully loaded in, let me just save this report so that I have it available later if I need it for reference. Click on the File dropdown and select Save. I'll call this report Anomaly Detection and Forecasting and place it within the Global Superstore folder. Go ahead and hit Save. By default, your report will show up in the View mode. Click on the Edit button to switch to Edit mode. Our next step is to set up a baseline time series visual. This will be a simple line chart showing profits over time. In addition, as a little overview, I'll demonstrate the simplest form of anomaly identification using Power BI's Insights feature. This will be a quick visual discovery of unexpected behavior in our time-based data. Back to our Power BI report, select the line chart and add that to the canvas. And let's place order date on the x-axis. Now for our initial analysis, I'm going to have the date granularity be at the level of month. I do not want to work with daily data. Instead, I'd like to work with monthly data. And what I'm looking for is the profit over months in our Global Superstore data here. You can see some clear patterns here, some seasonal variations, and there are definitely certain anomalies. There are two high peaks in 2013 and 2014, and there are some lows as well. We'll use this visual for quick insights. Let's take a look at this data at a more granular level. Here you can see the seasonality much more clearly. There is a clear pattern in how profitability changes over time, though there is a general upward trend overall in the data. Let's go back to our monthly granularity and I'll do a quick review of anomaly detection using Power BI's Insights feature. This is just a quick look at where anomalies lie in our data. We'll perform a more detailed analysis in just a bit. Click on the three dots at the top of your visual, select Get Insights, and this will bring up the AI-powered insights. This shows you both anomalies and trends. Here you can see the overall anomalies and the recent anomaly. There are three anomalies overall. March 2013 and April 2014 were two highs. You can see those peaks in the line chart, and there is a low on February 2013. You can find these anomalies on your chart very easily. Here is the peak in March 2013. I'll leave it to you to find the remaining two anomalies. AI-powered insights gives you explanations for your anomalies as well. Let's click through to all anomalies and you can get explanations for specific anomalies. Here we have profit unexpectedly high on March 2013. For some reason, the chart hasn't loaded, but you can click through and see possible explanation. It seems like this anomaly was driven by the corporate segment, subcategory was copiers in the central region, and driven by an individual named Tamara. You can expand any of these categories to drill down further into the anomaly. And in fact, you can add these charts to the report to understand where the spike came from. And the best way to analyze this is by aligning the original chart and the chart which gives you an explanation for the anomaly. The chart below tells you that almost the entire profit for March 2013 was driven by the corporate segment. You can see that the dark blue line is very close to the light blue line for the spike in March 2013. Let's look at the copiers subcategory. That's a more granular drill down. I've deleted the current chart and I'm going to add this new chart to the report. And here again, it's very obvious that there was a massive order for copiers that drove this spike in profitability. Almost all of the profits for March 2013 seem to be from copiers. AI-powered insights are great to give you an overview of anomalies in your data. But for more granular anomaly detection with more detailed explanations, let's go to the anomaly detection algorithm that Power BI offers. This specific algorithm will give you a lot of control over the anomaly detection process. For example, you can tune the sensitivity of the algorithm to control what you consider an anomaly. In this part of the demo, rather than just viewing the anomalies extracted by AI insights, we'll use the dedicated configurable anomaly detection tool that Power BI has to offer. This will show you that you as a user have direct control over the statistical model for anomaly detection. This tool will allow you to configure the sensitivity of the algorithm to fine-tune the analysis to match your business context. This can reduce noise from false positives and ensure you don't miss subtle but important outliers. Let's go back to our Power BI report here where we have our time series chart, and I'm going to switch this time series to show a more granular view. Let's switch over to the daily view by adding the day component of the day hierarchy. The data itself is very spiky in this daily view, but there are clear anomalies, clear outliers in the data. In order to enable anomaly detection on this chart, in the visualization pane, head over to the analytics pane. And here you can see a number of analytics features associated with the line chart that we have selected. Observe that it's possible for you to add a trend line to the chart. This will give you the general trend of the data. I'll just enable this and you'll see a trend line show up in our visual. You can see that for the most part, the data has a gentle upward trend. So there's a gentle upward slope in profitability. Let me change the color of this trend line so that it's more visible against the blue line chart. I've changed the color to red. There are other markers and indicators that you can add to your line chart as well. For example, if you'd like an average line indicating the average over time, simply go to the average section and add the average line. Now the average almost overlaps with our trend line. That's why you can't tell them apart. Well, that doesn't give us much information. Let me get rid of this line. Another useful feature is to have lines marking the minimum and maximum values in your dataset. I'm going to add the min line first, and this will give me the lowest value for profit, and it draws a horizontal line there. there is a corresponding max line section as well. Click on Add Line, and this will add a line across the maximum value of profit for your line chart. These are useful markers to have when you'd like to see where the bounds of your current data lie. Let's get rid of the min line and the max line, but I leave the trend line in. I find that useful. In the same analytics pane, somewhere towards the bottom, you'll find a section for anomalies. Anomaly detection is turned off by default. I'm just going to slide this over and enable it. And once that's done, in just a few moments, you'll find that your visual will update and highlight all of the anomalies found in your data. You can see all of the high spikes and low spikes have the black markers. These are the detected anomalies. Along with the anomalies that have been highlighted, observe that around the blue line that represents our profit over time, there is a gray background. This gray band is the confidence band of the anomaly detection algorithm. This defines the range of values the algorithm expects based on analyzing historical patterns. This gray background essentially creates upper and lower boundaries that represent the limits of normal anticipated variation at that specific point in time. Any data point that falls outside this calculated band is flagged as an anomaly because that data point significantly deviates from what the historical data suggested would be typical. It's important that you understand this confidence band, the intuition behind it, because we are now going to discuss a parameter that you can tune in this anomaly detection algorithm, the sensitivity. The sensitivity setting controls how wide the expected range or the confidence band is around your data points. By adjusting this parameter, you can directly affect how many anomalies are detected in your data. Sensitivity is 70% by default. I'm going to set it to a much lower value, 5%. And let's see what happens. Observe the gray confidence band fills up to the entire screen. There are no anomalies in our data at this lower level of sensitivity because all of the data points are within our confidence band. By lowering the sensitivity, what we've done here is made the range of values within which our data points are expected to fall much wider. In fact, we made it so wide at this low value of sensitivity that there's absolutely no point that's flagged as an anomaly. All of them lie within the confidence band. Let me increase this a bit to 10%. Well, there's no change. This is still not sensitive enough. Let me increase this to a much higher value. I'll set it to, say, 30%. Let me apply this change, and then you'll see the effect of the confidence band. Now, here, the confidence band is still large. You can see the large gray area demarcating the expected range for your data points. You can see that as we went from a lower to a higher value of sensitivity, it makes our confidence band narrower. This means that more data points are likely to fall outside this band, resulting in more anomalies being detected. At 30%, you can see a few outlier data points here, about 5 that have been identified. Let's increase the sensitivity further. You can use the slider or you can type in values and you'll find that more data points are detected as outliers. Let me apply this change, and at 50%, there are many more anomalies in our data. Now, of course, the more sensitive we make the algorithm, more data points will be identified as anomalies. And you have to find the right balance for your use case. Let me tune the sensitivity all the way up to 90%, and you can see there are many more anomalies here in our data. How do you figure out what the right value of sensitivity is? Depends on your specific analysis goals and your tolerance for noise in the data. What we've done here is we started off with the default sensitivity value and then tweaked the sensitivity down where no outliers were detected and then tweaked it back up. If you find that too many minor fluctuations are being flagged that are not meaningful for your analysis, reduce the sensitivity. On the other hand, if you suspect that subtle but important anomalies are being missed, increase the sensitivity. Normally, I would have stuck with the default value of sensitivity, 70%. However, our data happens to be very spiky and I do not want so many anomalies to be flagged. So I'm going to reduce the sensitivity down to 35%. And by visual inspection, I feel good that this makes sense for my data. You can see that the confidence band for this reduced level of sensitivity is fairly broad. There are only a few points flagged as outliers. Now, in addition to tuning the anomaly detection algorithm, you can customize the visualization as well so that your outliers are highlighted more clearly. I've changed the shape type for my anomalies. They are now represented using square markers. You can increase the size of the markers so they are more visible. Let me set that to 8 pixels, and you can change the color as well. I'm going to pick a color that highlights the anomalies very clearly, a deep red. This will help draw attention to the anomalies in my visualization. And I've reduced the transparency down to 0, so they are a solid red. That's it for the customization of the visual. Let's take a look at the anomalies highlighted and find explanations for those. You can hover over the individual anomalies and get additional tooltips. Here you can see that the total profit was about $4,400. The value that our algorithm expected was around $730. And the min and max values of the confidence band at this particular point is minus $940 to $2,400. So the $4,400 that we see here for profit is way outside this range, and that is why this has been flagged as an anomaly. Let's look at another anomaly here on May 9th. The tooltip will give us additional information. The profit was negative 1,000 or so. The expected value was 917, and the range was between minus $525 to $2,360. The expected min value and max value define the confidence band calculated by the anomaly detection algorithm for a specific point in time. This range represents the range of values the algorithm predicted as normal or expected based on historical trends and seasonality in our data. Now, these predictions are context specific and depend on the patterns leading up to each date. This is why the expected minimum and maximum value varies for different points in our time series. In the last part of this demo, we'll move on from anomaly detection to forecasting. Forecasting projects future performance directly from historical data. So we have the same time series data that we worked with earlier, but now we'll not perform anomaly detection here. Instead, we'll perform forecasting. We'll see that the same data that was used to analyze the past in terms of anomalies can be used to predict the future, that is forecasting. You can see how Power BI integrates multiple powerful analytical functions into one intuitive interface. Now, here is our anomaly detection visual. I'm going to head over to the analysis pane under visualizations, and I'm going to turn off anomaly detection. I'm no longer interested in anomalies. I'm interested in forecasting future trends of profitability in my data. I'm going to reduce the granularity a bit. I only want this time series data at the granularity of a month. On the x-axis, we just have the year, quarter, and month components of the date hierarchy. And you can see that the line chart is a lot less granular. We still have the trend line though. The forecasting feature is also available on the analysis pane. Click on the analysis option and let's scroll down and find forecast. You can expand this section, and of course, to be able to use the configuration features, you need to enable forecasting. Let's turn forecasting on. Now, as soon as I enabled forecasting, observe that my visual changed. We now have profitability information based on our forecast extending into the future. Now, the line in blue, the blue part of the line is our historical data. The line in gray is the future forecast. This is the profitability that our model predicts over the next 10 months. How do I know this forecast is over the next 10 months? I'll explain in just a bit. In addition to the gray line, that is the forecast generated by the AI model, we have a shaded gray area. This represents the confidence interval of the forecast. The confidence interval defines a range above and below the forecasted line, indicating the statistical probability that the actual future values will fall within that range. Let's now turn our attention to the default forecasting options that were used to produce this forecast. Now, under options, we first have units. This setting determines the time period used for the forecast length. You can see that by default, the units are specified in points. This references the granularity of data points in your original time series data that was used for forecasting. We changed the granularity of our time series chart to be monthly profit. So a single point here represents the profit for 1 month. Next, we have the forecast length, which is set to 10 by default. This value specifies how far into the future you want Power BI to predict the trend. This value of 10 combined with units in points would forecast the next 10 months because that's the granularity of our data. Ignore the last allows you to exclude a specified number of recent data points from being used to train the forecasting model. This can be useful if the latest data is incomplete or considered unreliable for predicting future trends. Seasonality can be set to a specific period, weekly, monthly, or yearly cycles, to help the model identify recurring cyclical patterns in your data. By specifying the number of points or units in one full cycle, allows the forecast to account for predictable peaks and troughs. Finally, we have the confidence interval that determines the shaded gray area in your chart. The default confidence interval is 95%. A 95% confidence interval means the model estimates there is a 95% chance the actual value will be within the shaded forecast area. The granularity of our data is monthly. So if I were to switch the units over to months rather than points, you'll find that the forecast does not change. I hit apply. You can see the forecast remains exactly the same. Let's now predict further into the future. I changed the forecast length to 20 with the same confidence interval. I hit apply. Notice that we have a longer gray line now, and you can see that the forecasting model has picked up the same seasonal cycles that exist in our current data. I'm going to increase the forecast period once again. From 20 months, I'm going to go to 30 months and hit apply. We get a forecast further into the future. And if you've noticed, the gray shaded area gets bigger. There is an intuitive explanation for this. The confidence interval widens for forecasts further into the future because uncertainty naturally increases over longer time horizons. Predictions are based on past patterns, and the further out you project, the more potential there is for unforeseen factors or random variations to cause the actual values to deviate from the predicted trend. This growing uncertainty of forecasts further out into the future means the model has less confidence in pinpointing the exact value, resulting in a broader range of statistically plausible outcomes. So for the same 95% confidence interval, the range of the confidence interval is wider further out into the future. Let's predict even further out. I'm going to change the forecast unit to quarters rather than months, and I'm going to change the forecast length to 20 quarters and hit apply. And you see here that the forecast now is really far into the future. Our data ends in December 2014, and now we have forecast all the way through to September 2019, or even further. The forecast is till November 2019. Let's now change the confidence interval of our forecast. Adjusting the confidence interval will affect the width of the shaded area. I've reduced the confidence interval down to 75% and I hit apply. You can see here that decreasing the confidence interval makes the shaded band narrower. This reflects a lower degree of certainty, meaning or accepting a higher chance that the actual values might fall outside this tighter estimated range. Remember, the further out in time you forecast, the more uncertain your forecast and the more unreliable. I'm now going to forecast out 10 years. And this is what the forecast looks like. It's essentially assuming the same pattern over 10 years, and that's not really realistic. A lot can change over the next 10 years. Our business may not remain the same, so this forecast is inherently unreliable. Let me switch the confidence interval back up to 95%, and you can see that widens the shaded area. Increasing the confidence interval makes the shaded band wider because this means we want a higher degree of certainty that the actual future value will fall within this range. So the model provides a broader estimate to capture more possibilities. Let's move on to the next step in this demo: investigate and explain anomalies. We are moving from detection to diagnosis. We'll see how Power BI helps us answer why an anomaly occurred. Power BI makes use of AI under the hood to automate the root cause analysis by testing various dimensions in our data and surfacing the most probable drivers. We've seen that AI Insights also allows us to investigate anomalies, but the anomaly detection algorithm, the standalone anomaly detector that we're using, allows us to dive into the specific anomaly that we're interested in. You see this spike in March 2013? That's the anomaly I want to investigate further. So I double click on that little anomaly detection icon. And this will open up the anomalies pane, allowing you to investigate this particular anomaly further. You can see that for this particular date, profit was unexpectedly high, over $9,000. And here below, you have the possible explanations and the strength of each explanation as well. The possible explanations for each anomaly are listed in the decreasing order of strength. The strength score indicates how strongly that particular factor is correlated with the detected anomaly. A higher strength score suggests a stronger statistical relationship, meaning that the specific dimension, here segment is corporate, is more likely to be a contributing factor as to why the anomaly occurred. We should use this as an indicator to prioritize which explanations are most significant when investigating the unusual data point. It's pretty clear that on this particular day, there was unusual activity in the corporate segment. Profit in this segment was unusually high, and that contributed to the anomaly. If you scroll down, you'll see all of the possible explanations. There's a section for each, and there is a strength associated with each. The possible explanations are ordered in the descending order of strength. The huge order that occurred in March was shipped using standard class, so that occurs as a possible explanation. And then if you scroll down below, this particular order was in the central region, so that occurs as a possible explanation as well. And this was in the country United States. Market is US. That doesn't give us any new information. We already know country is United States. But this next one is interesting. Subcategory is copiers. It seems like there was a huge order for copiers that was incredibly profitable, driving up the profits for this particular month. And copiers, of course, belongs to the technology category. And that's the next possible explanation. And then we have order priority is medium. This doesn't seem like a very meaningful insight. The highly profitable order just happened to be shipped using order priority medium. Now, it's pretty clear when you look at all of these explanatory variables, these possible explanations, that some of these insights are meaningful and others are not. If you have a large number of variables, it's quite possible that many of the insights generated are not meaningful. Now, you may have a few ideas about what categorical variables actually explain these anomalies, and you may want to see analysis only for those variables. You can use the analysis pane and configure the anomaly detection algorithm to focus only on these variables. In analysis, go to the anomaly detection section, and here under action, observe that we have an explain by field. This field lets you add categorical columns from your dataset that you think might explain why the detected anomalies occurred. When Power BI finds an anomaly, it will automatically analyze the dimensions that we've specified to see if specific values within them correlate strongly with the anomaly. This way, you can help the AI provide more relevant potential explanations for the unexpected spikes or dips in your data. Now, I'm going to configure this field with a few categorical columns. I think the segment is always meaningful. If a certain segment had a spike in profit or a dip in profit, I'm going to go ahead and apply this. The minute I specify a particular value in the explain by field, I'm going to double click on that anomaly. When you look at the possible explanations for the anomaly, you can see that only the categorical column that you've specified is included here. Segment happened to be a potential reason for this particular anomalous profit, and only the analysis for segment is available here. We don't have analysis based on the other fields because we haven't added them to explain by. Another variable that I think is meaningful is category. I'm going to drag category and add that to the explain by field in my analysis pane. Once I hit apply, if the category is a meaningful potential variable to indicate why this anomaly occurred, that will be added to the possible explanations. Here you see segment is corporate, category is technology. Both of these are meaningful based on Power BI's AI. Let me add one more categorical variable, the subcategory, and I'm going to drag that onto the explain by field. And you see the anomalies insights pane will update once you hit apply. We've now trimmed down the possible explanations only to the variables that we think are meaningful. If you want to see all possible explanations because you're not sure what drives a particular anomaly, you just keep the explain by field empty as it was to start off with. If you hit apply, you'll get all possible explanations once again. Before we call it a day on figuring out possible explanations for an anomaly, let's look at a point where there was a steep drop, an anomaly in the negative direction. May 2012 showed a negative profit when the expected value was positive. Let's see what drove this anomaly, possible explanations for this anomaly. Order priority is high. There was a high priority order that contributed to the losses on that particular month. And this was in the home office segment. The ship mode used for the orders that contributed negatively to profit was mostly standard class. That's a possible explanation here as well. And it seems like this low profitability was caused due to very low profits from India. This is how you can use the anomaly detector to drill down into possible explanations for your anomalies and then, of course, investigate further as needed. We'll move on to the next step now to perform more on-the-fly analysis. This particular part of the demo is not strictly associated with anomaly detection, but it's closely related and can be used to analyze any point in the dataset. We've already seen this AI-powered feature before when we worked with bar charts. Here I'll show you how this can work with line charts as well. Explain increases and decreases allows users to generate quick explainable drivers for changes without any manual modeling. Now let's close out our anomalies pane, and I'm very curious about this steep rise in my profit in March 2013 that caused the anomalous point. So I right click, select analyze and say explain the increase. The other option you have here is explain the anomaly, but we've already seen that, so we'll go and explain the increase in the value of profit. You can see overall there was a 775.28% increase in the sum of profit between the previous instance, that is the 9th of March, and the 10th of March, that is the current instance. The fact that the most significant variable is customer ID should immediately tell you that this was a one-off order that was very, very profitable. There was a particular customer with ID TC20980 that contributed the vast majority of this profit. And you can see that this analysis gives you the four familiar charts: the waterfall chart, the scatter plot, the 100% stacked column chart, and the ribbon chart. Let's focus on just one of the variables and quickly dive a little deeper. Here is an explanation for the increase in profit broken down by segment. Our line chart displays values with daily granularity. So the initial time period is the previous day, March 9th. Here the profit was just $1,000. This big green bar shows that there was a huge order in the corporate segment, and the profit that this contributed was $9,400. There was another smaller order that was profitable. This was in the home office segment. On this particular day, the consumer segment was loss-making, but again to a very small extent, and that gave us the massive profit on March 10th of $9,300. If you prefer the scatter plot over the bar chart, the same information is available here. If you remember the red and green sections, the segments in the red section had a negative contribution to profit, that's the consumer segment, and the other two segments, home, office, and corporate, had a positive contribution to the profit. Next, we have the 100% stacked column chart. Here you can see the corporate segment formed just 15.2% of the overall profit on March 9, whereas on March 10th, its contribution was 94.7% of the profit, and the profit itself was larger. I think the best chart for the analysis of this particular point is the ribbon chart. The ribbon chart's flow-like structure shows you very clearly how the contributions of the various segments changed over the time period that we are interested in. If you hover over the blue ribbon, you can see that this is the corporate segment, where the profit went from $302 on March 9th to $9,400 approximately on March 10th. and its rank changed from 2 to 1. Now, I won't go through the analysis for decreases in detail, but you can select any downward spike, right click, analyze, and you'll get the option for explain the decrease. And this will show you the same for charts, explaining why this decrease occurred based on the different categories that exist in your data. At this point, you should be an expert at this kind of analysis, so I leave it to you to analyze and interpret this decrease by yourself. In this demo, we'll explore and understand the decomposition tree visual in Power BI. This allows you to explore a measure by breaking it down across multiple dimensions hierarchically. It's an incredibly useful tool for root cause analysis and ad hoc exploration so that you can intuitively drill down into different dimensions in any sequence to understand their contributions to the total. The visual incorporates AI by offering high value and low value analysis options, automatically suggesting the next dimension to drill into based on which dimension's values have the most significant impact on the measure being analyzed. In this demo, we'll first build the basic decomposition tree and understand how you can drill down into a particular measure based on the different variables that you've specified. Next, we'll see how we can specify the order and hierarchy of splits. Here, we'll also discuss why it's important that you specify your splits exactly in the right order for the drill downs to make sense. We'll then add more categories and customize the tree visual. Customizing the tree visual will allow us to use colors and other markers to really bring across the information we are wishing to convey. We'll then work with decomposition tree and interactivity. We'll see how it interacts with other visuals that you might have on the same report and how filtering and cross-highlighting works. We'll then explore the AI-powered insights that the decomposition tree offers for automatically splitting a measure into high and low values. And finally, we'll see how you can lock levels so that your explanations are more controlled. We'll first load our data and start with the very first step of building a basic decomposition tree. This will allow us to see how you can interactively break down a key performance indicator into its constituent parts. I'm going to do this demo on Power BI desktop, and we'll work with a dataset that we haven't used before, the Adidas sales dataset. You can see that I already have the dataset loaded and available to build a decomposition tree. This dataset contains sales information for Adidas products. For every sale, we have a number of bits of information: the city where the sale was made, the product, the retailer who made the sales method, whether it was in an outlet or online, the state, and the region. This is a great data set to allow us to drill down into where most sales are, which city is doing well, which retailer is performing well, and so on and so forth. And this is exactly why we'll use the decomposition tree. Select the decomposition tree visual from the visualization pane and add that to your report. The decomposition tree is indeed a tree. Every tree has a root, and the root node that you specify is the metric that you'd like to analyze. The two main fields that you need to specify for the decomposition tree is analyze and explain by. The metric goes in the analyze field. That's what we want to analyze, sum of total sales. Now, how would you like to break down the total sales? That's what you specify in the explain by field. If you hover over total sales, you'll see that sales are at around 899 million. The decomposition tree will allow us to see how different states, cities, retailers contribute to this sale. The first explanatory variable that I add is region. As soon as I add this, you can see a little plus icon next to the root node of our decomposition tree. You can now select this and choose how you want to see sales broken down. For now, ignore the high value and low value options. Those are AI-powered insights that we look at later. Select the one explanatory variable we have, region, and you can see how the sales stack up. The blue bars indicate the relative proportion of sales across regions. West has the highest, so that bar is entirely blue. The size of the blue bars of the other regions are relative to the West region, which has the highest sales amongst regions. Of the total 899 million or so sales, 269 million is in the West region. Northeast comes next with sales of about 169 million. The blue bar for Northeast is shorter than that of the region West. This shows you at a glance without looking at the numbers that sales for Northeast are lower than the sales for West. Of all the regions, Midwest at the bottom has the lowest proportion of sales. You can hover over these nodes of the decomposition tree to get additional information. You'll get the sum of total sales in each of the regions by hovering over the node for that region. Let's say you wish to drill down into your data further. After looking at the regions, you're curious about specific states in the region, how they perform. Let's add state as an explanatory variable, and this gives us the little plus icon next to region, and you can click on that plus and choose to drill down further by state. And you'll see the states in the different regions. Our decomposition tree now has an additional level. We first broke down the sales by region and then by states within a region. The states categorized as West are California, Washington, Hawaii, and many others. Of these, California has the full blue bar. This has the highest sales of all states in the West region. If you were to now select the Northeast node, you'll see the breakdown of sales for the region Northeast. And in the Northeast, you can see that New York has the most sales in this region, with Maine, New Jersey, Northeast somewhere at the bottom. And in this manner, by selecting the nodes of the decomposition tree that you're interested in, you can drill down further into your data. Now, you may have noticed how I added the levels in the decomposition tree. I first added the region level and then state. Because region is less granular than state, state is more granular. The order in which you add categories or levels to your decomposition tree is extremely important because the visual is designed for hierarchical exploration, starting with the total and breaking it down level by level. Adding the broadest category first and then moving down to more detailed categories mimics a natural analytical workflow. This structure allows users to first see the major components contributing to the total measure and then progressively drill down. Let me get rid of these existing levels here, and I'll show you an example of adding categories. As you drill down, you'll find that your decomposition tree visual is not as useful as it could be. Now I have to explain by variables region and state. I'm going to add city to that, and I'll drill down first by state. So this is less granularity than region, and after state, I'm going to add region as the next level. State is a narrower category than region, and then after region, I'm going to add city. This is the least granular category. Observe that things really are hard to parse here. New York as a state belongs to just one region, Northeast. So when you have New York selected, all of the sales can be attributed to the Northeast region within New York. You know that there are other states in the Northeast region. You don't get that information in this view. And it seems like the cities New York and Albany belong to the Northeast region, but they actually belong to the state New York. California belongs to the West region. Texas is in the South. You can see that our drill downs are not intuitive, and in fact, they're less useful. So total sales in New York, 642 million. And when you drill down into the region, it says, oh, sum of total sales, 642 million. This is misleading because we know that sales for the Northeast includes other regions. And that information is not available in the hierarchy that we've set up. Well, I hope this has convinced you that in your decomposition tree, you need to go from the broadest category to the most granular for an intuitive analysis. We are now ready to move on to the next part of this demo, using AI splits for automatic insights. This will demonstrate the augmented analytics power of the visual. You'll see that Power BI can act as an analytical guide. The AI automatically finds the most statistically significant driver at each step. Decomposition trees are an AI-powered visual. So far, we've been drilling down into our total sales measure manually. We are choosing the dimensions that we'd like to use to drill down. However, you can make use of AI, and that comes here in the high value and low value splits. High value and low value are both AI splits. When you choose the high value AI split, Power BI analyzes all of the available dimensions. You can see those 6 dimensions listed right there in the menu. Power BI will analyze these and automatically expand the tree along the dimension value that has the highest positive contribution to the measure that you're exploring. It helps you quickly identify the biggest drivers or components of your total. So let's select high value, and you can see the highest value split is by sales method. This means the differences in the total sales value based on our three sales methods, in-store, outlet, and online, are the most significant factor driving the total value at this point in the decomposition tree. That is, at the very root of the decomposition tree. The sales method is the dimension that Power BI realize gives you most variation in the data. There are large differences between the various sales methods. So if you're looking for an important area that you may want to optimize first, you may want to go with sales method. Let's now choose high value once again. So I select any of the nodes here in the second level, and then I select high value. And now the highest value comes from retailer. After sales method, the most important driver of total sales is a particular retailer. And here you can see Westgear clearly leads. Once we've chosen a particular sales method and we've chosen a retailer, what's the highest value driver? That is the region in which the retailer operates. The highest value contribution after region comes from the individual cities. Here, we are not the ones determining the hierarchy. The hierarchy comes from the AI analysis of our data. And of course, all of the other operations function as before. You can select individual regions, individual retailers, the sales methods, and drill down and explore based on what it is that you're trying to figure out. Now that we've understood how high value splits work, let's switch and understand how low value splits work. I'll just get rid of all of these levels in my decomposition tree. The low value AI split directs Power BI to expand the tree along the dimension value that has the lowest contribution or the largest negative contribution, if that's applicable, to the measure. This helps you quickly pinpoint the biggest detractors or areas that have the smallest impact. Now, starting from the root node, let me select a low value split, and you can see that it's by city. And you can hover over this little highlight here to give you more information. It seems like even among cities, the sales in Omaha seem to be the lowest. The fact that the lowest value split came from city, this means that when Power BI analyzed all of the available dimensions, the differences in total sales between the various cities had the least significant impact on explaining the total sales value that we are looking at in the tree. Splitting the sales by city reveals the smallest variation in the data. Cities contribute the least to understanding the overall sales figure compared to splitting by other available dimensions. Now, I'd like to show you the sales in Omaha, but since there are a large number of cities, this visual is a little glitchy and refuses to scroll down all the way. Let me switch to the table view and see if that helps us. Well, that doesn't really help us much, but let me go back to the report. And there's Omaha with the lowest value of sales across cities. Now, let me split by low value once again. And after city, the least variation is in the sales method. This means that the differences between the various sales methods across cities are smaller compared to other dimensions. Let's split by low value once again, and next we have by product. Given a particular city and a sales method, there is the least variation amongst the different products sold. And then, of course, we can drill down further. We select low value once again, and after product, it happens to be a retailer. And then this you can continue for as much detail as you want to. Let me select low value once again, and this gives me region. And then, of course, the next dimension is just state. Let's look at one last feature in decomposition trees before we move on. Once you've expanded a decomposition tree into the individual dimensions that you want to use to drill down, you can lock certain levels. This way, you can fix a specific insight in place. This will allow your audience to follow the intended analytical story without accidentally collapsing a crucial part of the tree. This is typically something that you'll use for guided workflows. I'm now going to set up the various levels in the decomposition tree based on what I think is the right way to drill down into the data. I've now got all of the levels that I want here in this tree. You can hover over this little lock icon. It's available next to each level, showing you that it's possible to lock any level in this tree. When you lock a specific level in the tree, all of the levels above that level get locked as well. So I'm going to lock the product level. Notice we now have the lock icon next to each, and the lock is in the locked state. Also, those little crosses that you see that allow us to remove a level, they are no longer present. In this locked state, if you were to share this report with other team members, they would not be able to get rid of individual levels. If you'd like to be able to remove levels as you see fit, you can click on the unlock icon. If you unlock at a higher level, all of the levels below it will be unlocked as well. The cross icon is back, and then you can remove levels as you see fit. Let's move on to the next step in our decomposition tree demo. We'll add more categories as explanatory variables and customize the tree. Here is where we are. We have sum of total sales broken down by region, and we have 4 variables in the explain by field. I'm going to add more variables here. Let me add the retailer and the product as well. We now have 6 variables. You now have a choice of dimensions that you can use to drill down further into the tree. Let's now drill down by sales method. You can see that in different regions, we have 3 types of sales: outlet sales, in-store sales, and online sales. I'll now drill down further by product. I'm curious as to how different products perform using these different sales channels or sales methods. Men's street footwear seem to have the highest sales amongst outlet sales in the West, and women's athletic footwear tend to have the lowest. This is all relative, of course. And in the West region, if you were to look at online sales, you can see that women's apparel does the best and men's apparel is the worst, relatively, of course. And in this manner, you can select the different regions, the different sales methods, and drill down right to the sales of products. Let's say there is a particular bit of analysis that you find interesting. I'll select West as the region. I have online sales selected, and then I have the sales of individual products. Now, let's say I need this information in a tabular format. You can click on the 3 dots, and there is an option here to show this as table. Select Show as Table, and you'll see exactly what you selected is highlighted here in this table. We had the West node selected, and within that, we have outlet, in-store, and online sales. We had online sales selected, and you can see the breakdown for online sales here as well. This table gives you information based on the current state of your decomposition tree. All of the levels and nodes that are currently displayed will have entries here in this table. Because we hadn't drilled down into the Northeast or South or Midwest regions, we just get top level numbers for those. Next, let's customize the look and feel of our tree. For this, you need to go to the Format Visual tab of the Visualizations pane, and there are a whole bunch of ways you can customize your tree. I'm going to do a few simple UI-related customizations. Let's change the default color in which the tree nodes are displayed. In the Colors section, you can specify different colors for positive bars and negative bars. Now, if you're drilling down into a metric like sales, sales can only be positive, can't be negative. But let's say you're drilling down into profit, you can have negative profit, that is a loss. And that's where the negative bar color will help you highlight what regions or areas or dimensions are making a loss. So I have a goldenish color for the positive bar and a reddish color for the negative bar. You have a nice percentage option here to change the size of the decomposition tree as a whole. I think the default size of 100% is just perfect, so I'm going to leave it as that. There are 3 specific settings as well. For example, you can control the density of the tree nodes. Let's say you want the tree nodes to be displayed less closely packed together. Choose the sparse density, and you can see that the nodes move further apart. Let's say you're planning to add many levels to the tree, then you should have the tree densely packed. So you can choose density equal to dense, and the tree nodes are packed closely together. We'll just stick with the default density. That's perfect for us. I think that tree displays just fine. And that's all the customization that I'm going to perform. I'll leave it to you to explore other customization options on your own. Now, let's say you'd like to collapse the entire tree. You can simply click on the root node and the entire tree will be collapsed. And then, of course, if you click on the root node again, the tree will be expanded once more. And then you can click on individual nodes to drill down as usual. In the next part of our demo, we'll see that the decomposition tree is not a static, isolated visual. It's a fully integrated and responsive element within an interactive dashboard. It's part of a larger dynamic data exploration experience, which means any filtering operation that you perform affects the decomposition tree as well. I'm going to add a clustered bar chart right next to our decomposition tree, and in this bar chart, I'm going to display the operating profit by retailer. Now we have two visuals in the same report. These visuals will interact with each other. So any selection you perform on one visual will affect the other. I have retailer information in the bar chart, and in my decomposition tree, I have region, sales method, and product. I'm going to select one of the retailers that I'm interested in, West Gear, which seems to have the highest profits. This selection that we've made in our bar chart is reflected in the decomposition tree as well. Observe the bar colors have changed. The darkest color indicates the proportion of sales that can be attributed across the tree to the retailer West Gear. The lighter golden color reflects the sales of the other retailers in each of the tree nodes. At a glance, just by looking at the tree, you can see that in the West region, in-store sales for West Gear tend to be very high. Online sales are much lower. I'll make a different selection. I deselect West Gear and select Foot Locker. In the West region, you can see that Foot Locker's sales tend to be higher online than in-store or in an outlet. This way, you can use filtering and the cross-filtering across visuals to better understand your data. Now I have the Kohl's retailer selected, and when I hover over the decomposition tree nodes, I get additional information in the tooltip. Total sales 899 million, sales that can be attributed to Kohl's, that's the highlighted bar, that's 102 million. Let's look at the West region. Total sales 269 million, sales attributed to Kohl's 62 million. The tooltip gives you information not only about the node as a whole, but about the specific filter that you've applied. Cross-filtering works the other way as well. So you can make a particular selection in the decomposition tree and your bar chart will be updated. Let's see how we can interpret this. In the West region, if you look at all outlet sales, West Gear tends to have the highest profits, followed by Kohl's, and Sports Direct seems to have the lowest profits as far as outlet sales in the West goes. Let's drill down further. I'm interested in men's street footwear. And here, if you hover over bar charts, you will get the total profits and what portion of the profit comes from men's street footwear in outlet sales in the West. It's pretty clear that you can get very, very specific with the filters that you apply in your report and that you use with the decomposition tree visual. Now, it's not just other visualizations. You can use the decomposition tree with slicers as well. I'm going to quickly add a button slicer here to my report, and I'm going to select the sales method as the buttons here. Now, as I select the individual buttons, you'll see that the decomposition tree updates to reflect my selection. I had the West region selected. I'm only interested in in-store sales. This is my view. Let's select online sales and my view changes. Select outlet sales and my view becomes different, and here I've drilled down further in my original tree. Make multiple selections and the decomposition tree visual will update accordingly.
In this demo, we are going to cover Power BI's Q&A tooling, which we can use in order to improve the natural language experience for our users. We will first load our data, then choose the Q&A visual. We'll ask and refine questions and note some cases where the Q&A visual falls short. We'll address those shortcomings in the next demo, not this one. Then we will convert our Q&A visual to a standard visual. And finally, we will integrate and refine multiple of these to create a report. So let's get started with the first step of our plan, which is to load data. Here we are in the familiar Power BI interface. We click on the Get Data button towards the top left of the screen, and from the menu which opens up, we click on Text/CSV. We are going to be making use of a Kaggle dataset, and you see that this Kaggle dataset is the AWS SaaS sales dataset. This is a single CSV file, and the URL from where we got this file is visible on screen as well. We hit open, and a few seconds later, we see that the connection has been established and we are able to preview the data. Here it is. You see that we have a row ID way over on the left, and then we have information about individual orders as well as customers and many other attributes. We take a few seconds to orient ourselves and then click on load. The data has been added to our workspace. There it is over on the top right, and we have all of the columns in there. Now we can move to the second step, which is to add the Q&A visual. Please look carefully. We are now going to carefully select the Q&A visual icon and click on it. It's in the third row from the bottom and it's the fourth icon from the right. What has been added to our workspace is known as a Q&A box, and we can see that it has a text input up top and then a few standard queries that are already built in based on the data that we have uploaded. We'll check out the prompt text box in a bit. Let's click on that show all suggestions link. You see that these suggestions have been generated automatically based on the data. Let's click on one of these. It says total sales, and this gives us the sum of sales across all rows in our dataset. Now it's a good idea to trust but verify when it comes to AI. So let's open up the visualizations dialog and click on the single card input. And there you can see that if we calculate the sum of sales, we get the same number. Well, one of them has been rounded to millions. The original Q&A visual has the raw number, but these look close enough. From this little check, the Q&A and the underlying AI seem to be working fine. So we can move on to the next stage of our plan, which is asking and refining our questions. To begin with, we can see that if we hover on the tooltips over on the right, first there's a tooltip telling us what this visual is displaying. In this case, it says this visual is showing total sale. And then there's another really important button there. You see there, the tooltip turn this Q&A result into a standard visual. We are going to work with this in order to convert our Q&A visual into a standard Power BI visual. To experiment, we just click on it and you see that we've gone to a regular card visual. The Q&A visual has disappeared. This is just a preview. We aren't quite ready to do this yet, so we hit Ctrl Z and here we are back in our Q&A visual. Let's try a query of our own. So we are not going with one of the suggested queries. Instead, in the prompt box, we've typed average profit for each region. Notice the underlining there. We'll have more to say on that in a bit. But now we just hit enter and you see that we do indeed have bars representing the profits for EMEA, America, and APAC. And hovering over them gives us the average profit. That's the numeric value. The query prompt text box is still available. So let's try show me the total sales by industry. And this also works correctly. You can see that on the y-axis, we have the different industries such as finance, energy, manufacturing, healthcare, tech, and more. Once again, let's trust but verify what we got using AI. So we open up all of the visualizations and we click on the visual for a stack bar chart. We drag and drop it, and then we choose the industry and we put that on the y-axis and we choose sales and place that on the x-axis. We now have our Q&A visual as well as a regular stack bar chart next to each other, and we can see by hovering over the bars that these numbers exactly match. The sum of sales and finance, for instance, is exactly the same in both visuals. Then let's delete this bar chart and try a different question. In the text prompt, we type what is the total profit, and we get a KPI back. This card tells us that the profit is $286,397.02, and we can verify this as well using a card visualization where we add in the profit and the numbers match. Let's ask a few more questions just to get the hang of how this visual works. In the text prompt, we now ask what are the total sales by customer. And down below, we have the individual customers. These are all large companies. On the y-axis, for instance, we see now on the top left, Johnson & Johnson. We know how this Q&A visualization is working. Let's now try and refine our questions. We'll get to that in the next demo. We are now going to work with Q&A tooling. This is a way to improve the natural language experience of our users, and we will begin as usual by loading data, showing the limitations of the basic Q&A tool without any tooling or customization, and then we will proceed to add field synonyms. This is one of the most basic and effective ways to improve the Q&A visual experience. Here we will add commonly used terms, and the Q&A engine will know to recognize those terms and map them to fields or tables in our data. Then we will test those synonyms and move on to some other features such as Teach Q&A, where we will teach Power BI to pick up new words as well as adjectives. We will learn how to add our suggested questions to those which are picked up by Power BI by default. And finally, we will briefly touch upon relationships. Some terms and phrases can't be defined with simple mappings to terms. And in such cases, we have got to specify the relationship between a subject and an object. Let's start as usual with our plan, where the first step is to load the data. Here we are back in Power BI desktop. We click on the Get Data button and then choose text/CSV. We are going to make use of the added as salesdata.csv. So we select that file and click Open. We quickly preview the data here. If we'd like to clean the data, we could also choose to do so, and we could even transform the data, but we'll just load it directly. So we have the preview and then the load and transform data buttons down below. We click on load. The wheels turn internally for a few seconds, and then over on the right, we see added as sales data. Now let's expand the visualizations card, and there let's click on the icon for the Q&A visual. We know our way around this visual to a certain extent at least. Let's start by clicking on show all suggestions. We'll be adding to this list of suggestions in this demo, and then let's quickly put this through its paces with a few simple queries. Let's type out average unit sold, and even though this isn't quite grammatically correct, you see that we do get a numeric answer down below, and this looks pretty sensible. Let's try another query, total price per unit by invoice date. So this is definitely a more complex query, and now we get a line chart. Now please pay close attention to the query prompt box. Notice that there is some blue underlining under price per unit as well as under invoice date. Notice that this is a blue solid line. This is Power BI telling us that it recognizes this word or phrase, and it has mapped this to some columns from our underlying data. The solid blue line tells us that Power BI is pretty sure that it's gotten this right. Let's try another query. You see that this time again we only have solid blue underlining, which means that Power BI is pretty sure. It has blue underlining, that's solid blue underlining, beneath total sales, then region, and bar chart. Again, Power BI is telling us it knows what we are asking it to do. We hit enter, and indeed we do get a bar chart which seems to have the correct values in there. Now let's move to the next step, where we will intentionally run up into the limits of Power BI's understanding. As we shall see, it's pretty easy to extend these limits, but first let's see where they are. The query that we now have typed out is average operating profit by sales method. The words profit and sales method have the solid blue underlining, which tells us that everything is fine as far as those terms are concerned, but something is off with the word operating. Notice that it has the bold red double underlining, and the word operating itself has been grayed out. This is Power BI telling us that it does not recognize the term at all. The word does not match any field, table, or measure in our model. So we are going to have to fix this. But what happens if we don't fix it and just try to go ahead by clicking on that bright blue run button? Well, you see that something has come back. And if you look closely at the text just below the query prompt box, we can see what has come back. Power BI has simply ignored the word operating. As it says there, just below the prompt text box to the left, it's showing results for average profit by sales method. This isn't really Power BI's fault. It doesn't know what the word operating means in this context. Let's try again with a different query which is even more out of reach. We've now tried total sales by brand as a bar chart. And in this case, it's really obvious that something has gone wrong. First up, we notice that the words by brand are grayed out. Brand has that double red underlining, which means that Power BI does not know how to interpret this term. Let's now proceed anyway, clicking on the blue button, and what we get back is obviously wrong. It has just given us one bar with the sum of total sales. We get a confirmation of that from the information icon towards the right. This visual is showing total sale as clustered bar chart. Let's remove this question and try another question, total entity sold by province. This time there are no red lines, there are just dotted blue lines for both entity and province. The dotted blue line is different from the solid blue line. A dotted blue line requires our attention. It's Power BI telling us that it's not completely sure about this part of our question. It might be guessing or interpreting the term in different ways, and we need to be sure that we are on the same page. We hit enter and we do get a bar chart. Looking at the interpretation, we are told this visual is showing region and total units sold. So province has been interpreted as a region. We probably want that to be state. Also, because it has no idea what to do with the word entity, it has simply given us the total units sold across a particular region. We'll fix that. For now, let's try a different question. Again, our phrasing is somewhat intentionally odd. Show overall sales and sale goal by dealer in a column chart. By now, our eyes are trained to look at the underlining, and we see that overall sales and sale goal and dealer all have that dotted blue underlining, which means that we've got to pay attention to how Power BI is interpreting these terms. We have solid blue underlining beneath column chart because there's no ambiguity there. We hit enter and we get a column chart back. It's hard to know what really this is telling us. Let's hover over the info icon. This visual is showing retailer that retailed Adidas sales data, total sale and total sales target as clustered column chart. Unlikely to ever win a Pulitzer Prize. In any event, let's move on from whining about these problems and see how we can fix them. Thankfully, Power BI has given us great support. We'll see how to add synonyms in the Q&A setup in the next demo. Let's continue working with the Q&A visual. We have a basic sense of how it works, but there is a lot more that we have to learn to customize. Specifically, so far, we were not telling Power BI what kind of visualization we want. We are going to change that now, and it's really simple to do so. All we have to do in the prompt is to add a clause or instructions such as a pie chart. So here you see that we've requested Power BI for total sales by product as a pie chart. The words as a pie chart are key. We hit enter and indeed we do have a nice pie chart. The different slices correspond to the different types of products. Let's try another example. We ask what is the total profit for the energy industry in EMEA region. Notice how we have placed energy within double quotes. This is going to filter the dataset down to the energy industry and the EMEA region and show the sum of profit. We hit enter and we find that the number is displayed down below, $22,503 and a few cents. What's more interesting than that number is the long form of our query, which is visible as a little link just below the text prompt box. That is the long form of the same query that we just typed in. This is an aid for us to understand how Power BI interpreted our natural language query. Here the interpretation was total profit with industry, energy, and region that AWS SaaS sales are in EMEA. Well, this is a rather long and ungainly way of phrasing it, but again, the answer is the same. Notice that there is no little link below the text prompt box anymore. Next, we ask for profit divided by sales by subregion as a bar chart. And you see that this has been nicely displayed as well. For instance, we have subregion IND, that's probably India, and we see there that profit divided by sales works out to 0.34. We hover over the little information icon on the top right and it says this visual is showing subregion and profit divided by sale as clustered bar chart. You can see how this Q&A visual helps us to construct very specific visualizations. Let's try a further refinement with filtering. We ask, what is the total sales by product in AMER region? That's America. And indeed, Power BI has broken down the sales by each product in the Americas. Again, we have the long form. This is just below the text prompt box. And we click on that and we see the long form of the query, which is product and total sale with region that AWS SaaS sales are in AMER. Now let's try and create the same visual manually. You'll see it's considerably more effort. So from the visualizations pane, we choose clustered bar chart And then you see that we've got to choose the correct columns. For instance, we've chosen product and we've dragged and dropped that into y-axis. Then we choose sales and place that on the x-axis. The visuals are exactly the same, but we had to actually know our way around Power BI a little more in this case. Note that at this point we have not filtered our clustered bar chart. So we expand the filters card and we drag and drop a region into the data fields. And here you see we have a basic filter. We now only choose AMER, and now the two visualizations match perfectly. We can verify this by hovering over the individual bars. Now let's delete the clustered bar chart, come back to our Q&A visual, and there try a more complex query. So here we are saying top 5 cities by sum of quantity in the EMEA region. We hit enter, and again this looks correct. We have London, Paris, Stockholm, Johannesburg, and Dublin. Again, we have the long form of the query. We click on that. It's just under the text prompt box. And here it is, top 5 city of AWS SaaS sales in EMEA by total quantity. So far so good. Now let's try an even more tricky query. What is the total profit from strategic products in APJ? This is APAC and Japan. This seems to work fine. You see that we have all of the products on the y-axis and the corresponding values for the profit or loss. When we hover over the info tooltip over on the top right, it says this visual is showing total profit and product where segment is strategic and region that AWS SaaS sales are in is APJ. Clearly, the long form of these queries is not really human readable at all. Now we are almost ready to convert our Q&A visual to a standard visual, but before that, let's purposely run up against the limits of this visual as it currently stands. Our query now reads, what is our total revenue? And what we have down below is actually the sum of our profit. The term revenue is usually used to refer to sales, not profit, but clearly this convention is not standard enough for Power BI to know of it. So we'll have to fix this, and we'll see how to do this using synonyms. Another little breadcrumb. So far, all of the underlining in our prompts had been blue. But now if you look closely, you'll see that for the first time, we have some red underlining in there. We'll see what that means in just a bit. This Q&A visual tool is a great one. Let's now see how we can actually close this and use this kind of tool in building a nice report. So let's start out with a simple query, total sales by country. This gives us a bar chart, but this isn't really what we had in mind. We need something a little more visually appealing. So instead, we type total sales by country map, and what we get is a map. This is a very much nicer looking visualization. We can zoom in and then we can hover over a particular tooltip. We also notice how the size of the bubbles correspond to the sum of the sales in that geography. All of this looks great. We are satisfied with it. And at this point, we can click on the button, turn this Q&A result into a standard visual. So we click on that button and you see that what we have now looks like just any other map visual. This now is permanently a map visual. So we expand the data visualizations and filters cards, and you see that under the visualizations card towards the bottom, we can configure this map just as we would any other map. There's no trace of the Q&A visual left. That's really all that there is to it. You see how simple Power BI has made the construction of these standard visuals. We'll now move to the last step, which is integrating and refining our report. Let's add a new page to our report. So we click on that little plus icon towards the bottom left. And in this new page, we again add a Q&A visual. Notice again how we select the particular icon corresponding to a text box from the list of visualizations. And here we have our familiar starting interface. We type out the query total sales by product as a tree map. This of course is very much in Power BI's wheelhouse. And so here we have a nice tree map. We click on the button to convert this to a standard visual. This is the same button which we had clicked a moment ago. And this tree map is now all that we have on page 2. Again, this is a permanent transformation. So you see that all of the ways to customize this are now for a tree map. Let's add a third page and add in here one more Q&A visual. Again, we click on the same icon from the list of visualizations over on the right. And our query now is total profit by industry as a pie chart. This is a perfectly serviceable pie chart. We are satisfied and immediately convert this to a standard visual. Then we add a fourth page. We again add a new Q&A visual. And this time our query reads sales and profit by segment as a clustered column chart. This also is satisfactory. We examine it and convert it to a standard visual. We now have a good basic understanding of the Q&A visual. We still have a few loose ends to tie up. Remember the red underlining. We'll see how to fix that using synonyms and phrasing in the next demo. In the previous demo, we had set up a simple Q&A visual, tried out a few queries. The simple ones worked, some of the more complex ones did not. So we ran into the limits of the capabilities of the Q&A widget. We now have to overcome those by using various customizations. We are going to see how we can add synonyms in the Q&A setup. There are two ways of doing this. One is by clicking on the modeling tab in the toolbar. It's way over on the top towards the left. There is an option called Q&A setup. However, we are not going to do that. We are just going to click on that little gear icon to the right of the text prompt box. There you see the tooltip teach Q&A to understand people better, review questions people have asked, and manage terms that you have added. Sounds good. We click, and here we are inside the Q&A setup pane. This is powerful functionality. So let's take a moment to orient ourselves. Over on the top left, we have various tabs. We are currently in the Getting Started tab. In the center of the screen, we have synonyms, which is a way to add terms that people might use as synonyms for the fields and tables in our data. Then there's a review questions. This is a way to review questions which people have asked and fix their misunderstandings. Scrolling a little further down, there's Teach Q&A. That's a way to understand questions and terms that people might use. And finally, there is Suggest Questions, where we help people to explore our data by adding to the suggested questions. We view some of those suggested questions. Those are the ones which appear in blue just below the text prompt box. We quickly cycle through the different options on the left, synonyms, relationships, and so on. We are going to explore these in detail. For now, let's click on synonyms, and then let's take in all that we see here. First, right up top, we have a bar, Improve Q&A with Synonyms from Copilot. This is in preview. Remember that content created by AI may not be accurate, so review it carefully, and then there are the terms. We click on Add Synonyms, and you see here a dialog which allows us to connect to a workspace which supports Copilot. Now, we've worked extensively with Copilot so far. However, we currently do not want to go down this rabbit hole. We'll focus on the basic working of the Q&A setup. And if you want to explore this, you'll need a Fabric workspace linked to a paid Fabric capacity resource, and you know how to set all of this up. Down below, we see added as sales data. Then we have tables and fields, that's the first column, approved synonyms, that's the second column, suggestions, that's the third column, and include in Q&A, that's a slider, that's the fourth column. So for instance, we have added our sales data, and you see from the little icon next to it that that's a table. There are already several approved synonyms. These were automatically generated by Power BI, but we could get rid of them if we don't like them. These pre-approved synonyms include Adidas sales data, Adidas sale data, Adidas sales data with underscores, just data, sales data, and more. There's also a little add button there, which we could click on. Next, look at the suggestions, and there's a really large number of them. In fact, there are 5 which aren't currently displayed. Let's click on that +5, and here we see all of them: sale fact, sale info, sale statistic, and more. There's a lot going on here. For instance, scrolling down, you see that for invoice date, we also have a date hierarchy. There aren't any synonyms there right now, but we do get the hint that we could work with the different components of the date using this particular section. In any case, let's move on and quickly explore all of the suggested synonyms. Once we've oriented ourselves with those, let's scroll back up to the top and accept the first 2 suggestions for the Adidas sale data, and we do that by clicking on the little plus icon. Notice that the synonym is approved. We are also informed that by default our synonyms are going to be shared with others that we are collaborating with. That can be turned off by disabling that green checkbox there. So be careful while adding synonyms. When you publish a report, your synonyms will be visible to everyone else. We then run through and rapidly accept a large number of suggestions, and here now is the important one which we really care about. The field is retailer, and we are going to click on the little plus icon next to the word dealer. Remember that we had that dotted blue line under the word dealer when we tried to run show overall sales and sale goal by dealer, and this selection is going to fix that. Next, we are going to add manually a number of synonyms. So we scroll down and under retailer, we click on the add button and we type out brand. We also add another synonym here, which is outlet. So brand and outlet are now going to be interpreted as retailer. Remember that we had problems with these as well. In similar fashion, we go down to units sold and we click on the add button and we type in the entity sold as well as items. Then in the field total sales, we add overall sale. Notice that we have a space between the words overall and sale. This is possible in synonyms. As an aside, note that as soon as we add a synonym, the list of suggested synonyms over on the right changes. You see there, it's gone from +4 to +5. Then we go to product and add their model as a synonym. And under region, we add sector as a synonym. And finally, we navigate to sales target. And then in quick succession, we add sales KPI and sale KPI. We now have added all of our synonyms. We can close out of this page. That takes us back to our workspace, where the next item on the agenda is to test our synonyms. It's time now for a rematch with some of the queries which had confused our Q&A widget. We start with total entity sold by province. You see this time that there is no dotted blue underlining and there is no red either. It only has solid blue lines, which tells us that these words have been recognized clearly by Power BI. We hit enter and the info icon over on the right confirms that this visual is showing region and total units sold. This is because of the synonyms that we added in a moment ago. Then let's try show overall sales and sale KPI by dealer in a column chart. Remember that dealer in particular had confused Power BI. That's no longer the case. Again, everything is in solid blue underlining. Let's use a different method to confirm that dealer is a synonym for retailer. We hover over the bars and there you see in the tooltip that this is clearly showing information for retailer and the sum of the sales target. The info icon confirms this visual is showing retailer, total sale, and total sales target as a clustered column chart. Now let's try a different question which has words that we have not yet added to our list of synonyms. We type top 10 locales by income in a tree map. The words income and tree map have the reassuring solid blue underlining, but locale has the dotted blue underlining. Power BI is not sure of its ground here. We hit enter and we see that Power BI has interpreted the word locale as a region. We know that from the tooltip inside the tree map. Anytime you see dotted blue underlining, it's worth taking a closer look. And we do indeed take a closer look at the icon. The info icon tells us this visual is showing top 10 region by total profit. What we actually wanted here was a mapping to state rather than to region, which means that we are going to have to fix this interpretation. To do this, we click on that little gear icon. Here we are back in the Q&A setup. We click now on synonyms in the getting started tab. This is just a shortcut to the synonyms tab. Notice it's highlighted on the top left. We scroll down to region and there we notice that under suggested synonyms, there is locale and the tooltip tells us the source for this is the thesaurus. Well, that's not what we want. So we delete that from the list of suggested synonyms. And then we scroll down to state, we click on add, and we explicitly type in the word locale. So locale is now going to be a synonym for state. Before going further, a little aside. Notice that the first synonym for state is state itself. And in fact, this is true for every field. The field name is listed as one of the approved synonyms by default. If you would like to obscure or mask the original column name of a given column in your dataset, maybe it has some problematic undertones, all you have to do is delete that particular field from your list of approved synonyms. In any case, we now have successfully added locale to state. We can close out of this Q&A setup and we see that the dotted blue underlining beneath the word locales has turned to solid blue. The tree map has also updated. We can hover over the different rectangles and see that it's showing state. And this is confirmed by the info icon over on the right. This visual is showing top 10 state. by total profit as tree map. We've successfully worked with and added synonyms to our Q&A visual. In this demo, we are going to work with scorecards, goals, and metrics. Goals are a great feature in Power BI which allow us to curate our progress against key business objectives, and we can also view progress towards goals in a single pane. In addition, we can also have sub-goals which roll up into a top-level goal. Our plan for this demo is as follows. We will begin by creating and publishing a simple report. Then we will navigate into what's known as Metrics Hub and create a new scorecard. Then we'll define a manual metric for total sales. When we say that it's manual, we mean that we will have hard-coded the values of the current total sales as well as the target. Then we will change this so that it becomes a connected metric, which means that the current value of total sales will be taken from a specific value in a Power BI report instead of being hard-coded. After that, we will then create sub-goals and modify the top level of parent goal so that the current value of the parent goal is the sum of the values of the individual child goals. And now, throughout all of this, we will have been working with only a subset of the data. At the very last step, we will change the underlying data which is used in the Power BI report which has been published, and we will make sure that when we republish our Power BI report from desktop, the values of all of the goals and metrics will refresh. We will also validate that all of these values as well as their statuses are correct, because along the way we will have defined various status rules. For example, if attainment is between only 20 and 30% of the target, we will classify a particular goal as being behind, and if it's even less than 20%, then we will have the goal showing as overdue. So all of this is going to be done automatically for us by Power BI. Let's get started with our plan, and the first step of which is to create and publish a simple report. Here we are in our Power BI workspace. As usual, we begin by loading data. We click on the Get Data button. From the dialog which opens up, we choose text/CSV, and we have a file, as usual, a Kaggle dataset file titled Adidas Sales. Notice that there is also a directory in there called full data. And if we click into that, you'll notice that we have another file also called Adidas Sales. Why is this? Well, we've actually created two versions of the dataset. One in the outer folder is a little smaller. It's missing the last 3 months of data. And then the one inside the inner folder has the full dataset. We are initially going to create a report with the sample data, that's the smaller file, and publish this from PBI desktop to the PBI service. Then we will create our scorecard on this reduced dataset. After setting up the scorecard, we will update the full data on the desktop and republish the report to the service. And we'll find that when we refresh our scorecard, the entire data will reflect. So let's get started. We've loaded in our reduced file. This is the smaller version of Adidas Sales. We quickly load the data and we find that 2814 rows have been loaded. Now let's throw together some simple charts. We begin by adding in a clustered bar chart, and then we will add the sales and the region. Next, let's add a pie chart of sales by sales method. Notice that the sales method is in-store, outlet, and online. This will become relevant when it's time to set up our goals. Then in quick succession, we add 3 cards and display total sales, total profit, and total units sold. Next, let's add another page, and on page 2, we add a tree map. This tree map is going to have profit by retailer. West Gear, Sports Direct, and Amazon are the 3 values of retailer. Now, we save the report and publish it to the Power BI service by clicking on the green button over on the top right. Then we click on Manage Access, which opens up a dialog. We choose More options from the bottom left of the dialog and hit Publish from the center left of the screen. The workspace that we publish to is our Looney Workspace Power BI. After publishing to Power BI, we switch over to the Power BI service. This is app.powerbi.com, and verify that the report is indeed available there along with the semantic model. Indeed it is. So inside our Looney Workspace Power BI, this is our Fabric workspace, we have 2 items called Adidas Sales Goal. One is a report, one is a semantic model. We first click on the sales goal. There are 2 pages and everything is exactly the same as it was on Power BI desktop. So you kick the tires here. Let's return to the workspace by clicking on the icon at the center left. and we move now to the second stage of our plan, which is navigating to the metrics hub. To do this, we click on those three horizontal dots towards the bottom left of the screen, and we click on the little trophy icon, and here we are in the metrics hub. This was a simple enough step, and this here is where we can manage and view all of our scorecards and metrics. Now we move to the next step of our plan, which is to create a new scorecard. This is easy enough to do. We click on that bright green plus new scorecard button, and a scorecard is a kind of container which holds all of our metrics, and it helps us to track them in one centralized location. Then we'll have to fix this name in a couple of places. First, on the very top left is the name as it appears in the Fabric workspace. So that's the item name which we've made Adidas Sales Scorecard. And then there's the logical name for what we are looking at right here, and we change that to be the same. Then there's room at the center of the screen to define a goal, and we are going to spend a lot of time doing that. Before that, let's quickly take a look at the settings. So we click on the settings icon, and you see that we have three tabs: details, permissions, and statuses. The most interesting of these three is statuses, because in there we see different values which we are going to make use of while defining our goals: overdue, behind, at risk, on track, not started, and completed. We also have the corresponding color codings. Notice also that these are arranged in a specific order, and we can change that order by clicking on the up and down arrows. Overdue is the most concerning state and completed is the best state. These default statuses are perfectly fine. We hit cancel, move to the next stage of our plan, which is to add a manual metric. Please note that the next step, not this step, is to add a connected or a data-driven metric. The difference, of course, is that the manual metric is static. Manual metrics are ideal for KPIs where we want to track progress against a set target, and we do not have any automated data source which is going to update this metric value. Let's go back to the metrics hub. In this context, a metric is a goal, and we can always add a new goal by clicking on that new button over on the top right and choosing new goal from the sub menu. This time around, we don't need to do this because there is already a placeholder at the center of the screen. So let's fill that in first. Let's define the metric name, that's total sales. Then we define the owner. The owner could be an individual or a distribution group within our organization's Microsoft Entra ID. Then we set the current value manually. Thankfully, there is an easy way there to format this, and you see that this is 334 million, and we display this to be in currency format. So here, the current value is 334 million, and the current value of the target is 450 million. Notice that we have the little drop downs there, which show manual next to current value as well as final target. Then we've got to set the status, and from that drop down of different statuses, we change this to be on track. There are also calendar widgets for the start date and the due date, and we edit the due date to be the 31st of December. At this point, we can click Save, and then we have this goal in our metrics hub. We can view the details of this goal by clicking on it and choosing those three vertical dots. In the context-sensitive menu which opens up, we choose See Details. But before we click on that, also note what the other options there are. We can add a new sub-goal, we can follow a goal, or we can delete this goal. Now we click on See Details, and a new dialog opens up on the right with tabs Details, History, Status Rules, and Time Period. At the center of the screen, we see the current value, and when we hover over it, we can see that the value there is 334 million. Let's quickly cycle through some of the other tabs, including the history, the status rules, and the time period. The time period is interesting because here you can see that we have different options for how the goal ought to be reported. The tracking preferences are cycle over cycle, cycle to date, and no cycle. Everything seems to be in order here, so let's move to the next stage of our plan, which is where we make our metric connected, that is, driven by data. We'll get to that in the next demo. Let's move now to the Teach Q&A tool. This is where we train the model to accept new words and adjectives. So here we are back in our workspace, and let's try a query which again is going to confuse Power BI. What was the profit for Western retailers? Right away, we see the dreaded red underlining under the word Western, because here we want Western to be an adjective for region equals West. This is of course not standard usage. The Power BI is totally right and justified to have that red underlining. It does return something. And when we look at what's returned, we can see that we have the profit by retailer. The word Western has simply been ignored. That's confirmed by hovering over the info tooltip over on the top right. So to fix this, we click on the gear icon. This takes us back into the Q&A setup panel. And there now we click on the Teach Q&A tab. Remember that we are still inside Getting Started, but this is just a shortcut to the Teach Q&A tab, which is highlighted on the left. Now notice that up top we have a text box which contains the query which got us here in the first place. What was the profit for Western retailers? Notice how profit and retailers are highlighted or underlined in green, but Western has that red highlighting as well as the underlining. We've got to disambiguate this term. How are we going to do this? Well, down below there's a way to define terms that Q&A didn't understand. There's a blank there and we are asked to describe a subset of retailers. This is where Power BI's understanding of the data really comes in handy. We just type the word West. Power BI then looks through all of the data in the different fields and it gives us any field values from any field which contain West. So we have West, the first option, which comes from region. The second is West Gear, which is from the field retailer. And the third is West Virginia from the field state. We go with the first direct hit, and as soon as we do this, the preview over on the right changes and we see the profit for all retailers where region equals West, and that works out to about 90 million. We click save, and now when we close out of this tab and go back to our workspace, we have the correct precise profit for all retailers where region equals West. As always, let's trust but verify. So let's recreate this. We expand the visualizations card. We choose a card widget. And then from the data, we select profit. And then in our card widget, we drag and drop region into the filter and we select West. This is clearly correct. Western was an adjective. Let's now see how to add a noun. Now we are going to ask, what was the profit by establishment? Again, we have the red underlining beneath the word establishment because this is not a recognized term. Power BI just ignores it and returns the total profit, and we can confirm that from the info icon. Again, to fix it, we click on the little gear icon. Here we are back in the Q&A setup. We click now on Teach Q&A, and there you see what was the profit by establishment populated in that prompt box up top. Establishment is highlighted in red. Again, we go down to the definition input down below. We start typing into that little input and we have two choices, retailer and retailer ID. Both of these are fields from our data. Let's pick the first one, which is retailer. As soon as we do this, we see that over on the right, we get a preview of our result. And we can close out of this. Here we are back in our workspace and establishment has solid blue underlining and the result is correct. The info icon tells us this visual is showing retailer and profit. Now let's try yet another question which Power BI cannot understand. What was the gross earnings? Earnings has the double underlining, and in fact, this confused Power BI so much that no result was returned at all. The message tells us, we did not understand your question. Try fixing double underlined terms or ask it another way. We click on the gear icon, we go back into the Teach Q&A section of the Q&A setup. Here we are, what was the gross earnings? Note now that gross and earnings both have some underlining. So we first select the word earnings and then we define it down below. Earnings refers to sale. Power BI immediately adds another input for gross total sales. So you see, it now knows that earnings refers to sale, which in turn refers to total sales. There's nothing that we want to add here. This is sufficient because in this context, the word gross can simply be ignored. So we close out of the dialog. Here we are back in the workspace. We notice that gross still has the red underlining and it's grayed out, which means that it's going to be ignored. Earnings, on the other hand, now has the reassuring solid blue underlining. There is a result down below, and we can confirm that this visual is showing total sale. That's in the info tooltip. Now, in effect, the word gross is simply going to be ignored in any query where it appears. So here we've typed out total units sold and gross earnings by sales method as card. The word gross is grayed out and has the red underlining, and in the results, it's simply ignored. You can confirm this by looking at the results and then hovering over the info icon. The visual is showing sales method, total units sold, and total sale as card. So again, this is how you get a term to simply be ignored. One more example showing how the word gross is ignored. The query now is top 3 establishments by gross earnings as donut chart. Everything has been correctly interpreted other than the word gross, which is ignored. The info icon confirms this visual is showing top 3 retailer by total sale as donut chart. Let's move to the next phase, which is adding to the suggested questions which appear in the Q&A tool. So we click again on the gear icon, and this takes us into the Q&A setup, and we choose the suggest questions. That's the option towards the center left. This is a pretty simple feature. We simply add questions which we think users might have. So these include total units by city. We hit add and we get a preview of the results down below on the right. In similar fashion, we add average profit by sales method, total profit by region, and total sales by retailer. We click save and then exit out of the Q&A setup and go back to our Power BI workspace. Now we would like to clear the contents of this Q&A dialog, so we click on that little text bubble icon just to the left of the prompt text box, and now we've cleared the dialog. Here are the suggested questions, and indeed these are the same questions that we just manually added. The first is total sales by retailer, then there's total profit by region, average profit by sales method, and total units sold by city. Notice how it's taken our explicitly added questions and shown them first. We click on total sales by retailer, and indeed we do have the answer appear as expected. Now for the last and maybe most interesting of the steps in this demo, which has to do with relationships. Here we are going to define linguistic relationships that connect different fields. We click on the gear icon. Here we are in the Q&A setup. We click on relationships towards the top center left, and we find to our surprise that we already have defined one relationship. You remember when we specified the term Western refers to all retailers where region is equal to West? Well, that shows up here. So the relationship reads some retailers are Western retailers. The condition is if region is West. And then we have the relationship type, and you see there that there are adjective, verb, preposition, and dynamic adjective relationship types. First up, let's just click on this existing relationship. And when we do this, we find that a fairly complicated dialog opens up. We have a drop-down for relationship type, which is currently set to adjective. And then we've got an example. Some books are used books. Then we also have the form of the relationship. Some retailers are Western. So the subject is retailers and the adjective or the antonym is Western. Then we have the condition where we define the field, the operator, and the value. And by using these, we see that the condition is region is West. There's also a drop-down for relationship table, which of course simply points to our added as sales data. Let's also explore that relationship type drop-down. You see that we have verb, adjective, and noun. And down below, we have preposition, name/identifier, and attribute/association. And in each case, we have helpful examples. For instance, under adjective, we have 3 different types of adjective relationships: adjective, adjective with measurement, and adjectives from data. This is the only relationship which we added, albeit indirectly. However, there are various implicit relationships already in there. For example, added as sales data are invoiced on invoice dates. Added as sales data are in regions, and they are in states and cities. And in this way, you can see just how Power BI has used AI to make sense of this data. Let's now click on that bright plus new relationship button on the top right. We are going to use this to allow operating in, existing in, and selling in to be used in our queries. From the relationship type, we choose preposition. Then from the subject, we choose the field retailer. Notice how all of the other fields are listed here as well. Each one has a little checkbox next to the name. And then in the input for preposition, we type in operating in, and then a comma, then selling in. So by the end of this, we've added 2 prepositions. Then we've got to add an object. So we click on that little plus add button, and now we choose state. So taken all together, this means that we've defined a relationship where retailers are operating in states. We click on that green approve button, and that takes us one level out. And there, right up top, we see the relationship that we just defined. Retailers are operating in states. Now that we've saved all of these changes, let's go back to our Power BI workspace and try and run a few queries. Make sure that this relationship is indeed being picked up. Here is the query, you see, which retailers are operating in New York? Notice first off that operating in has the solid blue underlining, which means that Power BI has understood exactly what we mean. We get back a sensible list of retailers, including Foot Locker, Kohl's, and others, and we verify this by looking at the info icon. We've been successful in defining this relationship, and with that, we've come to the end of our exploration of the use of synonyms and various other constructs in the Q&A customization. Let's reorient ourselves with where we were at the end of the last demo. There, we had set up our total sales metric, and we had added two sub-goals corresponding to two different channels, in-store sales and outlet sales. There is still a third channel which is not in here, and that is online sales. For that, we need to configure a third sub-goal before we roll them all up. So the next thing that we've got to do is to add a sub-goal for online sales. For this, we'll have to modify our parent total sales goal. So we click on the three vertical dots, we choose new sub goal. So we then name this online sales and set up the current value to connect to data. Then added a sales goal. We navigate to page 1. There we have our pie chart. The slice that we are interested in now is the online sales pie chart. And when we link it up, we see that the value does indeed correctly reflect. It stands at 58.7 million, which rounds up to 59 million. Then let's enter a manual final target of 150 million. We manually format this, and then you see that under status, we currently have not yet started. We can configure the rules from right here. And we click on that little link which says or setup rules. This opens up a new dialog where we can configure our rules. So we click on plus new rule, and then we go ahead and configure a number of rules as before. The first rule is that if the value is greater than or equal to 100% of the target, the status should be changed to completed. Remember now that the rules are evaluated in order, and that's why we can configure our second rule. If the value is greater than or equal to 50% of the target, change status to on track. Again, this rule as it stands only makes sense because we have another rule to deal with the case where we've gone above 100% of target. Then we set up yet another rule. If the value is greater than or equal to 30% of the target, then the status is at risk. A fourth rule where if the value is greater than or equal to 20% of the target, the status is behind, and otherwise the status is overdue. We hit save, and this takes us back out into the view where we are configuring the sub goal online sales. We already have the final target, which is 150 million, and then we configure the end date or the completion date to be the 31st of December. At this point, when we hit save, we see that the online sales target is at risk. Now you see that we've got our parent metric total sales. The target on that is 450 million, and then we have three sub metrics corresponding to in-store, outlet, and online sales, each with targets of 150 million. Now clearly the way this ought to work is that the total progress on total sales should be the sum of the progress made on each of the individual types of sales. But that's not how we've currently set up the goals. We've got to change that, and that's something we'll do in the next step where we roll up our goals such that total sales is computed as the sum of in-store, outlet, and online sales. So we click on the pencil icon next to total sales, and this allows us to edit the goal. We click on the setup dropdown for current value. You see that it's currently got that little chain icon, which means that it's connected to data. In the dropdown which opens up, however, we change that choice. So we've now chosen use sub goals, and in the sub menu which opens up, we have sum. This means that the current value of total sales is going to be the sum of the values of the sub goals, that is the sum of the in-store sales, outlet sales, and online sales. Now when we hit save, we are given a warning dialog. We are asked, are you sure? We are told updates made to a current value connection by someone who is not the original owner will delete all existing values. It also tells us that this action cannot be undone. The first part of the warning is because I'm currently signed in with a different login than the owner of the goal. In any case, we do go ahead And we see that nothing outward really changes because the total value remains 266 million. Previously, we were taking this from the Power BI report. Now, however, this is being computed as the sum of the three subgoals. Let's wire up yet another metric, which will also have similar rollups, but this time for the profit. So we click on that plus new button over on the top right, we choose new goal, and we name this total profit. We then set up the current value initially to connect to data. So we navigate to our Adidas sales goal report. Within that, we have a card on page 1, which already has the value of the total profit pre-computed. There it is, 97 million. So we click on it. This is the sum of profit. We connect this up to our goal. And you can see that the current value is now nicely formatted as $97 million. We enter a final target of 300 million manually. Next, it's time to set up the rule. So we click on that little link button under status, and then we proceed to add various rules as before. Here is the first rule. If value is greater than or equal to 100% of target, change status to completed. Then the second rule, if the value is greater than or equal to 50% of target, change the status to on track. Then our third rule, if the value is greater than or equal to 30% of target, change status to at risk. Remember again that these rules only make sense when we view them all together. Standalone, this rule would not make sense. Likewise, if the value is greater than or equal to 20%, then we change the status to behind. Otherwise, we set the status as overdue. Once we are comfortable with all of this, we hit save. That only does it for the status rules. We have a target for the profit, which we set to 300 million, that's manual, and then the due date as usual is the 31st of December. We hit save, and now we have our total profit goal. This one also shows up with status at risk. Remember, this is still a connected goal. We take the value directly from a Power BI report. We do not actually have any subgoals. Next demo, we will change that so that the total profit itself is computed as the sum of the profit for the different retailers in our dataset. We had ended the previous demo by creating a new parent level metric called total profit and connecting that up to a card in our Power BI report. Now, another way of getting at this total profit is computing it as the sum of the profit of all of the retailers in our dataset. Right now, this is a value which is taken directly from the Power BI report. Let's change that. So let's add subgoals corresponding to different retailers. The first of these we call West Gear Profit, and we connect this to data in our Adidas sales goal report, where on the second page we have a tree map of retailers and their profit. So we link this to the rectangle for retailer West Gear. So this has a current value of about 48 million. And then we manually specify a final target of 100 million. Then we could choose to set up rules. Now we know how this is done. We click on that setup rules and then add all of the rules in here. I think we have this down pretty pat. So let's just go back and set the status manually. Then we set the due date to be the 31st of December and hit save. That does it for the first of our three individual sub goals under total profit. We add a second one again by clicking on the three vertical dots, then choosing new sub goal. We call this Sports Direct Profit. We hit setup in the current value. We choose connect to data. We link it up to our Adidas sales goal Power BI report. On that page 2, we've got the tree map with the different retailers, and we click on the one corresponding to Sports Direct. This one has profit of about $35.9 million, which is what shows up here. We specify the final target again to be $100 million, and then we change the due date to be the 31st of December and hit save. At this point, we realize that we neglected to click on the status. So we click on that little pencil icon and go in there and set the status manually to be at risk and hit save again. Now we really are done with the Sports Direct Profit goal. Then we click on the three vertical dots under our total profit parent goal, add a new sub goal corresponding to the Amazon profits. Under current value setup, we again connect to data. We again pick the Adidas sales goal Power BI report, and we again navigate to page 2. This time in the tree map, we click on the rectangle for Amazon. The current value is picked up as 13 million. We specify a final target of $100 million formatted appropriately. This seems way behind target, so we set the status to overdue and as usual, the due date to the 31st of December. We hit save, and now we have wired up our 3 sub-goals under total profit. All that's left for us to do here is to change the total profit parent goal so that it picks up the sum of the 3 sub-goals. So we click on the little pen icon to edit the total profit goal. And in the dialog which opens up, we click on the little link icon next to current value. This link icon means that it's currently connected to data. Instead, we choose use sub-goals with the aggregation function sum. This is going to take the current value of total profit as the sum of the current values of the sub-goals Westgear profit, Sports Direct profit, and Amazon profit. We hit save. We are then presented with a warning sign. We've seen this before. We are sure that we wish to delete the link to the Power BI report. So we click on delete. Now nothing outwardly changes because even though the way we are calculating the total profit current value has changed, the actual value remains the same. To verify that everything is working, we now move to the last step, which is to refresh and validate the data. The way we are going to do this is we are going to change the file from which our Power BI report takes its data. Remember that we had 2 files, one with all of the data and the other missing the last 3 months. Our current Power BI report takes the values which do not include the last 3 months of data. So all of these numbers that we see on screen now, such as 266 million in total sales, do not include the last 3 months. Now let's navigate to our desktop. Let's make sure we understand this file setup correctly. First, please look at the address bar. You see that we are in the datasets folder. At the center of the screen, you see that within this datasets folder, we have the Adidas sales file and we have a subfolder called full data. This Adidas sales file, which you see right here, is of size 296 kilobytes. It is this file which we see here which is being picked up and used in the Power BI report. In a minute, we are going to override this file and the Power BI report will refresh automatically. Okay, now let's click on the full data folder. Inside that, we'll see that there is another file also called Adidas sales. This one is a lot larger. It's 375 KB. And we move that into the datasets folder, which is where we have sourced the report from. We have another file there also called Adidas sales. Windows asks us to confirm that we wish to replace the file in the destination. The answer is yes, so we select that. And now we will find that our Power BI report has updated and picked up the new values from this full data. So far, we are still only looking at Power BI desktop. Here we are looking at our Adidas sales goal report. And here you see in a minute, the value changes from 266 to 334 million. Power BI desktop has picked up the changes. However, for the service to also pick up the changes, we will need to republish this report. Let's first confirm that we need to republish. So we head back to the Power BI service and we hit refresh in our Fabric workspace and nothing changes. So we then come back to Power BI desktop and we click on the publish button towards the top center right. All of the usual steps play out. We are first asked to confirm that we wish to save our changes. Then we are asked for the destination. We choose our Looney Workspace Power BI and hit select. And that in turn gives us yet another warning. You already have a semantic model named Adidas Sales Goal in Power BI. Are you okay to overwrite it? Also notice we are told replacing this dataset may impact one report and there's a little view impact link button at the bottom left. However, we won't click on that. We are fine to overwrite the existing semantic model. So we hit replace and a moment later we get a message of success. Now we switch over to Power BI, that's the service, and we hit the refresh button in the top right and the values all update. For example, total sales has become 334 million. And we also can verify that every one of the individual statuses are computed on the basis of the current value versus the target. And with that, we have come to the end of this demo in which we successfully created a scorecard and worked with metrics, both manual as well as connected metrics, and we also set up roll-up sub-goals. Let's pick up right from where we left off at the end of the last demo. We had gone to the metrics hub, created a new scorecard and added in a manual metric where the current value as well as the target value were both hard-coded. Now we are going to wire it up so that it takes its value from a particular value in a Power BI report visualization. To see how this is done, let's close out of this details tab and then edit our goal. So we click on the little pencil icon And then where we have the current value drop down, we change it so that instead of being manual, it's connected to the Adidas sales goal report. So you see manual goal is currently selected. Another option is to use sub goals. So we can have the sum, average, max or min of sub goals, and we'll come back to that. But right now it's a third option that we are interested in. We click on connect to data. In effect, what we are saying is that the current value should not be hard-coded, rather it should come from some Power BI report. And here we've chosen the Adidas sales goal Power BI report, and then we click on next. So a preview of this report opens up. You see page 1 and page 2, and we've got to navigate to the visual which contains the data that we wish to track. On page 1, you see that we have a card there showing the sum of sales. And you see that is about $265.7 million. This is the current value that we wish to set. So we choose this by clicking on that green connect button. And now our goal in Metrics Hub is going to take its current value from the total value of sales so far. You see at this point, the current value has updated. It shows 266 million. And also a little link icon has appeared next to the current value. Previously, it said manual, but now there's the link icon. If we click on that link, you see that we have the same three options as before: manual goal, use subgoals, and connect to data. But now it's connect to data, which has the checkbox next to it. Note that we have a similar drop-down next to final target, but that has manual selected. This is not something that we wish to update dynamically, so we leave it as is. The status is also on track. We hit save, and in this way, we've now set up a connected metric. The benefit of a connected metric is that it's always up to date because it's linked directly to a Power BI report or dataset. Next, let's see how we can organize our metrics and group them such that we have metrics and then sub-metrics. So we are going to have a parent goal, which will be total sales, and this will be the sum of in-store sales, outlet sales, and online sales. Let's begin by clicking on the three vertical dots within our existing total sales metric. From that, let's choose the new sub-goal item. We are asked for a sub-goal name. Let's call this in-store sales. And then again, you see that for the current value, we have a drop-down with manual goal, use sub-goals, or connect to data. We would like this to be connected to data from the get-go, so we choose that option. And then we are again prompted for the report or app from where this data comes. Again, we choose Adidas sales goal, click on next, and then within this Adidas sales goal report, we navigate to the specific visualization. This is the sales by method pie chart. And you see that within that pie chart, we have different slices. The slice that we are currently interested in is the in-store slice. So we click on that slice in the pie chart. Look at how easy this is to wire up. The measure is sum of sales, and you see the existing value is about 128.9 million. So we click on that and then click the green connect button at the bottom left. That's all there is to it. We've taken the current value of in-store sales from that control. For the final target, we paste in the number 150 million, and as usual, Power BI formats it nicely to be currency and in millions rather than dollars. Of course, this goal has been hard-coded in, and that's why the dropdown shows manual goal has been selected. Then we also will set the status. This one can be classified as on track. We change the due date to again be the 31st of December. Once that's done, we click on save, and now you see that we have our first sub-goal wired up. Let's add yet another sub-goal corresponding to the second type of sales. This is going to be outlet sales. So we again click on the three vertical dots next to the parent goal, and we choose new sub-goal, and then we call this sub-goal outlet sales. This also is going to be a connected goal. So under current value setup, we click on the drop-down and choose connect to data. Then we wire this up to the Adidas sales goal dashboard. A preview opens up when we click on next. This is the same preview which we've encountered a few times. And we navigate back to page 1 and click on the correct slice of our pie chart. That's the slice where sales method is outlet. So we click on that and then click again on the connect button at the bottom left. We've wired up our sub-goal outlet sales to take its current value from that particular control. You see its current value is 78 million, and we set a target value to be 150 million and format it nicely as before. 78 million is a long ways off from 150 million, so the status we choose this time is at risk, and the due date is the same, the 31st of December of 2025. Let's take stock of where we stand. We have a parent goal, total sales, which has a target of 450 million, and then we've set up two sub goals corresponding to in-store sales and outlet sales, which have targets of 150 million each. We've yet to add a third sub goal in there for online sales, which will also have a target of 150 million. So the three sub goals with targets of 150 million give us the parent goal with the target of 450 million. Before we add the third sub goal, however, let's see how we can set up some automated status rules for our goals. Let's do this at the parent goal level first. So we click on the three vertical dots, then we click on See Details, and in the dialog which opens up, we click on the tab Status Rules. Then we click on the button plus New Rule, and then you see that we have if followed by a field dropdown which currently has value. Because it's value, we choose a relational operator like greater than and 100% of target. If we change the field to be date, then the relational operator changes so that it's now is on or after. Let's go back to the value and we configure a simple rule such that if the value is greater than or equal to 100% of the target, we change the status to completed. Notice the little otherwise clause there. Otherwise, change the status to on track. So this is how we've configured our automated status rules for now, and we hit save. Remember, this is at the parent goal level. Now you see that the status shows as on track because we've obviously not exceeded 100%. Now at this point, we might decide that 266 out of 450 million doesn't seem very much on track. So we've got to change the rule. We click on the three vertical dots and then See Details, and then we click on Status Rules, and we change the otherwise clause to read at risk. So here we only have two possible statuses, completed and at risk. We hit save and we see instantaneously now that the status of our total sales metric shows at risk rather than on track. Maybe this is a little too binary for us. We want to add multiple layers of logic. No worries, we can do that. We again navigate into the status rules and add a bunch of additional rules. It's important here to keep in mind that the rules are evaluated in order from top to bottom. So our completed rule is going to be evaluated first. We've now clicked on plus new rule and we've added a rule where if the value is greater than or equal to 50% of the target, we change the status to on track. We have that rule in there. Let's add yet another rule. This time we are going to make it a compound rule. So you see that we've clicked on the plus add condition button, and we use that to set up a rule where if the value is less than 50% of the target and the value is greater than 30% of the target, we change the status to at risk. Again, please note the use of and. Then let's add another rule, and this time this rule only makes sense when we understand that the rules are evaluated in order. You see here that we have if value is greater than or equal to 20% of the target, we change the status to behind. In isolation, this rule makes no sense. If the status is more than 20% of the target, why should we be behind? Well, the answer is because we will only hit this particular rule after none of the other rules above this have been hit. And those all deal with the cases where we accomplish more than 30% of the target. So this rule is implicitly telling us if this condition is greater than or equal to 20% but less than or equal to 30%, then set the status to behind. And finally, we also modify the otherwise clause. If none of these conditions are met, we change the status to overdue. Now you could argue that this doesn't really make sense because we haven't hit the deadline yet in terms of date. But another way of looking at this is if you are running at less than 20% of the target, then you are overdue. We hit the save button and we now click on the details tab. You see there that the status shows as on track. So it has picked up the value from our new set of rules. We close this and return to metrics hub. Remember that we still have to set up the third leg of our total sales goal, and that is for online sales. We'll get to that in the next demo.
In this demo, we'll do something a little different and quite cool. We'll see how real-time streaming reports can be built in Power BI. But first, what is real-time streaming? This refers to the continuous processing and delivery of data almost immediately after the data is created. Batch processing involves data that is collected over time and then processed in batches or chunks. Streaming data, on the other hand, flows constantly and is analyzed and visualized on the fly. This means you can get immediate insights and actions based on the most current up to date information. Examples of real time streaming data include IoT sensor information, where data is streamed from sensors across the world, or the financial markets, such as stock price ticker information. In this demo, we'll set up and configure real time streaming reports in Power BI to visualize data that updates almost instantaneously as it's generated from sources like IoT sensors and social media feeds. I should give you a heads up that we'll be working with a number of new technologies, both in the Azure portal and in our Fabric account. I'll walk you through the steps in the demo right now, but there are many terms in these steps which I'll explain as and when we actually perform that step. The first thing we'll do is create an Azure Event Hub namespace and an Azure Event Hub. Azure Event Hubs are what are used in Microsoft Azure to ingest massive streams of event data. This is in the Azure portal. In our Fabric account, we'll create a Fabric Event House. The Fabric Event House is the specialized database within Microsoft Fabric where streaming data can be stored and analyzed in real time. Our Power BI report will be powered by data streamed into this event house. The Azure Event Hub is where our streaming data will be ingested. The Fabric Event House is where the streaming data needs to be stored to set up our real-time streaming report. How do we get the data from Azure Event Hub to the Fabric Event House? Using an event stream. And that's the next step that we'll perform. We'll create an event stream and connect that to the event house. To verify that our real-time data flows from end to end, we'll send a sample event from Azure Event Hub and ensure that this event is available in the Fabric Event House. This will allow us to have confidence that the streaming pipeline is set up correctly. To confirm that everything indeed does work correctly, we'll send a second event and observe the updates on the Fabric Event House end. Once we are confident, we can build a real-time streaming report. This is different from the Power BI reports that we've seen so far, and this is actually a Fabric asset. The real-time streaming report will connect to the KQL database that we have in the event house to visualize the data. I know I used a new term here, KQL. This stands for Custo Query Language. This is a query language that can be used to explore and analyze live data, and it has its own specialized database. And once we set up our real-time streaming report, we'll send a whole stream of events from the Azure Event Hub. This will be a sample stream, and we'll see how the report updates in real time. Let's start with the very first step here, where we create an Azure Event Hub namespace, and within that namespace, we create an Event Hub. And as we perform these operations, I'll explain these terms in more detail. Now, this particular operation we have to perform within the Azure portal. So this is not within Microsoft Fabric. The Event Hub namespace and the Event Hub is an Azure portal feature. We'll create this Event Hub within the resource group that we set up earlier, Looney Power BI Fabric RG. Click on the Create link right here within the resource group and search for Event Hub here in the Azure Marketplace. You'll get a number of results. The feature that you're looking for is here. This is the second result. Click through to Event Hubs and we'll follow the dialog to create one. Azure Event Hub can be thought of as a pipe or a stream that ingests and stores your real-time streaming event data. Let's say you have an IoT sensor that sends streaming data. It can send that data to an Azure Event Hub. This is the actual destination that your applications, your real-time sensors send data to. The main job of an Event Hub is to handle a massive continuous flow of data from many sources, whether sensors or apps, and get them into your cloud environment reliably and in order. When you click on Create to create an Event Hub, you'll first be asked to create an event namespace. If you have an existing namespace, you can of course pick one of those. You of course have the resource group within which the Event Hub will be provisioned, and then you specify the name of the namespace. An Azure Event Hub's namespace is just the management container that groups one or more event hubs. It's the level where you configure security rules, network access, and capacity for the event hubs that live within the namespace. You can think of the namespace as maybe the cluster that provides the overall service and scope for your streaming data. My namespace is called Looney Event Hub namespace, and I'm going to provision the event hub in a particular region. Let's say all my sensor data is in US East, I'll place it in US East. If my sensors are in Central India, I'll place the event hub in Central India. I've chosen Central India here because my Fabric workspace is in Central India. I don't want my data to be transferred across regions. Remember, events ingested by the event hub will be sent to our Fabric event house. Next, you choose the pricing tier for your event hub. Event hubs offer several pricing tiers. You can see there are a total of 4. And these are designed for different scales and feature requirements. All hubs within this namespace will use the same pricing tier. I'm going to choose the basic pricing tier, which is best for development, testing, and low volume event streams. That's more than sufficient for the purposes of our demo. And that's it. These are the only bits of information you need to create the namespace. Click on Review and Create. Azure will perform some basic validation and you can review the namespace that you have set up. One detail to note here, that the throughput units for this namespace is set to 1. This is because of the basic tier that we've chosen. A throughput unit is the unit of capacity that we purchase for an Azure Event Hub's namespace. It gives you a specific bundled amount of power shared by all event hubs within that namespace. And one throughput unit has a certain limit for ingress, that is receiving data, egress for reading data, and storage. Our final review looks good here. Let's go ahead and create the namespace. And it will be created within a few moments. Once our namespace has been created, the next step, of course, is to provision an event hub within this namespace. Click on Entities off to the left, and under Entities, you'll find an entry for Event Hubs. Click through, and here you'll be able to view all of the event hubs in this namespace. And of course, there are no event hubs yet. Let's go ahead and set one up. Remember, the event hub is what actually ingests the streaming data. The namespace is just the container. Give the event hub a meaningful name. I've just called it Looney Event Hub. And here you can configure the partitions in your event hub. A partition can be thought of as an ordered lane within an event hub that holds a subset of the stream of events that are ingested. Azure guarantees that all events sent with the same partition key are processed in order. Partitions are what allow event hubs to scale to ingest massive amounts of data, millions of records. For our demo, a partition count of 1 is more than sufficient. The cleanup policy for the event hub means messages will be deleted after the retention period, and the retention period is 1 hour by default. So messages will remain in the event hub only for 1 hour. You have to either process them within that period or they'll be deleted. There are other features to event hubs. We won't worry about those. Let's just review and create the event hub within our namespace. And in a few moments, the event hub should be created as well. At this point, we've completed our setup at the Azure portal end. Streaming data sent to this event hub will be the source. And this now needs to be ingested into Fabric. So we have to do a bunch of setup at the Fabric end. In order for the components in Microsoft Fabric to be able to access the event data from Azure Event Hub, we need to copy over a shared access key. Head over to the main Event Hub namespace by clicking on that link there. And on the left under Settings, you'll find an entry for Shared Access Policies. This key provides a connection string that grants full administrative rights, including the ability to send, listen, and manage all event hubs or queues within that namespace. Now, because it provides complete control, this is not recommended for your applications in production, but for the purposes of this demo, we can simply use the shared access key. You need to copy over 2 bits of information, the primary key that's here and the primary connection string. So once you copy these over, save them safely somewhere. We'll need them once we set up stuff at the Fabric end. Step 1 of this demo is complete. We are now ready to move on to step 2. Now, at the Fabric end, we have to have a way to receive the input streaming data and store it in a real-time database. This is the database that our report will query in order to display real-time updated visuals. In the Fabric workspace, make sure you are in the Fabric experience. Notice at the bottom left, it says Fabric. In the Fabric experience, click on the three dots and here you'll find an option for real time. So all of your real time setup will be done in this view. So go ahead and click on that. This is the real time hub and we'll be spending time here in order to build our real time streaming report. Now in our main workspace, click on new item and we'll set up a Fabric Eventhouse. An Eventhouse is a specialized high-performance database within Microsoft Fabric designed to store, manage, and analyze massive volumes of real-time event data. Now, at the core of the Eventhouse is a KQL, Custom Query Language Database. And you'll see that when we set up this Eventhouse. A KQL database is extremely fast for querying time series data like logs, telemetry, and clickstreams. Created our event house here called Looney Event House, and in a moment it will be created. Observe to the left, you can see the KQL database associated with this event house. It has the same name as the event house itself, Looney Event House. The streaming data that we ingest via Azure Event Hubs will be stored here in this KQL database, and we'll run a query on this KQL database and use the results of that query to display our real-time report. This is how the Fabric Event House and Azure's Event Hub work together. Now, the KQL database is a specialized database, but it has familiar structures like tables, views, materialized views, and so on. If you expand it, you'll see that currently we have no tables. That's because we just set up this event house. We haven't populated the database with any data yet. The final destination for our streaming data is this KQL database, which has the same name as the event house. This is where the data will be stored, indexed, and analyzed instantly. Now, why is this destination a KQL database? This is a high-performance, read-optimized engine specifically designed to analyze massive volumes of time series, log, and telemetry data with near-instant query results. The special power of KQL databases comes from automatically indexing unstructured text and semi-structured JSON data on ingestion. And this is what allows for powerful, fast queries without complex setup. It's called a KQL database because it's queried using the Custom Query Language, KQL, which is a powerful and intuitive syntax built for time series analysis, pattern matching, and anomaly detection. This completes step 2 of our real-time streaming demo. We can now move on to step 3, create an event stream and connect to the event house. An event stream is the pipeline that continuously moves our real-time data from the event hub on Azure to the event house on Fabric. So let's switch back to our real-time view. If you click on the 3 dots, go to the real-time hub here, and this is where we can set up an event stream. Our event stream needs to be connected to the Azure Event Hub's data source. And the way you do it is by clicking on Add Data here. And here you can find the different data sources that an event house can connect to. You can see that there is an event stream of stock market data available. You can connect to Fabric Workspace item events. So if the items in your Fabric Workspace changes, you'll get events for those. You can connect to diagnostic logs available on Azure. And if you scroll down here, you'll see the variety of data sources available that you can connect to as the source of your stream. Now, we'll pick Azure Event Hubs. We already have the Event Hub set up on the Azure portal, and we now want to connect to it from the Event House on Microsoft Fabric. This will bring up a dialog allowing you to configure the event stream and set up our connection to the Azure portal's Event Hub. This event stream is literally that, a stream. It's a continuous, unbounded flow of data messages that represent events. These events can be website clicks, financial transactions, or an IoT sensor reading. This sequence of data is ordered by time and has no defined end. That's why it's continuous. Fabric's event stream provides a no-code visual canvas for ingesting and transforming and routing this real-time data. It acts as the central pipeline to capture event streams from various sources, such as Azure Event Hubs. Fabric event streams allow you to operate on data while it's in motion. You can use built-in operations to filter, aggregate, or enrich the data. Finally, the event stream will route this processed data to destinations like our Fabric event house. Our event stream has a name by default, new event stream. Click on the little edit icon right next to that so that you set it up with a meaningful name. I'll just call it Looney Event Stream. Within this event stream, there is a specific stream name, and that's called Looney Event Stream Stream. A little confusing, but you should know that's how it's named. For your event stream, you can either go with the basic configuration. These correspond to the Azure Event Hub configurations, or you can make use of extended features if you want to. These extended features include schema registry support and more. Now, this is where we set up the connection with the data source, which happens to be Azure Event Hubs. If you have an existing connection, you can click on the drop down to select one of the existing connections, but we'll set up a new connection because we haven't set up a connection before. This will bring up the connection settings dialog where you configure the various details of your connection. You need to specify the Event Hub namespace and the name of the Event Hub. So set those up. Our namespace is Looney Event Hub namespace. Our Event Hub is Looney Event Hub. Next, we need to specify the connection credentials. When you create a new connection, you'll need to authenticate the event stream to access the Event Hub, and you do this via the shared access key. The shared access key name and the actual key. This is the primary key that we copied over. Now, why is the shared access key needed? An Event Hub is a secure, independent service. It's actually not connected with the event stream in any way because an event stream can be connected to any data source. By default, an Event Hub rejects all incoming connections. The SAS or the shared access key is the credential that our event stream provides to authenticate itself and prove its identity. The key is also tied to a policy that grants specific rights. For an event stream, it must have the listen permission, but because we've used the root key, it has additional permissions as well. This is not a recommended practice for your production environments, but for the purposes of this demo, this is totally fine. The shared access key is the best way to authenticate yourself. There are other ways as well. If you click on this drop down, you can see that you can use either the shared access key or the organizational account. The organizational account is where you log in with your account to the Azure portal. Now, that's not recommended. Use the shared access key. Next, we have the privacy level. The privacy level that you configure prevents sensitive data from being accidentally folded or sent to an external public data source. Now, we can stick with none, which means ignore privacy levels because this is just a demo and we are not using any sensitive data. When the test connection checkbox is checked, if your Azure Event Hub is enabled for public access, and by default it is, the event stream pipeline will actually test that the connection works. Now with that checked, let's go ahead and click connect. And if there are no errors, it means the connection has been set up successfully to the Azure Event Hub source. There are other details you can configure here, but we leave them to their default values. The consumer group serves as a specific bookmark or view of an event stream for a consuming application. It allows multiple applications to read the same stream of data from an event hub independently at their own pace and from their own position without interfering with each other. When different applications read from the same event stream, you'll generally set them up with different consumer groups. Every event stream is created with a $default consumer group, and the recommendation is to not use this default consumer group, but instead create a separate consumer group for every application that reads from the event hub. For the purpose of our demo, we'll stick with the default consumer group. And then, of course, there is the format of data received from the event hub. We'll stick with the JSON format. Click on Review and Connect. This will allow you a chance to review all of the settings that we've configured so far. You can see that our stream will be created within the workspace that we've been working on so far, Looney Workspace Power BI. Everything looks good. Our stream name is Looney Event Stream. Click on Connect to set up the event stream. Click on Finish, and in a few moments, you'll find that your event stream has been created. Now, where do you find this event stream? Click on Real-Time Hub and your stream should be listed here. I have some other streams here in my other workspace, but the Looney event stream is the one that we just created. At this point, we know that our event stream kind of works, but we haven't tested out the end-to-end flow. Let's fix that. Let's send a new event now that our destination table has been set up and configured correctly. And this event that we'll send should be stored in the destination table, in our stock events table. Go ahead and click on send. Once you've sent this event, you can view events and you'll find that 2 events have been sent to our event hub. The original event that we sent earlier and the new event that we just sent. The original event was used for schema inference when we set up our stock events table, but this new event will be ingested into the table. First, let's take a look at the event stream and make sure this event was received there. Let me select the source first. The data preview shows us that the source, that is our event hub, received 2 events. These are the 2 symbols of the stock and these are the remaining details. Let's see whether the event stream received this data. So we are kind of clicking through the entire pipeline here. Select refresh here in the data preview pane and you can see that the 2 events have now passed through the event stream as well. The event hub source received 2 events. 2 events passed through the event stream. Let's see what was stored in the destination. Click on the Looney Eventhouse destination and hit refresh. And there is the event that we just sent. We've verified that our events can flow from Azure Event Hubs right up to the destination table. Let's head over to the Looney Eventhouse and check our destination table to see indeed if the event is present here. Hit refresh and you can see that the table is no longer empty. It has a single event that has been written out to the table. Now let's run the simplest possible query using the custom query language to view the events in this table. Click on the 3 dots here, select query with code. This will allow us to write KQL queries. I'll just say show any 100 records. This will bring up an interface with a KQL query that views the first 100 records in the stock events table. Stock events pipe take 100. We've sent a single event all the way through to our event house and verified the data flow. Let's send a second event and observe the update just to make sure that everything is working correctly. I like to do things twice in case the first was a fluke. So back to the Azure portal, select send events and it will generate a new event and you can simply hit send here. First, let's make sure that the event passes through the event stream. Head over to Looney event stream and here select the source. The source should now have a total of 3 events. The first one for schema inference and the remaining 2 events for testing. Next, let's click on the event stream itself and you can see that 3 events have flowed through the event stream. So this is great. And finally, let's look at the data in the event house. You'll need to go to data preview and hit refresh and you should find that 2 events have been stored in the destination table. We are now ready to move on to the next step in our demo. We have our event data stored in a KQL database. We can now execute a query on the KQL database and use that to power a real-time streaming report. This is different from our regular Power BI reports. You can see I'm in the Looney event house. This is where our destination stock events table is present within our KQL database. At the top of the screen, you'll find an option to set up a real-time dashboard. Go ahead and select this option. You'll be asked to specify the name of the dashboard. I'm just going to call it real-time stock prices dashboard and click on create. By default, a real-time dashboard will set up a single streaming tile. So the individual visuals in the dashboard are referred to as tiles. And this tile just displays all of the events that were received so far in the destination table. Now this is not the view that I want. So you can go ahead and get rid of this tile. Click on the 3 dots and there's an option here under tile options to delete this tile. Select the delete option and this tile will be removed and we can now add a tile and have our own query powering our streaming dashboard tile. Add tile will bring up the query interface on our KQL database and here you can write any custom query and the result of that custom query will be displayed in that tile. This query here is written using the Custo query language. Now, I won't go into the details of this language, but you can see that a basic query starts off with the table that you want to query, that's stock events. Then we use the pipe operator to specify what we want to do with the data in that table. Price underscore value gets the price information from a nested JSON field and converts it to a double. Summarize then performs an aggregation on the price. We compute the average price by symbol, and then we order in the descending order of average price. This will group the data based on symbol and compute the average price for each symbol. We have events corresponding to two symbols here, and you can see the average price displayed. And once you hit apply changes, the same information will be displayed within a tile in your dashboard, and this will be updated in real time. Now, if you want to view this not as raw data but as a bar chart, you can click on Explore Data and pick the visualization that you want to use to view this information. I'm going to set up a column chart, that is a vertical bar chart. Here is the same average price by symbol information displayed in the form of a bar chart. Let's go ahead and save this to our current dashboard. I've selected in this dashboard and I have a tile name, average price per stock. Click on create, and our real-time dashboard now has two tiles, one with raw data and another with a bar chart. And this brings us to the very last step in this demo, where we test real-time updates. We'll send multiple streaming events to Azure Event Hub and watch our real-time dashboard update in, well, real time. So this is quite exciting. We need to head over to the Fabric portal first. We have our tile set up in the dashboard as you see here on screen. Here is our event hub here in the Fabric portal. Click on send events, and instead of sending just one event from the stock data sample dataset, I'm going to send multiple events. And you can do this by checking this checkbox that says repeat send. Repeat send will allow you to configure how many events you want to send and at what time intervals. So rather than sending a single message at a time, this will actually mimic a real streaming source. My configuration says repeat send count 10, so send 10 messages, and the interval between the messages should be 3000 milliseconds, so 3 seconds between messages. Click on send, and let's quickly go to our real-time dashboard and hit refresh, and you can see the messages streaming in. We now have a total of 5 events, and as you hit refresh, more and more events stream in. You can see the raw events on the left, the average price per stock symbol, and you can see the bar chart update on the right. Let's hit refresh once again, and you can see all of the events have now been received. The bar chart as well as our raw table has been updated in real time. And this is our streaming real-time dashboard, powered by a Custo query language query running on a KQL database housed within a Fabric event house. Our Fabric event house is connected via a data stream to our data source, that is our Azure Event Hub. Before we test the connection from event hubs in Azure to the event house in Fabric, there's still a bit of configuration that we need to set up for our stream. Click through to this Looney Eventstream stream. Here we have a stream connected to our data source. Click on Open Eventstream and you'll get a nice visual canvas showing you how the data source is connected to the destination. You can see there are 3 components in our stream. There is the source, there is the stream itself, and there is the box for the destination. Observe that the box for the destination is empty, and you can see the little message that says switch to edit mode to transform the event or add destination. We need to be able to edit this event stream, so click on the edit option here at the top right. This is the visual canvas of the event stream, and you can use this to add real-time transformations on your event data, so your data will be transformed before it's stored at the final destination. Now, I'm not going to apply any transformations to the data, but we do need to configure a destination. Right now in the canvas, I have the Looney event stream selected, and you can see the details of this event stream in the pane here at the bottom. The data type that this event stream will process will be in the JSON format, and show data from the last hour. You can of course configure this. There's no data in the stream yet. That's why there is no data to preview. Let's move on to the important business of configuring a destination for our stream. Where will the events be stored? Remember that the stream can perform transformations on the data as well. In the dropdown, you can see all of the different transforms that you can perform on the data. You can aggregate data, you can filter events, you can perform grouping operations, you can join two streams together, you can perform union operations, and so on and so forth. Now, what we're interested in is configuring a destination and choose Eventhouse here as the option. We want our streamed data to be stored in an Eventhouse so we can build a real-time report using that data. There are some details you need to specify here about the destination. Let me configure those details and I'll walk you through them. The first thing is the data ingestion mode. Now, direct ingestion means that you're not transforming the data before it's ingested into the KQL database. And so this is the right choice for us. We're not going to apply any data transformations because we'll be working with some sample data that doesn't require much processing. If you did want to perform some processing on your events, you choose the event processing before ingestion option. You also need to specify the name of the destination. I've just called it Looney Eventhouse Destination in the workspace Looney Workspace Power BI. You will then be asked to select the event house where the final process data should be stored. That's the Looney event house that we set up earlier. Once we've selected the event house, the next step is to select the KQL database within that event house. Our KQL database has the same name as the event house. Just go ahead and select that. Once we save this, we've successfully configured the destination for our event stream. So data should come from the source, pass through the event stream, and land at our destination. In order to set up this connection completely, we need to publish our event stream. So go ahead and click on the publish button. Wait for a few moments till publish is complete and you'll find that there's yet another bit of configuration that we need to specify. Notice the little message that says KQL data stream was not configured or already deleted. And the status says unconfigured. And you can see the little box representing the destination. It's in an orangish brownish color and it has a configure button. So there is still some configuration that we have to do. Let's find out what that is. Click on the configure button and it will walk you through the last set of configuration steps. You need to create a table in the destination database where your data will be stored. We don't have any tables in our destination. So I'll create a new one called stock events because the kind of streaming data that I'm going to stream into this table will be some sample stock market data. There's a default name for this data connection, which we'll just accept. Click on next. Now, this is where the schema of the input data is inferred. Now, since we haven't sent any data via this event stream yet, this event stream cannot infer the schema. Now, you cannot complete this setup unless you actually have data in the event stream and you infer the schema of that data. This means we'll have to send some data from the event hub source all the way through to the Fabric event house so that we have some data in the stream that can be inferred by the event stream. This takes us to step 4 of our demo where we send a sample event from Azure Event Hub and that will allow us to infer the schema of the event when we configure the destination here in the event stream. We need to head back to the Azure portal for this and in our Event Hub, click on Data Explorer off to the left. The Data Explorer is a simple in-portal tool that lets you send test messages to an event hub or peek at events streaming through it. It's not a full-scale analytics service. We'll use the Data Explorer to send a single event to the event hub, and this will pass through the event stream and will be available for inference at the destination of the event stream. When you click on Send Events, you'll find that there are a number of sample events that you can send to the Azure Event Hub. Just pick from one of these sample events. I'm going to pick this stocks data. You can see the JSON structure of a sample event right here. It has a symbol, price, volume, market cap, etc. This is the event that we'll be sending. Every event carries along with it some system properties. So you can expand this section and see what the system properties are, a message ID and a correlation ID and some custom properties. We won't worry about these. Just click on send and we've sent the first event to our event hub. Click on View Events here and you'll be able to view the event that we've just sent, a single message in the JSON format. You have all the metadata information and the actual event body. This is the actual message with the stock event information. If our connections have been set up correctly, we should be receiving this at the destination and we should be able to use this to infer the schema. Let's go ahead and hit retry here and you can see that single message is now available here at the destination. And using the single message, the KQL table at the destination was able to infer the schema of the incoming events. And because the schema has been inferred, we are allowed to finish the configuration of our Eventhouse destination. So our destination table stock events was created, a mapping was set up to infer the schema from the source. We can now close this dialog and take a look at our event stream once again. Our event stream is all in green, it's completely set up. You can now click on every component of the event stream and view additional details of the component here at the bottom. This is the source, the Azure Event Hub that we are connected to. You can see a preview of the data that we received from the Event Hub here. It says no data to preview, but there should be data here. It's just not updated yet. We'll come back and refresh this in a bit. The Data Insights section gives you a graphical representation of the events received. So you can see the number of events here, and one event was received very recently. That's the test event that we sent to actually configure the schema of our destination table. Let's take a look at the details of the other components. Select the actual event stream itself. We've already seen the data preview that contains our data type JSON. Let's look at data insights, and the little spike in the graph shows you that a single message has been received. You can look at the input and the output. 454 bytes were received, number of incoming messages 1, outgoing bytes 496 and outgoing messages 1. The additional bytes come from some kind of metadata the event stream might have added. Now let's look at the last component here, our Eventhouse destination. The status is active. Let's look at the data preview, and right now, no events have been received by the Eventhouse destination. Now at this point, the single event that was sent was used for schema inference purposes. When you click through and open up the custo item and select the stock events table, you'll find that this table is currently empty. There are no events stored in this table. The very first event that we sent to the Azure Event Hub was used for schema inference of our destination table. That event is not actually stored in the destination table. At this point, we know that the connection from Azure Eventhouse to the event stream works, but we haven't verified this entire event flow end to end. We need to ensure that the event is finally stored in the destination table. That's what we'll do next.